One, two, three. One, two, three. Okay. Good morning, everyone. Let's see if you're able to start. Should we start?
Two, three, one, two. Okay. Yes, I can hear myself. Good morning, everybody. Is it loud enough for everyone to wake up? Okay. Okay, I'm very happy to welcome you during our second day of the Automotive Functional Safety Forum 2025. I hope you enjoyed the first day and had a restful night. Just as a kind reminder, our sponsor today is SGS Tuvsar. Just like yesterday, let me share a few organizational remarks with you. Coffee breaks will be held in the same location as yesterday, in the hall right outside. Lunch will be served in the same room as the breakfast, behind the glass door. Restrooms are located on the right in the end of the hallway. In case of emergency, please follow the green exit signs. I would like to remind you that we also appreciate your opinion a lot. So evaluation forms, please fill out the evaluation forms and hand it to me or my colleague at the registration desk, or if you see any team member. And also, if you have anything you'd like to discuss with us, feel free to talk to us, or to my colleague or me. That's all from my side. Our chairman today is Riccardo Vincelli.
Okay.
Riccardo, the floor is yours.
Yeah, please vote for me. So, welcome to again our group therapy of the functional safety. Hopefully, you had a great evening yesterday after the conference. Yeah, so today again is a long day. I know that some of you guys also have a flight to take, also me. So we need to try to be on time, or if you're able a few minutes earlier, let's see. But yeah, today will be interesting, and I think no single presentation will be less important, especially also the panel attend will be very interesting for the future. So please try to stay with us. Yes, and I don't want to take too much of the time here, so I think we should already get started and we can talk during the breaks and lunch. Yeah, I would like to invite here on stage Anna Maria Ulrek. Is it okay, Ulrek? Yes? Organization Functional Safety and Cybersecurity Manager at the NXP Semiconductor. And also functional safety experience since 15 years, so dealing with functional safety in different roles, and also software safety assessor, I see. So please.
Thank you very much, Riccardo. Hello, everyone. Welcome to our second day of conference. I'm happy to kick it off with a topic about harmonization of functional safety and cybersecurity. Yes. Okay. Then from the beginning. Hello, everyone. Good morning. I'm happy to see you and to be here. Let's kick off the second day with a topic about harmonization of functional safety and cybersecurity. So some words about me. I'm working at NXP. I'm having now the role of Organization Functional Safety and Cybersecurity Manager. The last part is something new. I added this year because we saw a need to extend the focus of my team. In NXP since 9 years, a journey in different safety teams and safety roles, from hardware development to software safety assessments, and now on the software side, on the engineering. Okay, so If you don't know, we at NXP, what we do is to develop technology. We focus on different markets. So it's automotive, industrial, edge, mobile, smart home. So what we wish is to improve the world, to make it more automated, smarter, safer, and secure. So that is what we focus on. In the software organization, what we do is software components, because yes, we are a tier 2. And from the safety point of view, we apply this safety element out of context. The same for cybersecurity. With our experience, more than 70 years, the portfolio focuses on safety libraries, safety framework, enablement products like the drivers. So we are below the RTE. We also have the security firmware, which we will discuss today. So we want to do more and more of the integration. That's why also the NXP core, right? So what we work on, basically to enable our customers to take on our shoulders the burden of the integration, because we are aware it's not something easy to do. And yes, among these efficiency drivers, what we observed during the time is also this harmonization, what we will discuss today. So in my talk, yes, I will cover these topics. If functional safety ever meets cybersecurity, it's a little ironic. It's not about one thing, but we observe that it's something we have to do because somehow these two areas coexist in the end product. Also, we will look at some exchange points we identified, and also, of course, the challenges, because nothing comes for free. And I will present you the holistic approach I initiated at our level, so at the business line in the software organization. And finally, we will have a case study about the STPA we applied on our security firmware, which also has safety aspects, so high-level safety requirements. Okay, so these two words, functional safety and cybersecurity, as I think you know, they come with a different mindset. So one focuses on preventing the hazard, preventing the failure modes, finding ways to keep the functionality alive, while the other one is rather about the dynamic response and how to prevent the attacks. So the focus on one side is on protecting the person, and on the other side is the protection of the assets, the secrets, and making the system trustworthiness. Now, while functional safety is a little more conservative when it comes to adopting new tools or innovations, cybersecurity is rather faster into this direction. And the faster they adopt this, also the new cryptographic algorithms or tools for this, we are those with the brake pushed. So no, wait a second, we need to see what is behind that, what can be the impact. What both areas have in common is this value for the risk management and the compliance for the standards, right? Because each of the areas have their own collections, and the continuous improvement. And we know that at the system level, safety and security, they come together. And then the cyber attacks can compromise the safety critical functions. So that is the point where we understood that, okay, we cannot let cybersecurity aside as it was historically, but we need to, embrace it and see how we can bring them together. This whole journey started some years ago. Initially, it was like an innovation topic. So while we were thinking what we can do better for functional safety, one of the points we thought of was, okay, but let's see how we can bring maybe safety and security together. And during this working group, we did an analysis. So it was spread over a full year. And we saw that, okay, if, for example, the security properties, for us, the safety guys, it was enough the availability, the integrity of the data. For them, also the confidentiality and the authenticity is important. So here already a flavor we were not aware of. Then what is happening at the startup, how we declare, right, the safe context. They accept this only by instances which are trusted by them. So, for example, the bootloader, but these cannot be changed after that. So, also the control of the sensors. Right, we rely on the external power monitoring and the external clock. That for the cybersecurity people is not so well embraced or received because they don't know who can control that, right? Any external software can be an untrusted source. The same for the reaction time. Okay, we have the FTTI, we have the FDTI. They don't have these numbers, but they want to be fast, so as fast as possible. And here, a conflict we saw was about the reset for the security. The reset is the first measure. So if they feel attacked or if they feel in danger or that the assets are endangered, then reset is the way to go. And then for us, for safety, okay, but before we do the reset, we need to collect the data, collect the faults, inform the application. So that takes time. And for them, this time means uncertainty. What if someone can steal the assets? And for another point here, yes, test of the safety mechanism, right? We have the fault injection, which we do for the diagnostic coverage demonstration. We also run some of these tests during the runtime, and their concern is, what do you do if the test fails, right? How do we know that our assets are not endangered? So these were observations. Also from the technical and architectural point of view, right? The security subsystem in our microcontrollers is compact, I would say, so in one subsystem, whereas our safety mechanisms are distributed across the microcontroller. So also this shows, right, the mindset. Where do we come from? And where they come from. I still say they, because the adoption is fresh. And yeah. So while doing this harmonization, we faced some challenges. Maybe also a point about the motivation. Why wasn't it good enough to stay like this, or what pushed us to look into this topic? Besides that innovation trigger, also the customers asked us, can't we use your security firmware in safety critical applications? And initially our answer was, no, better not, because we don't know what it is there. And they insisted, so that triggered, right, for us a retrofit initially, and then further developments which are safety compliant for the security firmware. And then also the compliance, right, with the standard, because also as a global request, all the safety software products shall be compliant with ISO 21434. And then we saw that, good, it's easy to say, let's put the things together, but harder to do. And then, as I said, from the requirements point of view, there might be conflict. So it is crucial that the safety architect is involved in the review of the security concept. And the other way around, because it needs to be a handshake during the definition phase. Then, okay, the standards, they come with their requirements. Still, the cybersecurity standard, as we saw, relies a lot or references the ISO 26262. So that was for us a motivation that, okay, we can leverage the learnings and the practices we have for safety also in the security development. And then the homework for us was to harmonize the processes. But that is something we could do only at our level, because in NXP we have the BCAM process, which has the layers for the different functionalities. So functional safety is one process, quite solid, I would say. The same for cybersecurity. And then at the business line level, where me and the team are, what we did was to build a layer where we select and further detail the requirements for our software projects. Then another challenge was this technical complexity I was talking about. So there are still some points and some decisions which need to be revisited. The timing, the reactions in case of fault, and these things. And then from the roles and responsibilities point of view, the teams were organized such that they were different. So in the NXP, we have competence centers for functional safety, one competence center for cybersecurity and security, another one. So somehow the people were used to work like this. And then in the projects, okay, we come together and somehow that product needs to cover both cybersecurity and functional safety. It's not an or, it's not a wish. And also the responsibility sharing, right? How we cannot ask the safety guy to be responsible for the cybersecurity if he or she doesn't have the knowledge, doesn't have the enough insight to judge this. And then the holistic approach we propose together is, like I said, at the business line level, we consolidated or we defined this combined process to make sure that we don't have deviations from the BCAMs, from the upper layer, but to bring together this functional safety and cybersecurity from the methodology point of view. And also from the roles, we extended the scope of the project functional safety manager to cover also the cybersecurity aspects. The integration and the adoption of the SAFE, the Scaled Agile framework, helped a little because now we work in art in these agile release trains, and we want or not, the people work, they come closer. So that was also the opportunity we took. Then at the work product level, we started to combine what we have in the PMP with the safety plan and also with the cybersecurity plan. And the same at the end, in the moment we collect the deliverables, we bring them together. Then analysis. Here is something we introduced and we proposed for adoption is the STPA, because we saw that there we can treat both. So instead of doing the software FMEA or the and the DFA for software and the TARA for cybersecurity, we saw here an opportunity to analyze these two areas in one single analysis. Yes, and then all these aspects and the proposal was well received by also by the management team. It was accepted also as an efficiency driver because somehow extending the role, and also combining them or benefiting together by what we call supporting processes was seen as an efficiency driver, yes, and well received. So it is something for which we have the support. Okay, so as I said earlier, at the business line level, coming from two silos, I would say, from the process, from the team's point of view, what we do is to bring together there in that in the middle, to find the middle ground, right, for these two areas, safety and cybersecurity, by means of roles, deliverables, analysis, which we started to do together, of course, without jeopardizing the compliance, because at the end, with all these changes or harmonizations we drive, we want to be able to say, yes, this software release is compliant with both standards. And then, of course, the adoption is something in progress. So don't get the idea that yes, we are done. But we have pilot projects where we do this, and then also for the cybersecurity inside NXP, we have different levels, and then depending on the risk associated with certain assets, we say that, okay, some are more secure, we have the edge lock levels, or some are less. And then this deployment of the harmonization started from the lowest level. It's something we call minimum security guideline. And then for this one, it was very good received because the project teams felt that we support them and we help them with this new compliance. I wouldn't call it burden, but I think it felt like this for them. And then in the moment they heard, the PFSM will take over also the cybersecurity. Okay, yeah, good. Then tell us what do we need to do? So that was an advantage. So we made use of this. Okay. And then the case study I would like to quickly show you is this STPA we did for the security firmware. And then we start this during the concept, so when the definition is done. This is not different than what we do, the software FMEA or the TARA. It's the same, we do this at the same development stage. But as I said, the advantage we saw with this analysis is that we can treat them together or analyze them in the same time, in the same analysis. And then you will see in the next slide, we identify these the threats, the unsafe control actions, and then the mechanisms. Okay, what can we do to avoid that, or what are the security controls we can bring? And then finally, at the end, during the verification, we will have combined the scenarios to cover both functional safety and cybersecurity. For safety, we still do, of course, fault injection done by the development teams. And then for security, we have the pen testing done by the independent team from CTO. Okay, and then here, a snapshot of the analysis. I only selected one or two points, is to give you an idea of how this would look like at our level, at the firmware level, right? Because this is an analysis done for, Nancy said, at the systems or vehicles level. And then for us, it was quite challenging to reduce the scope so that we can still model that the firmware, right? Firmware and the microcontroller. And then the loss, one of the losses we identified was this, that the secret keys and the signatures will get exposed to unauthorized systems. And then the firmware, if this happens, then the firmware can accept and install a firmware image which is not securely authenticated. And then we also come into discussion, the safety guys, because this is something we want to avoid, right? In the moment we declare this safe context, we want this to be declared on right premises. And then after we did this modeling, we identified these unsafe control actions. And one of them was that the firmware will start, okay, so we'll go through the startup, declare the safe context without validating the configuration integrity. And then that is again something which can jeopardize our high-level safety requirements. So that was from my side. I don't have a conclusion because it is work in progress. So I wouldn't say we are done with the harmonization, but it is rather a point I wanted to share with you, what we started to do. And yeah, so the message is there are benefits, there are also challenges. It doesn't come for free. And then it depends, right, if the market and the customers see a benefit in this. Thank you.
Okay. Yeah, I think it's still okay to show that we have challenges, we are working on this, and I mean, that's the key point, also to be here and share what everyone else feels. First question here. Can we get a microphone?
Central Functional Safety and Cybersecurity Manager from Sensata Technologies. It's a nice presentation. So we are also facing the same challenges like integrating functional safety and cybersecurity. The question is, do you consider all functional safety specific software development or software component as cyber relevant, or is it changes case by case?
Yeah, so what we do at the beginning of the development is a security quick scan. And there, if there are real assets to protect, then we say, yes, this is security relevant, and that will imply also real security requirements. It's not the case. Besides this security firmware, all the rest, as I say, come with this minimum security guideline. And this was our way to serve the request from the customers, because they asked us, okay, what do you do for the compliance for ISO 21434? So there is a difference in the products which have security features, like the security firmware, right, which is the attached software for the security subsystem, and the other ones, which for those we rather do the needed to enable their integration into the system, like we would do for safety, this freedom from interference.
Okay, Thank you.
Thank you.
More questions? One here.
Hi, I'm Helen from ARM. I love that. I think this is what we all should do. I wanted to ask you what you think about combined assessment, safety, security, maybe also quality, and also if you have any measurable, KPIs which can be applied to this process. Like, for example, if this approach increased competence, saved time, saved money.
Yes. About combining the assessments, that's a tough question because now we do these independent reviews with the competence centers, and then safety team is on one side, security on the other side. So there I wouldn't. I think it is too early. And with this harmonization and with the developments we do, what I want is to gain the trust, right, of the business, and then to go further. That would be a bigger step to start to combine them. What we could do is at the project level, these verification reviews. There for sure, because in the moment we have the PFSM extended also with the cybersecurity responsibility, right? Implicitly in their checklist, they will add also the questions relevant for the cybersecurity aspects. Yes, but that is still at the project level. So the assessments are something bigger, yes. And then about KPIs, no, not yet. I could think of the existing KPIs. Well, okay, how many releases we got out, clean releases, or how many waivers, how many gates were blocked by one of the areas, right? Because another point in the project board, in the review board, we have representation. I mean, it's me who represent both safety and security. And with this, I do my best to explain what are the risks if the project board decides to move on with the current gaps or not. Yes.
Thank you.
Yeah, but I think it is interaction, safety and security is a big topic now. If you are interested in IEEE P20A51.2, we are trying now to establish exactly what do we need to exchange, what is the intersection point, and yeah, I mean, we see many companies are dealing with safety, are dealing with security, but the connection is usually through the customer.
Yes, that is not helping.
Yeah, so
because we just put the burden on the customer's shoulders.
Right.
We could do more on our side, yes.
Right, and instead, I mean, especially now from the second edition of the ISO standard, we said when you're doing safety, when doing also assessment, you should judge risk related to security. So that's now is something we cannot avoid, we cannot push, especially if you're doing SEOC.
Yes.
Okay, many thanks.
Thank you.
Okay, let's see if we get a bit more insight into this topic. Now we have Francesco De Rosa. He's a head of functional safety and cybersecurity. So that is nice to have to see a role that is combining the two at ART Germany. He's also 15 years experience on functional safety and a member of the ISO working group as well. So any questions on the ISO, please ask. Please.
Hello, thank you for the presentation and thank you everyone. So as presented by Riccardo, I am in ART Germany as head of the functional safety and cybersecurity department. Let me to start to present ART, our company, our headquarters that probably you don't know or some of you don't know. We are an Italian company that is in the middle of Italy, near Perugia, and we are a tier one, mainly for automotive focus, for luxury car, but also we have some products for mobility, for railway, and also for defense and aerospace in this phase. We cover all the aspects of the life cycle, from the requirement from our customers, or we define some requirements for our platforms to the manufacturing. Here, it's not the town where we are, but it's our factory, so it's a very strange company. And we have a competence center in Germany that I lead, that is in Berlin, the office that is specific for functional safety and cybersecurity. Because the idea of our company is that, of course, functional safety and cybersecurity are central activities for embedded system and strongly for automotive, and to have a specific competence center, also physically separated, but mostly organization separated, to increase this type of competence. And we act as a competence center in a, let me say, a dynamic way. We are like a tier 1 or tier 2 for art. So we provide also service for external companies, and we work as an external, mainly technical assessor. We are not a conformity assessor, accredited assessor, but we are a technical assessor. And then we have all the activities that we can cover. Let's start with a topic that is quite similar to the previous presenter. What are the strong point, common point between functional safety, and what are the differences between functional safety and cybersecurity? I like to start with the definition, because are just definition, but I think that are helpful to have a first identification. Functional safety, this is the definition of the standard, is absence of a reasonable risk. Cybersecurity is the assets are sufficiently protected. So in both the definition, we can say one point, that both the discipline are risk-based approach. In both the discipline, we are analyzing and we are managing a risk. That means that the effect of bots, it's not visible in a short time. We are not at the end of the functional safety and cybersecurity activities. The result will not be a product that works or not works, but something that is visible in long or medium term. So I like to say that if functional safety and cybersecurity engineer perform a good job, his job is not visible because we don't have accident or problem on the field. And this is very important, and it's real for bots. And one of the common points that we have in the internal discussion, for example, when we have onboard discussion with the other managers. And bots are relevant for the liability of the company, and also for the image of the company, because you can know that in case of accident, functional safety, cybersecurity accident, there is the media are involved and can have a direct impact or big company and also small company. That are the commonalities, high-level commonalities. From differences, we have a different approach about the threat scenario and the failure that we consider. Functional safety mostly are considered internal fault and failure, mostly because it's also considered an external environment, but the main focus are to internal failure. About cybersecurity, we consider the external attacks. In terms of regulation, functional safety up to now is only relevant for liability. Instead, cybersecurity for automotive is also relevant for homologation. It's a different, the perspective for functional safety. We have road users that are impacted, where road user here, I mean all the persons that are on the road user, bystander, pedestrian. From cybersecurity, we have different stakeholders. And then there is the last difference, but I think that is one of the most important. We have two different standards. That means, and we are in the two standards, especially in 2144, that the same concept in some cases is defined, is explained with different words, with different work product. And these, for me, my personal opinion, create some extra work that could be reduced. Okay, so starting from the definition, starting from the element that we have from the definition, we can see what are the three pillars for us about the functional safety and cybersecurity. That are the process, the risk assessment, risk management, and risk assessment, and technical concept. And the background that this is the culture. The culture, why? The culture, and let me to explain why this concept for these are the pillar for us. The culture, because it's not tangible activities are short term. So that means that without culture, it's not possible to perform a good safety and a good cyber. We can create all the checklists, we can perform all the review, all the assessment, but if the software engineer not perform a good writing of the code, think about the functional safety and cybersecurity, the issue will remain here, and in one moment it will appear. The process, because we have liability, so we can have a product that is very safe or very cyber, but it's also needed that we have a robust process and robust evidence when the issue will happen, if happen, of course. And then we have the risk assessment and technical concept. Let's to start with the risk assessment to see, I will present some specific and real differences that we have in the day-by-day. Risk assessment, we have two different standards, as said before by our colleague. Functional safety is one of the aspects of the cybersecurity, both consider impact and feasibility, so probability for impact, but with a different parameter. And as you can see here, the cyber consider the safety as one of the elements to consider to calculate the impact. And then we have two different scores, but it's not so relevant. So we have one difference. In the functional safety, the severity is just for the impact. In the cyber, the severity is one of the elements of the impact. And this can create a misalignment between the two evaluation. We have, for example, or we had, now we are resolving this, some products that were not safety relevant, QM, but with cybersecurity impact for the safety. That is a misalignment, but this is possible because the standard perform a different calculation, and it's possible. It's a real case. I don't report an example, but this the severity of our subsystem is S3, that is maximum level. The cybersecurity impact will be yes, but we can, with a good controllability, a good exposure, we can have QM. So this is the first case of misalignment that create a lot of workload and a lot of problems in the management in our product. We tried with our customer, OEM, to identify some solution, and now we have two solutions that I will share with you. One is very simple, not to use the severity for the calculation of the impact of the safety, but the hassle. In this way, we have, if a product is hassle B, we have a safety impact that is medium. If hassle D is a safety impact that is high. This is very good in terms of efficiency because we have one parameter that shall be shared between functional safety and cybersecurity to have an alignment between the two disciplines. But there is a risk of effectiveness for a practical case. The practical case is that when the attacker think and perform the attack on the products, he also can consider when he or she has to perform the attack. So that means that when we consider the three parameters, severity, controllability, and exposure, it's quite probable, or it's at least possible, that the attacker will perform the attack in the best moment for the exposure. Let me to explain this with an example. If the attacker wanted to create a misbehavior of the lights of the car, he will perform the attack on the night, not on the day. So that means in this approach that is very good, very efficient, because it's one parameter that has to be moved from one element to another, as a technical gap that is the exposure is not considered. There is another approach that in some cases is possible. In other cases, it's more complex to apply. That is and I think that the new 2144 is at least oriented to apply this approach according with the last meeting, is to divide the elements from OEM perspective, or user perspective, vehicle perspective, and architectural perspective, tier 1. So now we are tier 1, and these parameters, access time, window of opportunity, are specific of the architecture. So it's good and it's correct that the tier 1 or the component lead perform this type of analysis. The other parameters are the risk that the final user can take. So that means that this parameter is correct that are evaluated by the OEM or by the vehicle integrator. In this approach, we have a fully alignment between functional safety and cybersecurity in terms of risk assessment. And also we have a collaboration because in this case, we can solve two issues. One is the alignment between risk assessment of FUSA and cyber. And from other side, we have alignment of the risk assessment of the vehicle and risk assessment of the tier 1. Because in the cyber, we have two risk assessment, vehicle point of view and tier 1 point of view, and often are misaligned. Okay, then this is in terms of risk assessment, and this is the first case of differences, and how one can be different from the other one. Then we have the safety measure can impact on the cybersecurity. This is an example. for the functional safety, it's needed, or it's quite probable that we have a safe state. So we are creating an element, some element, the red element, that can be used by a potential attack to create impact on the operational of our component. So we are increase the surface of attack for attacker. From other side, we have also the cybersecurity can impact on the functional safety. For example, we have a cryptography that is quite needed for the cybersecurity. Cryptography, of course, is a complex, require a lot of power of our control unit. This increase the latency. That means, in other words, that increase the fault reaction time of our real-time subsystem. So we have practical cases how we can try to perform this with a concept that is common for functional safety and cybersecurity. So this is, we say that the TARA is performed at OEM level, the tier one not perform the TARA. In terms of HARA. In terms of the TARA, the OEM define the cybersecurity impact, and then we perform as a tier one the TARA, and then we tried to commonize the process from that point of view. So here we have a single concept where there are the requirements of functional safety and cybersecurity in a single point, and we have a single interface. So we have a single functional safety and cybersecurity expert that define the general principle, and then we have the specific expert that go in detail about secure boot or about fault reaction time. This is an example for that we can apply for the FMEA. This is just an example. We can consider that the external attack as external failure. This is a simplification, not want to be a specific example, but we can consider internal failure of the component as a specific failure, and then we can create a model where the external attack are treated as external failure. Then the effect of the fault and the failure is analyzed. We verify what is the impact on the safety and security goal if there is impact. We verify the effectiveness of existing safety and security measure in the technical and security requirement. And if there are no sufficient measure, we can create a new measure. And that new measure are evaluated to verify if they have an impact on the existing safety and security goals. So we have a closed loop. This, for example, if we consider the example of mentioned before about the cryptography that can have an impact on the functional safety in terms of timing, a possible solution, very simplified, is to have a partitioning between the user data, the not relevant data, and the sensitive data. In this way, the cryptography will impact only one part and will not impact the latency of the safety data. This is how the process will be strongly modified. In blue, there is functional safety. In green, there is the cybersecurity. That three blocks are common. So we arrive at the functional safety concept and cybersecurity goal that are in two different paths. Then we have cybersecurity and functional safety technical concept, implementation, and also verification at low level that are common by the same person. The same is not possible on the right way of the V-cycle, because the testing methods and also the methodology and also the skill to perform the testing are very different. In one case, we have a penetration test. In other case, we have fault injection test. Conceptual can be also the same, but at the moment, it's too early for us to perform the same, two different skills. And then at the end, and this way I will conclude, there is the final part that is very, very different. That is continual monitoring that is specific for cybersecurity. Yesterday, in one speech, someone presented the concept of continual monitoring of the safety. That is a good concept, but it's something that usually is not used by a lot of companies, and is also not required by the standard. And here we can see, I think one other important difference between the two disciplines, and at the moment there are no I don't see that in short time this gap will be aligned. In functional safety, we have a hardware metric and measure like diagnostic coverage. You know, we have in general we have 4 levels from ASIL-A to ASIL-D, and that is calculated in the HARA. And based on the ASIL, we have a different type of measure, different robustness of the process. This approach is not applied for 21434 in the cybersecurity. I know that there is the CAL approach, but it's not really used in the CAL approach. It cannot also be used because it's very different to connect the code. And also based on the last meeting of ISO 21444 working group, I don't think that will be developed. So this is an important difference that, for my personal opinion, I don't see any point to contact in the next year. Functional safety has a different level for threshold, A, B, C, D. The cybersecurity is more black and white, all or nothing. If there is a risk for a cybersecurity guy, it shall be resolved. It shall be not door open or something. This is a conceptual cultural difference that I don't think that will be solved. And then there is continual monitoring. As I said before by our colleague, the cybersecurity is is speed up a lot compared to the functional safety. Why? Because there is an attacker, and the attacker want to enter in our products, and I will say that he or she has an advantage that there is no regulation, not process that he or she has to be applied. If he has an idea or he or she has an idea, he can apply. So that means that the attack increase day by day, year by year. And here you can see what means increase. There are the CVE, the vulnerability that are in the NIST database, and in the last 20 years, there is an increase of 800%. But also in the last part, you can see that the increase is more or less of 300%. So there is an increase day by day. And this is another important difference that I like to see in this way. When there is the safety case, more or less the functional safety guys can go in holiday because he closed its activity, and if the safety case is good. Because the risks have been evaluated, have been managed, and then there are no new risk. Can happen, but it's an error. For the cybersecurity, it starts to the activity, because it's the moment where the attacker can attack and can create new attacks that can be also applicable for the previous components. So that means that when a cybersecurity component is put on the field, we have also to think our product for the next 5 or 10 years to update, or for some measures that today are not applicable. So let me to close my speech with the summary. Bots, the commonalities of the two disciplines, and bots require a robust process and a culture, because this is the background. Otherwise, nothing is possible, because the impact are visible only at medium and long term. So there are challenges and differences that are about the risk evaluation that are different, and then there are the measures that can impact one and the other discipline, and we can identify some solution. And the strength is that we can identify common measures for functional safety and cybersecurity, and the fact to have one team, one organization, or just one point of contact can be helpful for increase the culture for both of the discipline. Thanks. Questions?
Functional Safety and Cybersecurity Manager from Sensata Technologies. It's a nice presentation. A quick question about the cyber issues. Do you consider the cyber failure in FMEA? Because usually we do it in Tara. So
They're starting to consider cyber failure within.
Oh, sorry. Can you talk to Mike?
okay.
Yes, we are starting to consider. We are modeling the attacks the possible attacks as a external failure on the interface, or also internal fail by considering the physical attacks. So we are trying to use this type of approach. So we consider the attack as a failure, and then we consider the impacts.
Okay, thank you.
You're welcome.
Again, I would like to give opportunity online. I'll try again to see if someone is willing to share some questions.
Roman Chamian from ZF. I'm interested, you said that you have a common workflow somehow, but I was also wondering if the roles are different. So do you have cybersecurity experts and safety experts, or do you have a combined role like safety and cybersecurity expert?
Okay, now we are trying to use this model. We have functional safety and cybersecurity project. Of course, this is relevant when we have a project that is FUSA relevant and cyber relevant, otherwise it's not needed. What we try to do is to have one single project functional safety and cybersecurity manager, so that is responsible of the functional safety and cybersecurity in terms of project management. Project means to evaluate the risk, to consider the risk. And then we have the expert matters, because secure boot is an expert matter. But also if we consider functional safety, now it's quite simple to consider the functional safety as a one single discipline, but the expert of the hardware of the functional safety is very different aspect of the software of the discipline. So we have, in terms of project, one single focal point, and then we have the expert matters that are a single expert matter. For example, for the software, we have a single software matter that for functional safety and cybersecurity. You're welcome.
Okay, maybe last question.
Thank you. Luz Garcia from Ebusco. Really nice presentation, and I want to say that I think is from the OEM perspective what we are looking for, a combined approach. I have a question regarding the technical concept. You have here a combined approach. Which is the OEM reaction to this solution from your side?
Okay, it depends. So we have, okay, it depends also cultural point, if it's more open to have something that is flexible or not is less flexible. I will say that to very frank, one OEM, no, was not possible to have a single document. But for the other OEMs, they understood, because what is the point? Because it's simple to say we have a single document that covers all the aspects. It's just one slide. But what is the concept? The concept is this. Let me to, I don't know, we are saying that functional safety is one of the elements of the cybersecurity. So that means that, and now I am simplifying the concept. If there is a functional safety requirement, it should be 99% of the case always also cybersecurity requirement, because functional safety is a part, is a subset. What we are trying to do is clarify in the cybersecurity requirement what is the impact that they are considering. So we have a cybersecurity requirement that we have some cybersecurity requirements that are relevant for safety functional, some other cybersecurity requirements that are relevant for safety, and in this way it's more simple to have a digestion with the OEM. And I would also say this approach, this step is also important for the step of common documents, because in this, if we have a collaboration with the OEM, we can also have a collaboration in terms of technical and cybersecurity concept. Otherwise, it's more complex. We have a standard approach, OEM tier 1.
Thank you.
You're welcome.
Yeah, but as we see that still we don't have a standardized approach, and really we are still far away from a kind of harmonized. Oh, okay. Last question. Let's try to keep it short.
I'm Garrett Tietz from Harbinger Motors. I see in this slide specifically, you show the feasibility of the cybersecurity assessment done at the architecture level. Do you see that at the concept level architecture or the system level architecture?
Can you repeat the question, sir?
Oh, go back to the previous slide, please. So the box in blue, the feasibility assessment, do you see that at a concept level, being done at a concept level or a system level?
This is performed at, okay, concept level or system level. I don't know if you mean at standard level in terms of concept. We perform at the beginning of the project. We have a preliminary architecture. We perform so that feasibility with the preliminary architecture, and then we reevaluate the feasibility when the architecture is established. So we perform at architectural level with preliminary and then in the different phases to have a maintenance of the TARA, but at the architectural level.
Okay.
That is the concept phase of the standard. But
and then one more quick one on the process flow. It showed that the testing is not combined. Is there a reason that you haven't combined the cybersecurity and functional safety?
Yeah, not yet, because step by step. Now we are trying to harmonize the TARA, then we harmonize the requirement, and then I will say now the main challenge is the tools. The tools are very different. The tools are very, and also the concept, because what we're trying to do is to create a team of attacker in the company. So in this way, because also I will say that there is another level of difference. In the functional safety, there is only the defender. We have to defend our product by randomic failure and randomic faults. From cybersecurity is different the approach. So there is a defender, the company, and the attacker. And so if we are able to have the attacker inside, it's not simple. And it's different approach. At the moment, I am a safety guy, not a cybersecurity guy. I see a different approach about cybersecurity testing and functional safety testing. Very, very big gap. So, yeah.
Thank you.
Okay, and I think we should also extend it to discussion. So it's not only ISO 26062 and cybersecurity, but even SOTIF. So we can really inject the false, like on the perception system to influence the functionality. So that's something that often is neglected, but yeah, we have to consider probably bigger picture. Okay, thank you.
Thank you.
Okay, we go to the next presentation. Again, it's still on the similar topic. Hopefully I pronounce your name correctly. So Chaitra Ramaswamy. Oh, God. Competence lead for functional safety and cybersecurity again. So nice. And from Continental. And also, yes, long experience on functional safety, but yeah, I give it the floor. Thank you.
Hello, hi everyone. My name is Chaitra Ramaswamy. So I work for both functional safety and cybersecurity. And yeah, okay. I think we already had two presentations, which kind of showed already how the interaction between safety and cybersecurity should be present, or what are the things which are quite common to them and which are different. So my approach today is we at Continental have, let's say, we have two projects where we combine safety and security, and I would like to show some let's say, practical examples of how we perform this. So yeah, this is an introduction. So I think already we had two presentations. So I'll skip directly to the V model. So here, of course, it doesn't have all the work products, but what I'm basically trying to show here is how the interaction between some of the work products can happen between safety and security. So starting with the topic of HARA here and TARA. So like already mentioned in the previous presentation, there is a part of severity which is considered from HARA in the TARA. So such concepts are taken over from HARA to TARA. And in the same way, at the next level of requirement felicitation, we would have SIL level and CAL levels. So of course, having a CAL level is not mandatory, but I would like to show how having a CAL level helps us in both testing and also in further, let's say, simplifying the requirements. Then there's also approach to combine the analysis. So for this, let's say we have fault tree analysis and attack tree analysis, how they can interact with each other and how we can show from attack tree a possible path that can lead to a fault or violation of the safety goal. Yeah, then coming next to the software and hardware parts of it, and also the testing. I think we can go into individual ones. The first topic before starting the whole process is about alignment in the organization, because it should not be that the safety culture and the security culture are quite different. They have to be kind of combined. So for this, we solve this issue by having, of course, we have several safety engineers and we have several security engineers, but they report to one group which would be expertised in both safety and security. That means if safety has some issues, then this can be discussed overall with the security engineers. And in this way, the overall process in the organization kind of combines together, and it gives inputs from both security and safety to the overall process. The first one is mapping of hazards in the threats. I don't know whether it's quite clear, but yeah, this is an example from, let's say, what we have. So the example here talks about a low beam. So the main safety goal for the low beam is loss of illumination on the road. So if there is no illumination on the road, it's probably then the user cannot see the road, and this may lead to possible functional safety violation. And for this, we have linked the threats. So the attacker can attack, let's say, by tampering or by denial of service. So by tampering, he can tamper, let's say, the illumination value, which would mean that maybe there would be very low illumination that they cannot still see the road, or with a complete denial of service, that means the whole total low beam can be shut off. In both the cases, we have a violation of the safety goal. So this link from the attack to the safety goals gives us, this is the path where the safety and security are combining together. With this link, in the next step, what we can do when we perform TARA is that, so here, this is the parameters. So for us, the first problem is, let's say, if the parameters that are stored in the memory, this is an example, by the way, one of the parameters stored in the memory can be corrupted, or they might be manipulated in a way that the illumination might be lost. And this is, let's say, a safety risk. And this is included here in the TARA, in the safety impact, with severity as the highest, or very severe. And because of this, the CAL level would increase at a TARA level. And also, I have hidden some things here, but yeah, that means that we would have a lot more measures from security that would be required to protect this parameter. So this is one way. The next step would be at requirements integration. So the key component here in requirement integration is we didn't want two separate work products. One is TSE coming from safety, and also security concept. So we combined the technical safety concept, the security concept in system architecture. And the differentiation factor was with ASIL levels and CAL levels here. And each of the requirement had ASIL and CAL levels. So it can be a security requirement, but then the safety engineer goes through this security requirement to add ASIL level to it. And in the similar way, the security engineer looks into the safety requirement to see, yeah, maybe this is also already considered as a part of one of the security requirements, and then this needs to get a CAL level. So what this helps is later point in the testing, we already have a CAL level which is defined, which means when the testing takes off,
the standard already has a specific test. Maybe we need some penetration test, then already with the specific cal level, we can do a specific penetration test. Or maybe with an ASIL, we need to do a regression test. So this is already with the addition of these attributes, we could already have these incorporated. The idea is also to have different views because, of course, we are trying to combine them together, but it can be that we as a tier one, but it can be that the OEM would still like to have different documents which shows that this is safety and this is security clearly. So we have different views still incorporated, or maybe there might be some projects like maybe an interior light project which might not be safety relevant but only security relevant. Then we could clearly cut out the safety part from it, and then the rest could be used as it is. The next part is about the analysis. So with the analysis, what we did was, this is an example of the same parameter here. And this is a part of the attack tree. And this parameter leads to tampering. And this is linked to the safety goal here. Of course, the tool, I mean, in an ideal world, once this linkage would happen, the tool should take that this exact tampering of the parameters can also violate the safety goal. But at the moment, the tool doesn't support it. So once this linkage is done, we manually also are adding it to the fault tree, or at least having a look whether such let's say tampering of parameter, maybe now the parameter requires much more safety mechanism, or maybe it has to be hard-coded in the code that not every parameter value, but only, let's say, the minimum intensity parameter value. Maybe this has to be integrated already in the code that no one can manipulate it. So this would be the approach. And yeah, here as well, I think this is the first one where we say, yeah, this was the parameter was the one which had the safety rating, and hence it has the highest. Next is hardware and software impact. So already at system level, we have requirements which have CAL and cell level. So once the requirements are traced down now to hardware and software level, this CAL and cell level should also be flown here. But I think already in the previous presentation, it was also mentioned, like we have to think about corner cases where we think, do we need some additional measures? Maybe like separating a core, that safety core does not, I mean, safety core is quite separate from the security code. Maybe it might be needed, might be not, but then these has to be thought here. It also goes for hardware. Maybe we need HSM. These things has to be thought of here, and then these requirements also at hardware and software level needs to have a CAL and SIL level. Based upon this, we tried, so until what I showed now, this is already proven in a project, and based upon this, we tried also the testing strategy. So what we tried is combining the system level test. I'm not talking about all tests, but just some requirement testing. And what we did was we could test it together, but still the reports had a separate columns for safety and security, just for, let's say, showing it to customer or assessments and so on. But it was quite possible that at system level testing, this could be combined. Next is the assessment strategy. I think there was a question. So what we tried to do with the assessment strategy was also that we tried getting assessors who are expert in both safety and security, because it's not about checklist. It's also more than checklist, that this person needs to know that both safety and security concepts are in place, or how they have to be on a technical level. Of course, this is still not fully done, but the idea was we have safety assessors, and to train these safety assessors to also be security assessor. And the idea is to combine some of the documents which are common to them, like maybe requirement documents, and they can be checked at once. And of course, the testing and other strategies can be checked together. But as of now, these are two assessors who are performing assessment individually, but they are still in contact with the same lead so that all of the harmonization between safety and security are happening. Next is about vulnerability management. Of course, after the V cycle, we also have, let's say, maybe some vulnerabilities which are reported in field. So in such cases as well, for each vulnerability, we do analyze whether it has an impact on safety. Example, maybe like we had for Cypress Trevio, an issue with the watchdog. So if the parameters were not mapped properly, then the watchdog was glitching. So it can be if the parameters were attacked. So it is a security issue because someone can change or manipulate these parameters, but it's also a safety issue because the clock is not working or functioning properly. Maybe it is, yeah, I mean, it can be that we are violating the FTTI. So in such cases, yes, of course, if there is clock monitoring which is already present, then of course we have a mechanism in place. But maybe in some cases, it might need that because of a vulnerability, we need to have additional safety mechanisms which are added. So this is how I mean we are analyzing the severity impact because of safety, and based upon this, the vulnerability management also incorporates safety. Yeah, as a conclusion, I think I went through all the phases, the initial, the requirement, the analysis, hardware, software. Of course, not all testing can be combined together. Some testing are quite independent, but let's say, yeah, at the moment, 2 projects are running okay, but for customer, it is still presented as 2 different because they don't like this combination yet. Maybe it takes some time. So.
So good, we have a time for questions. Okay, first questions here.
Hi, I'm Kepin. I work as functional safety engineer for BorgWarner. So you mentioned that your safety engineers goes through security requirements and assigns ASIL level and vice versa. So isn't it like a double effort? Because I'm sure that everything which is required, the safety requirement or ASIL other than QM, you have already assigned it in your THC. And then now you're going
We are not having a single TSC because we wanted to combine safety and security. So it's in a single system architecture document. And the system architecture document is 3 people responsibility, the system engineer, the safety and security engineer. So the part of the security requirement, assignment of CAL level goes to the security engineer. If you find a single engineer who can do it, then of course this is the best approach, but that's quite not possible. So that's why I know it's a redundant effort, not just with that, but also, let's say, since it's a single document, it can also be that we have to do extensive inspection review for it, for some parts of it, which for maybe from security it's not required, but yeah, maybe from safety it's required, then it's also increasing a bit effort there. But having 3 document means that it would be a 3 different review. Compared to this, the overall effort with a single document is less. So
Thank you.
One over there, and one here.
Hi, Alec from AVL. Thanks for the presentation. My question is about vulnerability management, like you said, after production and when the vehicle is on road, maybe. So when there is a vulnerability identified at that time, you said you do the safety analysis again based on that vulnerability. So
vulnerability, we
where do you
incorporate the safety aspect. And let's say if we find out that it is a safety issue, then it is something that has to be reported as well. Like the one I said, so the clock glitching issue. So it is an issue, it's on the road. So that means that if we didn't had a mechanism, we would have to report it to the OEM and we would need a software to correct it.
I think the issue is who can take the decision. So I think the security guys can find, yes, there is a vulnerability. but now do we have an impact on safety? This probably you need different people to judge this.
Yeah. So that's why once in a vulnerability, the security engineer can look whether it's a safety issue. And if it is, he has to say to the safety engineer. And of course, then the whole process of with the safety and security both should follow together.
Right, yeah.
Senthilvale from Sensata Technologies. I could see that the safety analysis and cybersecurity analysis are combined in one of your slides. So if it's okay, can you tell us what tool is capable of supporting both the analysis, and is it done by a single person, or it's a team who works on a single file and does this analysis?
Medini can support both Tara and Hara. So this is a diagram from Medini. And in our company, I mean, of course, it can be done by an individual, but with us, we have two different people who are doing it. But this overall diagram is a common one. It's a single file. Both Hara and Tara are in a single file, but handled by two people. But this overall diagram is done by system engineer. Yeah.
Thank you. It's a nice work. Thank you.
Okay, I will actually have a question, not much to you, but to also the assessors in the room. I mean, I think we have a few. Do you have a plan to, let's say, enhance your assessment to include safety and security together? Or also from your side, you will have a safety assessment and security expert done by different group of people? Can I ask this question? Okay. Starting with the sponsor.
Hello, Grim Alexander, SGS TÜV. Currently, we do not plan such a combination because the topics are quite diverse, and to mix up the work products and the reviews could lead to issues, I would say, in the review process. So for us, we have not identified the benefit of the synergy effects yet, but maybe we can learn from you that it can make sense. This is the current view from SGS TÜV.
Yeah, I mean, the point that in the second edition of the ISO standard, now we are really requiring, asking to have this judgment about security when we are saying, yes, the product is safe. So, I mean, for me, I also do internal assessment, and usually the outcome of the security assessment is something I do want to question, but I need to have as evidence to show, yes, okay, these are the risks, these are the mitigations. Do we see any risk for safety? Yes or no? And then we can take a decision. So for me, this needs to be now one of the input.
Makes sense, yeah. We have the experts which are experts in both topics, which are also handling assessments in both topics, but still separated. Yeah, let's see how the times will change and what kind of work product change we will see on our customer side.
Thank you.
Yeah, from our side, it's similar.
Again, name a company.
Sorry?
Name a company.
Yeah, Christian Nowak from TÜV Süd. So yeah, from our side, I think it's fairly similar, I would say. I mean, we have also the experts that basically have the domain knowledge in both cases, but I think also from the project side, it was normally so far fairly separated. Of course, you're right. You have to consider also the results of the cyber security assessment and also for the safety assessment. There have been attempts to combine it, but I think so far not really found a good use case for this, let's say.
Okay. Thank you again for the feedback. Anyone else wants to contribute? No. So again, many thanks to Chandra for presenting. Okay, next topic is Dr. Marzana Katun. She's a functional safety manager at Bosch. And she's been also busy for since a few years on the functional safety and security with different projects. So, please.
Testing.
It's okay?
Yeah, I just wanted to go back. Did we go other directions? So sorry.
Okay, so as a safety side, I always have to click and see if something go out of the box. So that's, I always do try to present something. So hello everyone, and I'm very happy to present our topic. Before I started my topic, I would say it's purely research-based and also come of the tool and the team interest, where we see us in future. So does this co-analysis make sense? If yes, how we can make ourselves better for future and be time to market, go ahead with the technology that we are using, and what are, like, it's about to understand the technique, to understand different domain, and how to systematically reduce the complexity, because nowadays our systems getting complex. We have demand for autonomous vehicle, which is much more complex, but we have on the other hand pressure to be in the market and to present the best solution possible. So with that motivation, I would present today co-analysis of functional safety, SOTIF, and also cybersecurity specifically for failure effect understanding. We have seen yesterday, Mr. Ricardo mentioned, we have jungle of standard. You take one and it always goes, oh, we have to follow this standard, we have to follow that standard. Have we considered this and that? For automotive, we focus mainly on the safety and cybersecurity. Our product has these two main impact. We have several areas where we can improve ourselves or we should take care. One of them could be process as an organization perspective. We could also consider now management system. We had a well-established safety management system. We have from cybersecurity side, cybersecurity management system, but we know from management level also we need the support. So we need the interaction. We need to find the KPIs. So we need some technique to apply that we can also understand those management level areas. But today I will focus on methods. To start with the method, we all know there is failure, errors, and fault, error, and failure. Fault is condition, abnormal condition, we all know, but I always like to repeat it, that I stay with my domain. Error could be a result of a fault, and then the failure is that we have the termination of our intended functionality. So we can start with the broad picture. We can have a system from vehicle. We have also, if we decompose it or go down, we can have several EE, electrical and electronic system, but we have also element, which is nowadays complex if you think about ASIC, application-specific IC, MEMS sensors. So we have much more complex, lower-level development. But how this propagate, how this fault propagate in different level, we can see it differently. Yes, you can question me why this is only one direction, why I did not draw it other direction, because we as a Bosch, we focus on tier 1, tier 2. I'm coming from ASIC side. So after that, I cannot transfer my requirement to someone else to do it for me. I end up with transistor level, and that's all I can have. So what to do? How to go? Because there is nothing rather than my level. I could say that, no, it's not my responsibility. Please delegate it. But we also wanted to support our customer. So we wanted to think what we can provide to the different level from upper, and that we could benefit each other and we could learn from each other. Now comes about cyber attack. You can also again ask me why it's in the system level. Yeah, vehicle, you can physically attack the vehicle, easy. System, I have VLAN, infotainment system, could easily be, not easily, but it depends on the expertise, but you all might know. 2015, chip attack, Chris and Charlie wanted to just experiment, and they first time show it and demonstrate it in vehicle that how a cybersecurity attack can lose the steering function. So I have really an impact for safety. So that means it's not only now about safe vehicle, but also secure. So it's safe and secure, not or secure. So that's the main message. Why the element does not have cyber attack can happen, but in that case we are more focusing on physical attack, which might be difficult and different nowadays, at least our understanding. So we first focus or we try to do relevance assessment. For example, if we have an element, just evaluate it. Does it make sense to put entire cybersecurity process on it? Do we have the relevancy? If yes, how deep it is? Of course, to optimize our effort and time. On that case, we understand that effect, the failure effect understanding could be the connection between cybersecurity and functional safety and SOTIF. Why? We have base already quite long. Like when I joined in my first company, 2015, I came to know first time, there is a norm called functional safety. Okay, let's start with it. And I was allocated because there was on that time, on that small company for ECU, no one expert. This is a new norm, you have to apply, read and try to apply it. Started with FMED, okay, I have to look for Siemens norm and in ECU, how I can put it. You can make an end template. So I started with old character, like old approach. I take an Excel, try to formulate it, and do you understand it? Good thing is I have done it with my master thesis with this starting point. So I had a bit of knowledge. But then we write the failure effect. No one on that time really thought about cybersecurity. Okay, for ECU, you have the standard, support us for the industry. And then a couple of years later, I joined in the PhD for autonomous vehicle. Okay, I was offered, hey, I have a safety topic. Are you interested for autonomous vehicle? Okay, autonomous vehicle, complex system, and on top of safety. And then okay, then it's not only safety, it's also about security, because higher level, I mean level 3, 4, or highly automated vehicle, then basic point when controllability, we put in HARA, yeah, human can take an action, but then it's not even possible anymore. So even the approach, what we years used it and we have good knowledge, it's not valid anymore. We need some extension, but how to make the people in industry motivated about it, because we are very comfortable. We know how this method works. We are using for longer time, but recent years, the technology changes. We are more focusing on or getting motivated on artificial intelligence, LLM, hey, use it, it gives me good result. I have someone to talk. I don't need a meeting and termine. This is a different topic. Whatever this ChatGPT is giving me, is it trustworthy? I would not go in this topic, but in our team, we focus on holistic approach, that how to combine or understand or realize this failure effect and to judge, is it make sense now to apply security measures or to apply cyber safety measures, or can we combine it? To start with it, we started the set of threat models or failure modes. We have quite a good library for functional safety to collect the data for failure modes and the component or asset. You can say the item and asset. Let's assume in a good case scenario that we have a product which is safe and secure, so an item could have been both. So we know we have this mind that can have some threat which is only specific for the cybersecurity perspective, true, but they might be separated or can be separated from safety failure effect. But what we also realize in our projects that there could have some effect which we can benefit both of the domains. If so, do they have any interaction? How we can present it systematically? And at the beginning of the concept phase, because things get messier in the development phase. You deal with thousands requirement. So concept is the key for my understanding. Concept is the way where we can make our mind fresh and be systematic on it. Okay, that's where we started. Let's combine the team of security and safety side and start to build our concept. In the concept, we must, of course, we have seen several presentations today. There was a nice presentation explaining the impact, showing that it has a safety is only a property or impact that we consider in cybersecurity. But cybersecurity is more than that. But for today, or for my presentation, I'm focusing on that criteria, severity, and focusing the co-analysis, so focusing on safety perspective. We can take our state of the art or from our project experience, what are the cybersecurity measures we have, what are the safety measures we have, can we get support from each other? Is it so that how much we can gain, which is readily available already, which we have the experience already, and then try to build it. That means standardization. That means a block fixing that, okay, we have the knowledge, we have the expertise, we have the technique, we have the tool. Now it comes about how to implement and make people aware about it. So here I bring a small example just to make it simple. I head up to complexity to make much more simpler possible, to avoid also conflict discussion and to maintain the time. So we first used, okay, what could be our scenario coming from tier 1, tier 2, I'm mostly from tier 2. That means ASIC, application specific IC is currently I'm working on, and that comes about, we always get the customer requirement. We start always with customer requirement, but also we wanted to be out of the shelf. So we wanted to understand also, as I mentioned, what's a system or from where my customer needed, how I can help them, and also understand their, I also don't wanted to say that, okay, we have it, we are experts on it, leave it. Take it like that. Or I also don't want it to have that opinion, oh, you are my customer, whatever you said is okay, your customer requirement is my wish list, I follow it. No, we wanted to be competent. We wanted to understand for whom we are working on, for why we are doing design this way, not that way. Are we, like, we now in this competitive market, we also have to always have this time pressure, we have the technology pressure, and so on. That's why we have to understand more. This is my main also motivation, to realize why someone need that and why I can support, or where are my constraints and limitation. From that perspective, we make, okay, my assumption point. At this point, you can see I mentioned, okay, we are considering vehicle level, we have no cybersecurity measures. Why not? Because we have a very baseline for safety. Why not start with that? If you have, then we can also discuss with. And then it's an abstract model. So we can take it as a block, and then we can always have this simple block in our mind and go deep dive in the development phases. Yes, every method's come up with some limitation, and it was known for us, which is quite state of the art. You have a failure, you have only failure effect, you have threat, you can use separately, but there must have some common, because as I said, ASIC, we are transistor level. You can differentiate between higher level from where the failure or the source of the failure coming, but for ASIC, for us, okay, it's not working. We did not get the data. It's a wrong data, or my transistor is not working, over voltage, under voltage. To define the risk level, here I use VDA FMEA handbook reference, just to give some numbering or quantitative values. So we started with element. So first try to failure mode and threat mode description, and then we also have the failure effect. Can we define this combinedly? Is there any point where we can combine this both effect together in ASIC? Then we have some similar, like basic approach that you normally use in FMEA, and we always discuss with the cybersecurity expert. We have our own process. For example, you can see communication buses we have, and then we said, okay, from safety side, can have loss of communication, wrong communication, and so on. But from cybersecurity side, we have the output. Okay, why not try several kind of attack? Maybe you do in the test, and we can combine those tests, and we can be faster. We do anyway fault injection test. Is it possible to incorporate those? It's just to give an example for you. Regarding doing this practice, we have, at least in our team, we understand this is the right mindset is important. If you communicate to both domains and they are expert in their own domains, things are even difficult even to communicate. For example, an analog designer, when we talk with a digital designer, sometimes it took times about to understand one word. Sometimes it happens with me, sometimes that I when join in ASIC, they talk about system, and I came from doing the autonomous system, and then I also, oh, they're talking about some ACC system. What is this system? Then I understand, no, the system is the term, it varies which team or whom you are talking. So during this, we understand, or during this example or practice in our holistic approach, or to realize all these challenges, that failure effect really is the point where we should focus on. Then also getting an overview. Sometimes at the beginning we thought, no, I can be independent, and I have my asset and I'm good. Let me do my threat analysis. Let me provide this security measures. But how to close those gaps? As I mentioned, we want safe and secure, not or. And we wanted to find those gaps in the concept phase, not in the development and end of the product. Then it's much more costly. And then also to have our systematic mindset that at any point during development, when people are, designers are working hard and they are on their domain, how to interact those, how to close those loop and connect those blocks together, that we have a product together. We have realized as a good point, then after several meetings, you find that people are now cooperative. Beginning, they're not even interested to talk because of uncomfort. I have never worked for safety. I have cybersecurity experience. Why are you talk about failure modes? The other way goes also, then it's my job being a safety manager and cybersecurity manager to bring the team, to bring the expert together, that they have this understanding why they are doing it. And that was really good. Then we have a flow, okay, after several times it works. Then they try to think on both perspective, but I must say it's one person, very difficult to put your head once as a safety manager, to put your head as a cybersecurity hacker, because they have different goals, they have different view to see the product. And to have both experts together and be me to support, to understand was really quite good practice. We have some drawback, for example, the cultures. When we are very well known and work in our domain for safety and cybersecurity, then it's uncomfortable feelings. But we have to take the challenge, we have to take the innovative part and improve ourselves. As a future work, we have the idea to involve the test, so right side of the V, to focus on the right side of the V and how we can prepare this common failure effect, maybe as a database, and then also use some artificial support to use it. Thanks. Now I'm open.
Okay, very interesting. So what is more important, safety or security? Questions? Okay, one here.
Well, from Sensora Technologies. I have a question about the severity table for cyber failures or cyber attacks? Because as of now, VDA is suggesting the severity table for the safety analysis. So how you are define the values for cyber failures?
We have not, if I understand your question correctly, we get this safety impact.
Yeah.
So 21434 directly refer to ISO 26262. So if our asset have a safety, then you have to consider that impact. And it really varies, but for the FMEA or the failure modes, you can realize though with the effect, if this effect is really critical, but we don't also consider the other part of or other properties of the cybersecurity on that analysis, as we take functional safety failure modes as our base, because we have the library for it and try to extract much more information possible from the safety side. And if it's needed, then we extend it further.
So in one of your slide, you specified severity 8 and 7 for cyber. So
the analysis, you mean?
Yeah,
The
just
analysis.
to understand how you are differentiating the values.
We have take the state of the art like CVSS from security type. We also use the safety expert. So it's more or less come with the refinement of expert opinions and based off other project experience.
Okay, got it. Thank you.
Okay, we have 2 questions here. Then we need to move on.
Alexander Grimm from SGS TÜV. Was it faster for you to combine the FMEAs and not performing separate ones with the experts separated?
That depends, as I mentioned, for the levels where we are. For ASIC, it is really faster and we can save the time. But from my previous experience or research work, this is Tara, my mentor was from TÜV Süd. So we had this close connection how to do it. But on that level, I do agree to keep it separate was much more faster and easier.
Thanks for the clarification again.
Okay, well, it's Siavash from AVL. In your presentation, you have considered the attack equivalent to fault that leads to error and then failure. In couple of presentation before you from Mr. De Rosa, the failure and attack were considered equivalent in terms of ISO 26262 and cybersecurity, I suppose. Maybe it's not correct understanding. I want to see a little the rationales between these two. Also, Mr. De Rosa, if is this understanding correct? You have considered the failure and the attack equivalent. Then here we have the fault and failure.
So
is it?
What this presented, Francisco, I don't want it to say wrong pronunciation, presented from the top level, where you first start with can have a different level. So his presentation more about generic, and my example is for ASIC perspective, which is, as I mentioned, very lower level where you directly, what could happen if my one ASIC is not working? Is this ASIC has a direct violation of safety goal or cybersecurity goal? It's really coming from there, but you already considered in your vehicle level safety that is this asset has a safety properties. And then you have to, of course, maintain the traceability. You show the V diagram. So you always have this co-mapping or correlation or interaction between these two domains. And we, as an ASIC tier towards the lower level, we cannot really, at this point, we don't see separation in that level. But of course, in higher level, you can always say, where is the source of failure? But when I take the failure modes, it's only over voltage, under voltage, but can also be tempering values, or can I have a malfunction of my IC, right? So that's how I can visualize this in different level. Does that answer your question?
Yeah, I suppose then when you see it in the base level, you mean that it is called attack, but you mean it's one attack step, not the whole attack.
No, definitely not. Yeah. You need this mapping always both ways. Either you can do top to bottom or bottom to top.
Thanks.
Okay, we are already a bit out of time, but last question, if you can keep it short, and then we start with the panel.
Actually, I have get my answer from the question, but I can extend a bit. How did you selected the components? I mean the ASIC. So for example, class 2 or class 3 components which has functional safety relevant, or did you have conducted all components? How did you have selected the
We
components?
selected for this use case only one, but more or less in our ASIC, typically it come with SLD process, safety relevant always. And in the reason for that, the moment you talk about digital data, you cannot take out security side.
I have very short one more question. Generally, functional safety concept is so such analysis are mainly done by hardware side, but cybersecurity is mainly focusing on software attacks. So how did you actually, which challenges did you get bringing two teams from hardware and the software at the same time to making this analysis? This is also very interesting.
Okay, then let me start with the beginning. So you have a hardware side and also the software side. Cooperating them with the hardware-software interface is also a challenge. And then we need the third person in the room who is focusing on the security. And I don't think software is only for cybersecurity. If you have software, you should consider, otherwise not. I don't fully agree with that because that could be a physical attack. So that means as an employee, I have the technical knowledge. Am I sharing this information to my competitor? Could also be a cybersecurity properties. So this is also about awareness that whoever, for example, in production, I don't know if someone is doing some security information or some product-related information, then it's not a safety concern, but it's a security concern. So we have, you might know, we have the awareness, we have the training, we have to let people know, hey, it's now not only about technology, it's also about protecting your knowledge. It's also about knowing that how security is not only safety, it's also about privacy, finance as well.
Thank you. Okay, I would like to move forward, so thank you. But don't go away. Don't go away that we start now the panel. Can we get a slide for the panel? And I want to invite, again. Okay, so panel about, again, cybersecurity meet functional safety. Alexander will be moderating the panel, and we have, again, Dr. Marsana, Costas. And on top, we have Joaquin Maria Castella Triginer, should be online.
Yes.
Yeah,
Everyone.
hola.
Hola.
Hi. And Joaquin is connected from, I think, Spain. And
I'm in Graz.
Sorry?
I'm from Barcelona, Spain,
Barcelona.
but I am from I'm working in Graz, Austria.
Okay. Thanks for the clarification. Yes.
No problem.
Okay, and it's from a virtual vehicle research.
Exactly.
Yes, and then we have Marcos Klisch. Yes, I'm just getting. Sorry. Yeah, Marcos Klisch, it should be here. Okay, no, I need to find now. But okay, I will introduce like that. So he's a senior principal design engineer at MHP. It's a Porsche company, but he's also involved with many standardizations and activity for UN and so on for security. So nice to have you guys.
Thank you very much. Also, thank you very much for the introduction. Yes, we heard a lot about cybersecurity last
minutes and also yesterday already together with functional safety, and we've seen that there are challenges coming from an organizational perspective, a process perspective, a technical perspective. We have two standards which are relevant for us, the ISO 26262 and the 21444. And I would like to ask directly into the round, from your company perspective, from your experience, how do you combine the two? Are they separate? Or do you do this together? Let's start with you directly. Then let's go through the round.
Yes, thank you very much. Actually, the combination of the how to use the cybersecurity technology and awareness and solutions to bring a higher quality product is actually the final round. Functional safety is part of the overall product quality. And we have right now the challenge, especially in the UN WP29, which maybe many people are aware of. This is the overhead leading group for type approvals and the regulation of that one. We are right now coming to the part that where we drop AI, in which subgroup of the United Nations we will drop AI, and how do we can regulate AI. So AI have a lot of functional safety features in, or to enhance the driver assistance system. AI can be used for defense strategy as a technology against cybersecurity attacks, but it can be also the other way around. It can be used as an attack policy, right? And these kind of things, and this comes together with backend, with infrastructure. So we are moving back from the vehicle itself as a product item. We are going into the big world of infrastructure where we have a lot of players in. So in general, the question is how to combine these to answer, or to give you a kind of an index, is we need to consider when we handle the integrity of the product requirements in case of quality, then we can keep that in a certain level. Then we can try to handle and manage the risk which comes with cybersecurity, right? But at the end of the day, if you're saying you don't want to have so much cybersecurity parts in, you actually don't know what has happened tomorrow, right? We saw in your presentation I call it climb the hill attack, right? Or starting with one attack surface and then going through the system and open another door, another door, another door. Maybe from the day one of identifying the attack vulnerability, you're not finding really the end, the issue, the impact of the product itself. And that kind means you need to have security by design and part of the functional development.
Mm-hmm. So this means you're even extending the scope. So not just for safety and security, but also AI and backend and complete IT infrastructure. Okay.
I would like
to you, yes.
Yeah, I would like to add that we are encouraged to use AI, for example, FMEA, FMEDA, and we always evaluate. We are asked to evaluate those and how to make AI better and usable. Currently, it's not, or have not reached up to that level today, but maybe in future. Regarding the two domains, we have the process individually, but having people much more awareness to making the training to know about why we should collaborate with each other. It's not about anymore only one product and quality. It's now also about business is changing now. So we have to cope up. And in ours, we are also focusing on how the Asian market going on, about the e-vehicle going on, how faster they are compared to Germany, how it's evolving. So we also wanted to take this opportunity to be innovative, to be open-minded, and at least to know how things going on and where we can contribute.
Kostas, what's your experience?
I'm the outsider here, okay, obviously, coming from the industrial part of functional safety. But it's a different approach that we have to deal with, because we do not have connected systems, and therefore functional safety applies in the base and cybersecurity comes after. Okay, so there's no a holistic approach. I think with automotive, there is a great opportunity, because this comes in the beginning. And we've seen many projects jeopardizing by the initial requirements. So therefore, in automotive that have a joint requirements for covering both, it's a great opportunity for the experts to cover them initially and deal with them. I understand the challenges between the different standards and the approaches, obviously, and there were enlightening presentations on that, on the different approach from the companies. I see similarities and differences, okay? But at the end, what we need to deal with, they all mentioned, I think they all mentioned the culture. And it's something that comes everywhere. So I cannot recall who mentioned about the meetings and the way you treat people in the cross-functional teams. So if you cannot train them initially, how to expect for that to finish the right way? So I think the challenge primarily comes from that and how you can support in any kind of industry you are, right? Especially in automotive where the requirements are stricter and you need to support them. But when it comes to simple things, the way I see things is that, okay, functional safety is what's going to save people from, let's say, killing, harm. Cybersecurity is the door that will leave that to happen. So sometimes it's not clear to me, even in the presentations, if that's the approach that companies are following, okay? Yep. It's mostly to raise concerns than answering things here, but that's how I see it, okay?
Well, thank you for your contribution. And Joachim, how is it from your perspective?
Thanks, Alexander. So what I see is that so if we see the perspective when the standard, the ISO SIE 21434 was introduced 2021, I think companies most of them struggle how to apply processes and how to be compliant, basically. I mean, this is 3-4 years ago, of course, but processes needs a certain maturity, and introducing a new, let's say, domain on top on we discussed the concept of dependability, and put a domain in top the same as SOTIF, that are resources, that takes effort, and so on. And I think what focuses an industry that is not well known to have unlimited resources when it applies to these kind of things. So it's focusing on applying to be compliant, let's say. Try to implement processes, try to understand what are the work products needs to be applied, and so on. What I see, so because I'm saying that because the perspective of research, co-engineering, and co-analysis are, let's say, fields of domain that are even more like extends that only these 4 or 5 years. So it's a 5, and so there's at least in my experience 10 plus years of such type of research in this field. The only point is that there is the maturity of the processes need to have a certain degree to say, okay, now we understood how much it costs cybersecurity, how much are a process of safety, and now we see, okay, we could then again take whatever we did on research, update what is ongoing, and try to see if in an efficient and let's say optimized way we can create a specific working activities where we can meet both. And I think that's let's say the challenges that I see in the future.
Okay, thank you very much. So looking at the 21434, it basically requires a cybersecurity management system. And there are now currently discussions going on ISO 26262 also to have a functional safety management system established. And you mentioned about here joining the efforts and doing this collaboratively. And I also like to ask the audience here, what are your experiences here? Would it make sense to have this, to combine this, and to have a joint, joint setting, a joint management system for cybersecurity and safety?
Sorry for interruption, but there's one important correction. The 21434 is not covering cybersecurity management system. This is R155. This is the regulation which saying you have to establish a cyber management system which covers the overall processes. 21434 is only for the cybersecurity engineering itself, and designing projects to create artifacts and work items and deliverables, etc., to have a kind of measurement. Because we are right now discuss in the ISO group to implement in the next version the cybersecurity management system as a part of the new release of 21434 to building a better bridge even to the regulation. Okay, just for avoiding this misunderstanding, we have the same in 24089 for the software update. This is also not a software update management system standard. It is a pure engineering standard. Sorry for, but
sorry, it's okay. We just combined it internally. That's probably the reason. But yes, but in general, still I would like to know the experience from companies. How are you treating this? What is your experience with combining these two? Or do we have this separated? What is the best approach that you would see?
Yes, Max Walter from Siemens Factory Automation. So I can comment on how we treat this topic in factory automation. So we have this same discussions ongoing for years now, how to deal with safety and security, what is the interrelation. And my personal conclusion so far is to separate these two things as far as possible. So because it's too different, and people are talking about similar things, but they have completely different ideas in mind. And if possible, it should be separated, in my opinion.
Okay. That's the contradicting point to what we have seen in the presentations this morning. Any other experiences?
Luz Garcia from Nebusco. I agree the R155 requires an CSMS for cybersecurity, and I would love to have something similar for functional safety, a regulation. Mm-hmm. Because what I struggle all the days is if we saw a presentation regarding the dollar yesterday, and if my company need to put $1, we'll put it in cybersecurity and not in safety, because one is a regulation, the other one is just a standard. And I cannot think that we cannot force companies to implement safety better than is done up to today. Okay. To combine the process, I'm not sure. We are trying to do something, but that is challenging for a lot of aspects. For competence, for management, could be done in some way, but competence and find an expert capable to understand cybersecurity in deep and functional safety in deep. I agree with Francesco. Mm-hmm. Also, safety is not just safety. You have system, software, and hardware competence that are really hard to have all in one person. It's a unicorn if you are looking for that candidate in your team.
That's true. So thank you for your contribution. What I can say from our experience during development is when you think as a security attacker to the system and analyze it with this, you find also a lot of safety issues. It's even more than you just doing the random faults. And this gives us a step towards technical implementations, which would be our next topic of the discussion. One of the approaches is you don't trust anything in your system. So you have authentication, you have keys, you have measures anyway. And the question here is, what does this actually make to real-time systems? Is there any experience from your side that you have here?
Ooh. So I had in the presentations which I did, in 2020 or in 2019 about when it comes the first visibility of cybersecurity in the automotive industry, it's going to have a must-have and a mandatory requirement. I always said the problem is if you try to get you will never get 100% security, right? So security is the best guess of risk measurements and an analysis of future environments to see whether if you can cover the risk or not, or keep it under control or minimize it or whatever you want to say. So for instance, if I'm saying, okay, I crashed my vehicle against a tree and I have a super secure system. So maybe the front crash sensor is telling my ECU saying, hey, there was a attack, a hit. Okay. And then said, oh, wait, we need to check the digital signature if you are the right sensor. And going into a backend, trying to establish a communication before getting the content of the communication. You're discussing, is the communication secure? Is this an authorized vehicle with an authorized sensor? And double checking. In the meantime, maybe you see or you don't see anymore any sunrise. But at the end of the day, the communication was super secure. So you need to find the balance, what kind of security fits into the requirement. And again, when AI will change, I think, functional safety requirements dramatically. Right now, you can say the vehicle have to brake after whatever 30 meters in a certain speed. And you can measure that. That is 101. You cover the 30 meters, then you're good. If you're going above, then you're out, right? This is zero run decision. Good, bad, right, wrong, whatever. Security is not that one. And AI will do the same because the algorithm is not giving you always the same answer. So in that case, you will be challenged with that balance of answers, and that will be change the functional system environment completely and the technical implementation of that one, because you cannot physically prove anymore that this functional safety function works in any condition in the same time, and you cannot give this kind of guarantee in zero run decisions. That's my 2 cents.
I would just like to add, or my way of thinking is cybersecurity standard give us also open room. It's not strict that you have to find that we see it in ISO 26262. You do this analyze, you end up with this, you have some values, make it safe. But cybersecurity standard give us the hint. So it one of this risk treatment. So you have acceptance risk. So you do you think based on this scenario, is the risk from cybersecurity side is accepted by us or not? It's on the manufacturer, it's on the developer. So I think we should focus on understanding on those areas. Is this risk needed some measures, or I would accept this as a risk? And of course, if I can also relate or think on that unknown, unsafe scenario, we also have it in SOTIF that we cannot cover everything. So maybe that's a connection from functional safety, then upper SOTIF, and then I have the connection with the cybersecurity that we know there is a risk. We know at some point 0 days will come. Are we aware about it? No, at this 2 days, it's all known or based on our known judgment, but at some point it would happen. And then it comes also about roles and responsibility. Yeah.
Yeah. So I agree mainly with Marco's comments on the challenges, and I think I'd like to extend that to the even more challenges when this needs to be applied in legacy systems. Think about it. How to even think about it? How to start it? It's almost blocking, right? We are coming from a world where there have been established systems, established architectures that they demand for things, if they demand for things, and we need to consider if that's something as a possibility. And when we start implementing it, the process requirements, the effort, the challenges, the complexity, it's almost blocking. I don't see that as a reality, especially for legacy, homogeneous mixed systems.
So, Joachim, your experience.
Yes, so I wanted to add, like when we establish Tara for our, let's say, clients, we somehow try to identify these layers of security in the automotive. And I think when we think on security, we have to see, okay, which are the layers of a vehicle where where I should use not only for the Tara for understanding what would be my attack steps and evaluate the feasibility, as well to understand where I put the security measures. And there, I think it's important to understand, okay, what I want to do is I want to have an architecture which is kind of free of security, which focus on reliability and functional safety requirements with certain specific time restrictions, or I really implement cybersecurity within the architecture. And I think this balance between in which layers I put security and how good they are, in terms of if I can, for example, isolate my architecture, which level of degree of, let's say, risk I'm taking outside and inside the architecture, finding out this balance, I think, is important. And once you have that, let's say, part of the architecture, another point I wanted to hide out is on we discussed about the AI, let's say, methods that you could use on different specific systems. And for example, in security, I think for intrusion detection system, things like that, you would use that. But for communication itself, you need to have certain deterministic values. So if you want to guarantee certain safety on your architecture, you have to have a deterministic communication. And I think, of course, we can discuss, there will be a lot of AI application based, will not be deterministic, will be a lot of, let's say, systems that rely on that, but in certain aspects like communication and signals, things like that, needs to be somehow deterministic in a way that we can really have that. So that's what I see on this perspective.
Yes, definitely on the term. Yeah.
You raised, by the way, an excellent point. Just want to add or take this legacy thing. And that goes also in a question to the audience. So one of the most critical thing I'm seeing is it's not the actual products, it's the end of life in the lifecycle management. When is end of life reached? How do you manage that one? And do you can guarantee for a vehicle where the life cycle is 10, 15, 20 years, even longer? How do you want to guarantee software updates, cybersecurity patches in a future time? And if not, what do you do? Because the most critical thing in the automotive industry is when the regulator is telling you, you are a public risk because your vehicle can be hacked and used as a weapon against a civilization. So they may withdraw the permission to operate this vehicle, your product, where you make money with, from the street. So that image to the customer is one of the biggest disaster. It can be happened by one of the ECUs from the supplier. It can be the overall product. But end of life is an open question which the regulation even doesn't cover because the community, the industry, the association, the NGOs, even the government itself in this UNEC Task Force Cybersecurity couldn't speak and agree to a certain flexible environment. So this is right now up to the industry. And welcome to the audience. Do you have your end of life under control? Do you see when do you want to recall products?
Very good question. I know how the industry handles at the moment. They forget their product, and then it's out.
Thank you for the question. Yeah. And I think it's one of the biggest points open in the R155, but the OEM is obliged to create a work product saying which is the position of the company, how we will handle that vehicle in the road. And the only solution and the agreement we have found with our regulator entity was we will communicate our customer that the cybersecurity is not anymore supported. So it's like discharging my responsibility to my end customer. But it's the only solution for now in the market. But it's a big point because I in the luxury position that I in the bus industry, so I can communicate with my end customer. But if I think in a normal automotive world, how I can communicate with my end customer? A, buy the car, then sold it to B, and now it's on C. how I can reach that person and tell that person that the car is not anymore cyber secure and maybe not anymore safe to be driven.
And who paying it, right? After 15 years, because payment is done. Customers already paid the vehicle, is the owner of the vehicle, and expecting a certain kind of valid technical function in the future. And you're saying, oh, yeah, sorry, the 0-day effect, which we had, but whatever last month, we couldn't foreseen. So now you have to pay 10,000 to bring the cybersecurity back to your car. That would be a discussion where you will end up in a. The problem I'm seeing here is that there's no standard for that one. There's no definition for what end of life means. We have in a regulation just saying a type approved vehicle from that particular vehicle type is not longer in the market. How do you want to do that? If you're a mass production automotive vendor, how do you want? You don't know if it's people putting in a garage and taking it out 20, 30 years later, or they sell it to some countries where the registration is a little bit more flexible than in Central Europe, for instance. So this, the end of life is not defined. End of service is not even mentioned. What does it mean, right? So that, and then the other thing is the OEM is taking the responsibility. You have to keep your tiers under control, and how the tiers can this manage, right? So giving just the bad part of the story to the tiers is not even the answer at the end of the day. So I'm really a little bit nervous about end of life when it comes to the first vehicles, which may go by 0-day attack, what you're saying, which we don't know today, and become urgently a risk for the national security or for the civilization or whatever we want to talk about. Yeah.
Because you are from industrial automation, probably also have very long.
Just a comment on that, because let's be realistic, okay? In industry, we need to do our due diligence based on what we know at the time that we develop, and therefore we cannot predict what's happening in the future. That's one, okay? So we can easily claim that our mission is for 30 years based on what we know today. This is a bit of a joke. So realistically, think of this as an approach. I'm a manufacturer and I plan for the 30 years mission. I will never claim for 30 years mission just to be on the safe side. But what I'm gonna claim is a bit of a great discussion, even internally in a company, even more internally in the group of the developers, and especially what you need to discuss on the management. Okay, my dear higher management, we have developed something for 30 years, but we cannot assure that this is going to be active after 5 or 7 years, maybe, or whatever. So, as you can understand, this is affecting the whole industry.
Yeah.
So it's a bigger topic, right?
Just to add another thing, the request from the regulation is you need to ensure that the commission is correct. So I need to call my customer and request to remove the data before that the particular part is thrown away. I don't see that feasible in this industry up to now. And the other point is what to do in case my supplier went in bankruptcy. I will call back all the cars and change the ECUs, or just hope that nothing is happening there and there is no vulnerability over there.
Sorry, one comment on that. There were companies that got into that trouble with COVID and the difficulties to deliver. So I know companies and products that have been recalled or stopped produced just to be on the safe side for the company. This has affected totally the business, and they lost margin.
This whole topic, there's one more comment from the audience. No.
I have one comment. In my previous conference, I had this talk to think about software not anymore as a software, it can be a service. So if it's a service, then it needs to be checked after X amount of time. So it's a service provider. It's not anymore a software, oh, I have sold and it's done. No, it need to be on time. And then every time you evaluate and have then update or something, you do it. That could be also, for me, it's a thinking view to, okay, before I have not think software as a service provider, but now we came to a conclusion that that could also be an option in future to have it as a service.
Definitely, and this brings us directly to the next topic, actually, because yeah, we have here, if we say already we need updates. Updates is something which we will need for a very long time, and we just discussed when does it end, actually. But let's say, assume we're having cybersecurity and functional safety combined, and we have a security attack which compromises safety. On the other hand, we know that when we have a safe system, we better don't touch it anymore. Safe, and then we don't update unless we find something from the safety perspective. But if this is not, let's keep it like this. How should car makers combine these two approaches?
I would say no way.
No way.
No way. One of the things is we have the right to repair, right? We had this this lawsuit from Carglass and who was the other one? Carglass and some other third-party retailer or maintenance company against the French OEM. And the French OEM said, "Oh, sorry, we are not allowing you to configure the whatever kind of sensor in a windshield." They said, "We are not allowing you because of security risk, and we have to fulfill the regulation from the United Nations, and we cannot give you access to the parameters to configure this sensor in a certain way." So, and they went to the European Court, and the European Court made pretty clear that the right to repair exists. So now it's up to the OEM to find a technical solution to say, okay, we open to third parties certain access to the system and have to keep the security in the same level. And that goes further. So that means when you open the system, then maybe some other people can get access to that one. I mean, over the air update is only just a physical distance, right? I can even use the OPD port for getting updates, right? We have the situation where we're discussing even in the UN right now how to keep the emission and the technical specification of the vehicle, which has been type approved, under control, because the modification of engine, of high speed, of emission environment, etc., can be manipulated just on a software base. So tuning, illegal tuning of the vehicles can be a big disaster because you're moving out of the type approval environment and certification. So with sound emission, you may have someone with a microphone saying, yeah, the dB value is too high. But if it goes to speed, to the software environment, turning software modules on and off, how the street police operator, the one that tried to identify technical inspection services like TÜV, etc., how do they want to control that the original software, and is there any kind of manipulation? And that is so hard. And that is the fundament for all these software updates, because if you enable software updates, if you give access to third parties, or the tier give to access to their ECU update to the OEM, how do they can control that the authenticity and integrity of the software from the beginning up to the update procedure and the final distribution in the vehicle environment is quite under control. And then you have the right to repair in the back, which opens your doors which you are hardly just closed for a while, right? So I think it's a challenge, like end of service, end of life. No answer so far.
Joachim, any experience from your side?
I think first of all, over-the-air updates enable a change on production on vehicles that are fully digitalized. So I think it's clear that this will be implemented. So this is something. It's let's say fix. So what I have first of all is this. So I think OEMs are aware that they can change their development cycles on that. And I think process-wise, there's the ISO 24089, which is well aligned to say, okay, if there any modification on functional safety should be traced, should be informed. And on that regard, I think for the OEM is more beneficial than another thing. As well, for example, for let's say life cycle maintenance, at least for cybersecurity, is fundamental to have over-the-air updates. When we talk about functional safety, I think it's important to identify the critical functions on a vehicle and how over-the-air updates affect critical functions. And maybe what I may be concerned is that the OEMs are doing those analyses in considering whatever functionality they add, considering both, analyzing both effects. I think this is something which may I be concerned, because most of the time focuses on features. You tailed those features, you implemented, you put it in the new update, but I'm not sure if they trace that really on a specific functional safety critical function and have the relations, and or if cybersecurity could enable a door to access data to modify. I think this is something that process-wise, I think that 24089 in the future maybe need to be more detailed, because now it's really on a high level. And of course, OEMs are facing these challenges, yes.
Oh, yes, so let's look, Masana, with your combined approach. Let's assume you find something even after production. To reiterate your analysis, find something, what would happen then?
I'm in the difficult situation now. I can only tell what we do now. We have a cybersecurity process to do the incident analysis, and we have like this series approach to timely manner to check those. And from safety side, we have the field return to understand the failure or root cause of the failure. Of course, it's a management or I don't know political decision to blame whom. First, we wanted to protect ourselves, and that's how nowadays my understanding industry is going on. Yeah, maybe people will be more thankful, including the regulation. I would also think acceptance, to take the risk as an organization as well, to evolve us as a human, to go with the innovation, and that of course enforce some risk, and risk need to be distributed, not to one hand job. Yeah.
Thanks. So on industry automation side, how is it working there with updates? More difficult.
It's a hardcode thing, okay? So over the air, it's something that rarely happening, typically. But if we follow automotive, it's a different aspect to think. Because what would you do? If you cannot support it, you're gonna recall every vehicle to reflash it. It's not practical, and it's not only what the market wishes to have. I don't think that's the image that the manufacturers wish to get to the customers. So eventually this will come. But if we go the other way around and follow the do not trust anyone, this is a hard no. Yes. So it's a balanced thing to consider. In the future, I think it's gonna go to over the air sooner or later. Okay, but you need to be proactive. Support it.
There's a comment from the audience.
I think something that could help is the R156, that is obliging the OEM to follow a systematic approach in the software updates. But before apply the software update, need to be performed an impact analysis within the company before to deploy it. That is, in one side, good news, but in the other side, bad news, because most of the software we integrate in our product, final product, is coming from the supplier, and maybe the supplier don't have the full picture that is impacting in the vehicle.
Just one comment to that one, because I brought a lot of a lot of OEMs through the audit of R156. And if I would be an auditor, honestly, none of them would succeed. The hard thing here is we are talking about processes. They are just checking the processes. The usage in the daily development is so hard. You mentioned in Barcelona, you mentioned the word critical system, right? Over the update from map data is very convenient and just for the infotainment. But if you're using the map data for the assistance system to identify speed limits, geographic environments, curves on the street, etc., then it becomes a part of a parameter for a critical system, which the map guys maybe don't know because they just do maps. Right? They're just sending maps. They don't care where the maps are used. So now you don't know is the truth of the origin of the map capturing that correct, or was it maybe me to modify all the maps in any OEM product just to give you a hard time saying there is a stop sign? No, there is no stop sign, but my map saying it's a stop sign. The camera said no, the map say yes. Both are non-critical, but the decision at the end of the day, what is the truth, what is wrong, and the behavior of the vehicle in a function regards to that critical system. And this is so hard. And if you're trying to pass through R156, and there is a requirement saying you have to consider any test in any configuration that this software update is not impacting any other software function of the vehicle itself, how the regulator will check that you made that, because they don't know all the functions from the vehicle. They cannot double check, right? So it's again, a very, very big challenge.
That is exactly what I mean. It's really difficult also for the OEM to check all the details of the software. Because maybe we receive a release note.
Oh.
And that release note maybe is not having the full picture of the car.
We're running a bit out of time. So let's finish with one last example,
we need to close. Yes, so maybe my last question to the panelists: yes or no? Should we be excited about the future, or should we be scared?
Motivated.
We would be scared, but we would take the risk and go ahead. So we are scared, but
motivated.
I think we need to be aware, but excited to challenge it.
Thank you. Okay, so we have now a coffee break, half an hour. Be here on time, and don't forget to check out if you need to check out from your room.
So I can talk. Okay. I just wanted to tell that we are getting closer and closer to the end of the conference. Therefore, I want to remind you that some of the presentations already happened. So you can already evaluate them and tell us your opinion. It's very important. Thank you very much.
Okay. Okay, please, can you take your seat? Okay, I'm sorry to drag you from the coffee break. I know it's the reason you are here. I mean, not the coffee, but the networks are very nice. It's part of the therapy to really meet people and talk. Yeah, okay. We have a tight schedule, so we'll have to start again. Okay. Do we have a online, Joaquin?
Yes.
Okay.
I hope
Hi
you can
again.
see the presentation.
Not yet. It will come probably soon. Okay, now yes, we can see the presentation. So
Perfect.
again, Joaquin was part of the panel. And yes, please, the floor is yours.
So thanks everyone. I'm sorry that I could not join for personal reasons, but I I think that it was really interesting to join in this conference. And today I want to introduce a certain edge cases that we work on our team. So I'm working for Virtual Vehicle. It's a research company. It's the highest research center in let's say in Europe in terms of virtual validation. And we are here located in Graz, in Austria. And we have a team that it's focused on functional safety, security, and SOTIF. And basically, in our team, we are interested always in topics related to co-engineering and co-analysis. And today's presentation, I will show a certain examples that we work in the last year on from the perspective of the cybersecurity. So how SOTIF and cybersecurity can interact from the perspective of cybersecurity, and as well how functional safety and cybersecurity can let's say interact in terms of co-engineering during the concept phase. So what I'm going to first focus on the edge cases for cybersecurity and SOTIF, and then I will move change to the functional safety and cybersecurity. So one thing that I just put that slide as a motivational slide, but what I saw is that the complete a lot of presentations going towards this product dependability. I think it's important to have this perspective to see from long time was running functional safety, now for the few years SOTIF and security, and how those let's say products can interact and how can be optimized, I think is important. When we talk about SOTIF and cybersecurity, of course, cybersecurity already, let's say, is implemented or in place to protect the SOTIF systems and to protect the architecture and so on. So it's part of their responsibility. But I think it's important to understand if SOTIF must consider cybersecurity on their on their methods. We know that SOTIF has its own, so every company that relates to ADAS has to implement certain methodologies, has to control certain ODDs, define certain triggering conditions, have a certain database of a scenario, have a certain methodology how those validation procedures on safety related will be in place. But for us, was interesting since we have certain like a simulator or validation environment to understand if from this group of scenarios that we know is unknown and is unsafe, it can be a part of let's say cybersecurity scenarios that could be considered. For that, of course, you need to identify somehow what are, let's say, the scenarios that could cybersecurity influence SOTIF, and which are the triggering conditions and what could be the effects in terms of performance insufficiencies. And that's somehow what we try to gather, which scenarios, triggering conditions would affect different, let's say, systems. Therefore, here we collect a certain list of attacks which target different systems. The first attack I present is this part of the camera system, what is called poltergeist attack, and basically is trying to affect the vision system in three main parts. So basically, or rather hiding, creating, or altering existing objects. This attack focuses on the stabilization and inertial sensors of the image, and is targeting, as I mean, the image is, I think, self-explanatory, to create certain disturbances that one can, let's say, that then the system does not recognize the object as it's meant to. The second attack that we analyzed was the negative shadow attack. This one is more focused on level 1, 2 systems, and is trying to generate negative shadows that could create non-genuine lanes. As you may see here in the picture, there is the genuine lanes, and then there is this negative shadow. He creates that let's say, non-genuine lanes. And the idea here is first to identify, okay, how the perception would detect that as a line or not, and see what are the, let's say, the performance insufficiencies on the model in terms of recognizing if it's a legit or not the lane. Finally, we have the part of the patch attack, which basically focus on these two methods. The first is have a fixed patch on a specific signal, and to identify how let's say the system recognizes, or how good the system recognizes that signal. The second type of attack on this is to randomize these patches in terms of figure out how much affect the level of patching, let's say. And for that, you, let's say, want to target two things. One is the evasion attack that you would like to hide or not recognize the images. And another one is the misclassification. So one can, let's say, change the system can change the perception of that signal. And finally, what we have another target system that is the camera lidar system, which here the idea is to alterate the lidar sensor in the sense that create the disturbances enough to that the system is not able to recognize an object. So in the image here in the picture lower of the presentation, you see. So on the left side, you have the car detected, and once you have these disturbances on the top of the car, the system does not really recognize if it's a car or not, and therefore it does not classify as a car. So at the end, okay, those are, let's say, examples that I put, and not in terms of like how security could protect SOTIF, more SOTIF, how should consider, let's say, attacks from malintentious or maleficent actor that could affect, let's say, the performance of the functionality, intended functionality. Therefore, I think it's important to create such a list of attacks, okay, that can artificially generate unsafe scenarios in order to consider that not only for perception as well in terms of performance insufficiencies on the different algorithms could be part of the system. And of course, at the end, when you end up, and I think it's more considered on level 3 plus, let's say, driving system, that this sensor fusion is really important countermeasures to not only identify that the car has a insufficiency on the performance, only maybe being capable to identify that the car is attacked. So it's not just identifying there is insufficiency, identifying that there is attack on the part. And I think this should be the ultimate goal on this part of the SOTI. Now, in the second part, where for us, we want to analyze how security can interact with functional safety, and we focus more on the concept phase, and this will be more focused on the concept phase because at the end, where we will compare SOTIF with cybersecurity, there you have a SOTIF specific methodology, and it's quite, let's say, concrete the way how you apply different methods to validate that. When we talk about functional safety and cybersecurity, there both standards follow the same V model in terms of activities, try to be aligned. And I think that's why it's important here when we talk, in our case, in this example on the concept, to analyze, okay, now we have both activities running and how we could provide co-engineering strategies to connect both sides. If one check the 26262 and the 2018 version, you can find out on the second part of the management side, there is already an informative annex about how you could potentially interact functional safety and security. And it's quite it's detailed on different parts. And if we check on the concept phase, there's these 3 main points there. So from one side, threats should be analyzed as a hazards from the functional perspective. So in this term, somehow security should inform safety. From another side, functional safety inform cybersecurity, and we already saw that on one of the presentations on the TARA, that TARA has safety impact considered on their analysis. And finally, strategies to determine potential impacts on safety goals and safety concepts connected to cybersecurity. In there, we see different critical points or different identifying points. That one thing is the theory and another thing is the practical thing. From one side, we saw that even for work product base are different. So item definition are parts which are the same in terms of function, in terms of boundaries, but the item definition on cybersecurity contain other things like more specific architecture, maybe data flow analysis, a certain operational environment that needs to consider that at the end makes not the item definition is not the same, and some companies see as an annex, somehow the other ones try to create an hybrid concept on the item definition. The second part is about the HARA and TARA, which I will be better explain that in detail in the next slide. But we see that both are, let's say, risk-based approaches, but not both has the same, let's say, understanding. Okay, because when we talk about HARA, this is a static risk. You do HARA, and that's, let's say, the main, let's say, the level is defined. This level is applied to understand how much effort in terms of engineering or functional safety engineering would require certain ASIL. But when you're talking about cybersecurity, we don't have something like that. We know that the risk evolved, the TARA could change even in the middle of the project or after the project. And I think this is the first, let's say, inconvenience to tell that. And of course, finally, the functional safety concepts and cybersecurity concepts needs as well to be analyzed what influence what. If we start on the item definition, one of the things that when you face safety and cybersecurity is about the timeline application. So you know that you can early start with the functional safety analysis, but cybersecurity needs to have a certain maturity on the architecture. You need to have a certain understanding in order to calculate attack feasibility, how this will look like. And I think this is one of the major challenges, the way the activities are not performed in parallel. The second is about what I put here, functions versus assets. I think HARA really needs functions, and functions are really in the early stages, and that's it. While when we talk about TARA, it's assets, and assets are not functions. Assets is whatever. A thing could have value, could be interfaces, could be the same communication channels, could be a certain hardware, software element. So I think this is really important to understand. And what we have right now in place, the only thing is that the impact rating on safety, it's part of cybersecurity TARA. But that's the only, let's say, connected part on the concept phase by the TARA approach. What is saying this part of the HARA, so on the Annex E, what we saw, okay, threat scenarios must be part of the HARA analysis. If we analyze most probably the companies which do HARA, I don't know in those scenario catalogs if they really consider threat scenarios on that, because during the project, since you will identify threats late on development during the project, it's really difficult to tell that. So somehow you need a certain strategies to do that if you want to do it properly. Of course, you could add methods that are co-engineering methods. We saw already in some presentations the STPA security, FDA attack tree, and FMEA, FMEBA, which could better analyze safety and security during this risk analysis. But of course, in automotive, whatever method which add effort, it's really hard to argument to have a third method on the concept to harmonize that. But let's say these are like options that you could have to cope with that. When we jump then to the part of the safety goals and cybersecurity goals and safety requirements versus cybersecurity requirements, here we have to understand first how risks are connected, and second, how one influences the other. And that's why I think it's important to create links. To want to create a link between safety goals and cybersecurity goals, you have to create a link between the function and the asset. If you have this link, the process will help you a lot to understand, okay, this function is affected for this asset, and this asset is connected to this function, which has a certain AC level, and therefore you have this understanding, okay, I need to, in certain stages of my development, consider that could affect functional safety. If we analyze the cybersecurity properties, CIA, integrity and availability are shared properties. So most of the measures in place will affect functional safety for sure if it's a safety relevant function. And therefore, this risk needs to be inherited. So if there is an ASIL and this ASIL is high, this needs to be, let's say, triggered in a way that when you evaluate the impact, those needs to be first analyzed. And finally, when we talk about dependencies between safety requirements and specific requirements, I think the way safety requirements are much better defined in the standard that for cybersecurity requirements. But what do have cybersecurity requirements are requirements based on a specific controls and mechanisms that are derived. And I think here there is a potential to identify group already which protection mechanism you would use and already perform an analysis on those mechanisms that you will assign for each cybersecurity goal in order to classify, okay, which is the ones that are more affecting cybersecurity requirements and tail that. And that would make the impact analysis much easier. So these, I think, are points that needs to be considered that are important. So finally, to conclude the presentation, I think I already present what are the SOTIF, let's say, important considerations in terms of cybersecurity, in terms of ADAS attacks. I think it's important to have those trigger in conditions and scenarios from different attacks included on scenarios that could be evaluated, and therefore we could identify if a malicious actor is attacking a specific system. And in terms of functional safety and cybersecurity, it's important that we identify which are the parts which can be tailed, because there are differences on process-wise and activity-wise. And if we understand those differences and try to link them, I think we benefit from better strategies for tailoring activities in the concept phase. And that is my presentation. Thanks. And if there's any question, please go ahead.
Okay, thank you. So, questions? Oh, no questions. All shy again after coffee break. Maybe still opportunity for people online? No, also no. Okay, maybe, yeah, we've been already discussing a lot about functional safety and security, but I like that you are bringing this concept of the SOTIF as well. And as I was mentioning before, most of the times we are talking about ISO 26062 and cybersecurity, but that's not all. And SOTIF can even be affected. I mean, if you have cameras and so on, yeah, the cybersecurity considerations are important to have. Okay, so as we have no questions, we're on a tight schedule. I recommend that we proceed. So many thanks, Joaquin.
Thank you.
Okay, next presentation, please come from Cristiano Novello, Senior Principal Design Engineer at Cadence Design System. Is also proven in use because also 2 decades of experience in semiconductor development and then also safety. So, floor is yours.
Good day, everybody. Are you tired? No, that's good.
You will be.
You will be. No. By all means. I'm very happy to be here. Hopefully I can use this pointer. Probably this one is going like this. Yes. So the title is No Safety Without Structure. A little bit, I tried to put a punchline. So the subtitle is A Systems Approach for Safety Critical IP. So we are going back in the semiconductor business, like we did yesterday with Farzad, and his wonderful presentation, by the way. I have to thank also the organizers and all the presenters so far. I guess Christopher yesterday said that there are 2 extremes by which we can learn. And that reminded me of a statement from Oscar Wilde that says that experience is an euphemism by which we describe our errors. So since I did a lot of mistakes in my career life and also some mistakes in my other life, I can say I have a lot of experience. I will try to share something with you. So yes, that's me. Again, I will steal some part of the presentation from Christopher. That's me 12 years ago, before starting safety. Now you see all the gray hair. So my background is semiconductors. So I'm not into OEM, tier 1, tier 2. I work with these companies as a supplier, but I am born and bred in semiconductors, so down there in the value chain. I did design and implementation So for several companies, mostly in between Austria, Germany, a little bit of Switzerland, and then now I am back in Italy. And then 12 years ago, 13 years ago, I moved over to FUSA. So I have had the opportunity to interface with different teams. So project management, design, digital design, RF, analog, whatever. Also production. And had lots of sometimes heated discussions. I guess probably also from your experience, you share the same. I see somebody nodding. So my goal today is to be short, sweet, and simple, and to indicate some actionable items, because my work, as I guess most of your work, is to interface with people that outside of this room do not live in the what I call the safety cloud. So among us, a lot of discussions are known, the terminology is known, but we have to interface with people that, honestly, we have to admit, safety is not their utmost concern, at least at the beginning of the project. Then it becomes. So the idea is to give them something to do, not only theoretical discussions. So very briefly, my context. My context is I work for Cadence. Cadence is an ADA provider, okay, so tools for semiconductor design, but it has also a business unit that sells IPs. IPs are blocks that then are bought by different companies and integrated together to form a generally bigger systems on chips. So here some aspects of the company where and the business context where I am into. So some factors to consider to better understand my presentation. So again, time to market, I guess that's ubiquitous for everybody to understand. Different methodologies. Cadence is quite a big company. I hear most of you also come from big companies. So methodologies are, we have also to admit that methodologies are not always streamlined across the whole company. This is at least my experience. And that brings some different contexts, some different experiences, also some different cultures. Also, we need also to take into account that we have to interface with different level of abilities and expertise in the design community. Okay, so we might have people that have a long experience in design, but they are very new to safety. So the 4 aspects that I'm going to present today are these 4. So it's the importance of functional view. Importance of functional view versus a structural view. Then the importance of having a conceptual map in order to facilitate communication among stakeholders. The importance of written documentation. Okay, I'm going back to the basics here. I hope that won't disturb you too much. And then finally, the usage of patterns. So generally, when I interface, and I work in different capacities as architect, so functional safety architect, engineer, assessor, project consultant, and things like that. So one of the first things that I find recurring when interfacing with designers is the difficulty to think in terms of what can go wrong. This is specific to semiconductor. I don't know if for other industries, but for semiconductor, this is something of a peculiarity. I think that one of the problems that we might have in this situation is that a lot of our design engineers think in terms of functional trajectory of the system. So they think they are trained and they continue to think of what should happen in order to get the desired function. When we start thinking or asking them to think what could happen if we deviate for that trajectory, then we have 2 situations. We have the one extreme that will say, oh, nothing will happen. We are absolutely sure that we did the best system possible. Or the other extreme is everything can happen. It turns out that we have a problem that of the blank page, so where we don't have the ability to write down the failure modes, and that led me also to find out this paper, which I recommend also to your attention. Is a quite dated paper. Still, I guess it's very important because it goes and explains the basics. So the link is down there. In this paper, Dr. Burge affirms that FMEA deployment is often fraught with difficulty and this application is ephemeral. It was quite a punch in my belly at that time, but I could relate to that because a lot of the FMEA analysis were not really had something to say on the design. So the problem that he argues, and is arguing, I agree with him, is that we have a fundamental problem in understanding the concept of failure modes. The concept of failure modes are better described as malfunctions. So in order to overcome this blank page effect that the designers find themselves confronted with, I argue that rather than blocks, which are very common in semiconductor industry, we should start from function definitions. So for me, functions define, as you can read, the technical obligation that are expected from each component of the system and the system itself. So having in mind a clear definition of function, hierarchical over the entire structure, is a very powerful approach that can help us in construct malfunctions. How? Simply applying a pattern. So, and generally, so Dr. Burge proposes this pattern of anti-functions. So you take the function definition and you can define anti-functions, will generate then, will then in fact are the malfunctions, applying these patterns. The pattern that he proposes are 5. It's no function, over, function, under, function, intermittent, and unintended function. Clearly, these patterns need to be adapted to the specific understanding and subject matter knowledge. But in my opinion, are one actionable item that we can have in order to find out what are the failure modes of our systems. By the way, this is not a new idea, and here I would like also to compliment with all those that worked in the ISO group for the standard, which in my opinion is a solid standard. In part 11 about the semiconductors, we have a similar idea. We have failure mode of digital components that you can see here, where the authors of the standard speak about the same idea, speaking about function omission, commission, timing, and value. So this, I'm not claiming that this approach should be the only one. We still can combine this approach, for instance, with outputs analysis, which is very common in the semiconductor world, where the first thing that everybody is presented with is the block level diagram. So the block level diagram is the ubiquitous piece of evidence that we have. But when we ask about the functions of the different blocks, everybody goes, so once I had this recently, I spoke with somebody and they gave me the architectural spec and I read for the first time functional description, and they had 5 bullet points. And they said, oh, in the 5th bullet point, it's a very interesting. No, but that's just for an example purpose. So this is exactly the problem that I want to touch. The functional description needs to be done precisely and with intelligence. I mean, with effort, with effort from the entire community of designers. As an example, UCIe. UCIe is a standardized interface that nowadays tries to solve the problem. So the upcoming problem of density of design, putting together different implementations in a singular chip. Here, we have two lists of functions where the three layers that compose the UCIe are subdivided by controller and by PHY. And in the next slide, you will see, for instance, the application of the patterns that we were discussing before. For instance, if we have a function called link training, which is the training that the UCI interface needs to do on the sideband to start exchanging communication parameters in order to optimize the transmission and the reception of data. So we can directly apply this function, directly apply these anti-patterns, and come to a list of statements that could give already some hint in order to find out the failure modes. I applied this procedure with a team that I am working on a recent project, and that I have to say that helped overcoming the first barrier of difficulty in finding out the failure modes. The second point that we need also to discuss is the need of a conceptual map. Here again, I take from Burj this diagram. This diagram, it might seem just a picture, but it's an important picture in my eyes. And I would like to tell you in just few words why. We are juggling with a lot of abstract ideas. So it is difficult, and I have noticed also in other presentation, it is difficult to find a common ground among us, among the digital designer, the analog designer, the system designer, the architect, the guy that does project management. So in order to define, in order to have a good communication, we need to define terms, and we need to put them into relation. The details of this conceptual map are in the paper. Unfortunately, the time is short, and I won't get into the details. Another hint that I would like to give to you is that these type of maps can be used, for instance, also to create informational databases, like your requirement management tool. I took that idea that Burj presented in his paper and moved it, as he suggested, also to application in our domain. This picture, I use this picture when I interface with teams in order to explain them the concepts and the terminology that I am using in order to find a common ground for explanation and for understanding. So as you see here, we have in the upper part a description of how a system, function, and requirements come together. The picture tries also to have some sort of symmetry, in the sense that another problem that I faced, especially with things like legacy, with this, so the panelists were discussing before, is that sometimes you might find yourself in projects where the technical concept from which you should derive or on which you should grow your technical safety concept does not really exist, or does not exist in a good form, or is dispersed. So as you see, there is some sort of symmetry on the vertical side, so where you see the symmetry between the TSC and the technical concept. And the same applies also for the FUSA requirements and the functional requirements. That was important also because the fourth idea that I would like to bring to you is the importance of written documentation. And generally, the situation that I am facing is this one. We do work a lot with so-called RTL code. And everybody claims that the code is self-explanatory, obviously. Obviously. So yes, it takes time, it takes resources, and it lags because documentation always comes afterwards. Still, I guess there is one important point that written documentation fosters precision. And the Latins used to say, verba volant, scripta manent, which means words fly, but the written words remain. Since it fosters precision, it minimizes ambiguity and misunderstandings. I guess that's a given. And again, it remains over time. Another thing that is very important that sometimes is neglected is that it allows a faster ramp up of newcomers in the groups, which is not a very unusual situation. Okay, so, but we have to admit that writing and reading is not anymore a given task. I have been developing processes and find out that a lot of people prefer to call me to understand what is written in the process instead of RTFM. So, and this is the fourth idea that I would like to give you. Yes, we need to cope with the situation that a lot of us, say it because of the smartphone, say it because of the socials, whatever, we have a difficulty with the written word and with the read word. So I recommend to use patterns. Patterns is a very old idea, starts from a very old book in the software domain, Design Patterns, but goes on also in application, as well in the malfunctions, but also for requirements. And here I would like to refer to you two examples. One is the ears, which is the easy approach to requirement syntax, and the INCOSI guide to writing requirements. So 2 words on the ears pattern, literally 2 words, is a mechanism to gently constrain your textual requirements. So you won't be either be too scanty or too verbose. They put some sort of rules, very simple rules, and that is the beauty of this idea, in order to have a common ground for explanation. So these were my 4 aspects of structure. Let me argue briefly why I think there is no safety without these 4. Without these 4, if we don't think in terms of function, we start. It is more difficult to brainstorm, for instance, interactions, and it's easier instead to brainstorm about malfunctions. Moreover, we think in terms of the end goal, which is the safety of the system and not the technologies themselves. Having a clear conceptual map avoids logical traps and misunderstandings. And finally, patterns lower the barrier to an agreed written form. So, first of all, maintain a functional views of your system components, not only a block level diagrams. Second, define a conceptual map. You have an example, but you can grow on your own and be consistent. Fourth, foster good and understandable written documentation by example, in the sense that the safety group should be the first one to write good and solid written documentation. And finally, use patterns to help you think and formulate clearly. There is a 5th one, which is this one. First, find somebody to blame. Generally, is this always the functional safety guy? Thank you very much. I'm done.
Yeah, very true, very true. Okay, first question here. Documentation. I don't have time.
Thanks. It's Yavash from ABL. In the first slide, I suppose you had described the goal that was to have a better life cycle. If you could move to the first slide, maybe it's better. And yeah, there my question is, what does that better mean? How do you measure or describe in the very first one? Let's go. Yeah.
Sorry, this one.
Yes, to indicate some actionable suggestion for better safety life cycle. Then how do you define parameters for this better from engineering point of view or from management point of view? How do you define KPI?
So, very good question, very technologically oriented. I can see you are an engineer like me, but I like to bring you to another idea. For me, for instance, better is starting really from a written documentation aspect, which is up to date, which is, for instance, not always the case. So I can tell you now the KPI. The KPI would be the time that I take, for instance, to ramp up all the members of the program, of the project, in order to be able to deliver. I cannot give you a number, or I could give you a number, but I don't want to give you the number because probably I would embarrass myself. The problem that I see in better, for instance, in this situation, is that a lot of time is spent gathering information from oral sources, like the Indians passing around the pipe of peace, because that's the situation that I am facing in several companies. Instead of going directly and discussing the matter at hand. This is one point. The second point is also, for instance, the explanation or the definition of requirements, which sometimes, also done by non-native speakers like I am, is not done clearly or is not, it does not follow, for instance, the grammar rules. So it is difficult to understand. If we write down a requirement, but then what the information that comes at the other end is wrong, then we have lost the time in writing the requirement. Plus, we have the problem that the other counterpart is not able to understand. I guess the KPIs are time and also frustration, which is difficult to quantize. But it is a sentiment that is there in sometimes in functional safety. At least this is what I have seen.
Yeah, thank you. But let's say regarding documentation in ISO 26262, there are a lot of clauses regarding it. And actually, when we have the architectural design, unit design, and then implementation, it means that somehow also we have the documentation behind it. It is we should. It is mandatory.
It is mandatory, yes, but please, probably we need. I need to tell. I don't know if other people might agree. I don't know. I'm curious. But the ISO standard came because also probably there was not a situation standardized like that before, and there might be still holes or places where that situation is not yet completely there.
Yeah, I agree that it is important, but I mean, it is already defined in the standard. And when we have the requirement and it is the pattern, in the standard, we have the semi-formal language. And what I understood from the pattern introduced there, it's kind of syntax for the requirement. Yeah. And when we add the syntax to the requirement, it is semi-formal. So there again, we have, depending on the complexity and on the ASIL level, we have the highly recommended semi-formal language. Yeah. So this is again one obligation in the existing standard. It is. I was looking for something new.
No, it's not new. I admit, I am very candid. It is not new because I think that there are still some, these ideas need still to be trained, thought, and also thought and teach. And that's not a decision. So it's a deliberate decision to come back to these ideas. Farzad in his presentation said it is important to have knowledge in applying. And I guess this is important because, for instance, a lot of people in the semiconductor business have a lot of knowledge in design, but the knowledge in functional safety is a little bit, or these methods, which are in fact orthogonal to functional safety, these are system methods. So we need to repeat again and again. And there is a value in this repetition, in my opinion.
Thank you.
Okay, I would like to, I know you need a try to catch.
Thank you very much.
But thank you. But I agree, yeah, documentation is very important. And documentation is not only also for pre-release, but our job as safety engineers is to make safe products, one. Second is to protect ourselves, protect the company after things are happening. And without documentation, you cannot justify what you have done, why, and if you have a legal case, I don't think it will be easy. Next presenter, Max. So again, Max Walter, you know him already from Siemens, not really automotive, but I think, yeah, still related. Please.
Okay, yeah, thank you. I have the honor now to stand between you and the lunch, right? Or is there another presentation afterwards? And I have brought a very boring topic, or at least boring title. Yeah, it's about safe communication protocols, but I hope it will not be as boring as it looks. And I'm also trying to be in time. So what do I mean with safe communication protocols? I think we see them both in cars, but also in factories. Yesterday, it was talked about steer-by-wire. This would be a good example. If you think about a steer-by-wire system, you have the sensor, which is actually the steering wheel, and then you have to transmit the data from the sensor to an ECU, a controller, where the decision is made, and then again, you send data, let's say, to the electric drives, which control your car direction. And of course, this kind of communication has to be safe itself. If we send this data and receive different data than was sent, this would be highly unsafe if we don't detect it and react accordingly. And the same situation we also have in our plants. There we are using these kind of fail-safe controllers, for example, and we are using communication protocols such as ProfiSafe, which is running over the field bus. And we are doing this quite some time, since 1999. Okay, so here's one example. So this is a car manufacturer here in Bavaria, in Ingolstadt. And it is the world's first virtual PLC in a real production environment. So this is a cooperation between our customer and our new product, which is called the virtual PLC. I will explain it here on the diagram. This one or not? Okay. Yes, it's on. Okay, thank you. So we have two buildings here. So this is the shop floor with the actual factory where the cars are manufactured. And then here we have another building, which is the data center, yeah, where all the IT infrastructure is inside. And this is now new. Not only we have there on the compute clusters, the servers which are used for emails and stuff like that, but we are also running here now virtual fail-safe controllers on this IT infrastructure. And this means that the sensors which are here in the factory, they transmit data. For example, the sensor could be a door sensor, which detects whether a door is open or closed. Yeah, and it sends this data via the IT infrastructure to the fail-safe PLC. Then here a safe decision is made, and then data is sent back to the factory floor. For example, stopping the robot if somebody opens the door where a robot is inside. And as you can obviously see, if something goes wrong here on the wire, and you would not be able to detect it, this would be dangerous. Yeah? For example, it would assume that the door is still closed, although it's open. Yeah? So now the question is, how can we detect communication errors here on this wire without having to implement the whole IT infrastructure in a safety-related way? Now, this is, of course, impossible. Yeah? We cannot tell the IT guys to apply functional safety standards to their common off-the-shelf routers, to their cables, and so on. So in a diagram, this looks more like this. So now abstracted, we have two devices. Device A is the sender and device B is the receiver. We have at the lower level the communication channel, which I have marked here in gray, indicating that it is not safety related. And we have some safety communication layer on top of it. So the two parts of the safety applications, they want to communicate with each other over the standard physical communication link. And we have the standard communication in gray, which has the following task. It has to do addressing, sequence, flow control, also reliability. So it has to do error detection, retransmission if an error occurred, maybe even redundant cables if you want to be able to tolerate the failure of a whole cable, and also quality of service. Yeah? If we are talking about real-time systems here, so this must be a fast communication channel. So you now may be wondering what is now the task of the safety layer, because everything we need is already here. And the answer is the one and only task of the safety communication layer is now to monitor the behavior of the communication channel below. Yeah? It must detect all errors which may happen there and then react in a safe way. Typically, we are talking in factories about fail-stop systems. So this means this part of the system is stopped or shut down. And not only must it able to do that, we must also be able to do that with a guaranteed low probability of failure. So we call that a PFH, probability of failure on demand. And I think the corresponding term in automotive is PMHF. So it's the probability. We don't do error correction, fault tolerance, or anything like that in the safety layer just because we want to keep it simple. Yeah? So we assume that error correction, fault tolerance, and everything has already been done in the lower level. If there's a problem with that, it's not in the responsibility of the safety engineers. Then we use our finger pointing at the other people and say, okay, you have done something wrong here, and for that reason, we stopped your system. No? So that's how we deal with it. For the record, we talk about fail-stop system. Probably in the car, there are not only fail-stop systems, but also fail-operational systems. They more or less don't exist in factory automation. And we also talk about here only about point-to-point communication. So if we now look at the international standards, of course, in the automotive domain, we have the ISO 26262 standard. And in the industrial domain, it's a little bit more complicated. We have the 615OA as a safety standard here, and we have the 61784 as a standard for communication protocols. These are where all the field bus protocols are specified. And for functional safety on field buses, there's an extra standard, which is part of 61784, that's part 3. And this document contains the requirements for functional safety for communication. So if you are interested in this topic, you can read this specific document. It's not like in the ISO 26262 world where communication is part of the overall standard, but we have an extra standard here. And this 61784-3 standard contains the requirements, what has to be done for functional safe communication. And then we also have standards describing actual solutions, actual protocols, which fulfill these requirements. So for example, -3 is then ProfiSafe, which is standardized. So there are multiple vendors implementing that. So you can plug in your factory components of different vendors together, which then can communicate in a safe way. What is in this standard? So we have a table here. telling you what can go wrong in communication. And I think it is very similar to the corresponding table in ISO 26262. You find it in part 6. For example, we have this corruption topic, that a single bit may flip while you are transmitting the data, but you can also lose a message completely, or you can mess up the sequence in which telegrams are delivered. It can be late. It can be an addressing error. A telegram is going to the wrong receiver, for example. And it turned out to make sense to group these faults into 2 groups: the data integrity faults, timeliness faults, and addressing faults. And then we end up here with this abbreviation TADI: timeliness, authenticity, data integrity. And this is also how I will now explain it in this presentation. And let's start with the timeliness faults. So these are loss, delay, insertion, incorrect sequence, and incorrect sequence. And to deal with timeliness errors, the first measure we do is that we use always cyclic communication for safety communication. Because if we do cyclic communication, the receiver has an expectation. The receiver knows that, for example, I expect every 10 milliseconds an incoming telegram. And now if we implement a watchdog timer, we can then say, okay, if the watchdog timer expires and no telegram has been received, I know that the message must have been lost. So this is this example. If these messages are lost, I can indicate connection is lost. And also important maybe to note, before I get the first message, I also indicate I have not yet a connection established. And only in the area between, I say, okay, there is no error, so I can deliver you some process values. Then if we talk about incorrect sequence, of course, it makes sense to add a sequence number here. And if you look at these measures, the cyclic communication, watchdog, and sequence number, we can also clearly see that we are now able to also detect messages which are delayed. Because if, for example, the message 2 is too late, the watchdog will expire. Do you agree with that? Or not? And it turned out, it looks very easy. Many people would say, yes, it is. But there is one really subtle error scenario where you can see that it will not work. And this error scenario is called slowly increasing message delays, which you can see here. So the sender is sending a telegram every 10 milliseconds, but over time, the delay of the messages slowly increases. And if you have that, you have a distance between these telegrams at the receiver, let's say, of 12 milliseconds. So the watchdog will not trigger because we have said earlier the watchdog is at, let's say, 15 milliseconds. But if you look closely now at the last message here, you see it's already 18 milliseconds old. So it's definitely too late, but you are not able to detect this with the watchdog. And if you continue this graph, you can even show that the message can become arbitrarily late and it will nevertheless trigger the watchdog. So you have a problem here. And the solution to solve this problem is to do this kind of ping pong pattern here. And here you can now see, so I'm turning around again. You are now measuring with the watchdog the time from here to here. And so the trick is this sender is only allowed to send the next message once it has received the acknowledgement. And by that, you guarantee that this watchdog will measure both this communication direction and this direction. And clearly, it means that this direction here cannot be older than the watchdog. And by that, you guarantee that you will detect delayed telegrams, even in the scenario of slowly increasing message delays. Next topic or next type of errors is addressing. So if you have a system with multiple senders and multiple receivers, of course you have to take into account that addressing errors may occur and you are communicating with the wrong instance. And that can be, of course, dangerous. And addressing errors that you can be classified into three types. It could be permanently incorrect configuration, that you have plugged in your system in the wrong slot, for example. Or it could be an error at connection establishment. Yeah, you're starting up your system and you from the beginning you are talking with the wrong instance. Or it could be a fault, a transient fault maybe, during the cyclic communication. All three cases can be addressed or can be mitigated using another address, a safety address, which has to be assigned to both the sender and the receiver in an independent way. So it's important that you do that independently. You are not allowed at connection startup to ask the receiver, what is your connection ID? And then we are using that for the communication channel, because that would not mitigate the fault at connection establishment. You are establishing the connection with the wrong receiver, and of course you will also get the wrong address. So this is important. You have to set these addresses in an independent way. And now also the question is, and of course it only works if the safety IDs are unique within the network. And this also means that if you have bidirectional connection, which goes in two directions, you have to use different safety IDs for each of these directions. This is also important. Typical problems involved with addressing is to keep track of the safety IDs with multiple teams. If you do replication of projects like instantiation multiple machines in the same plant, then you must not copy the addresses, because then you have duplicates and so on. Yeah? So it becomes more and more difficult. And for that reason, we are also now using addresses which are very large, 64 bits and more, and which are randomly generated. And we can show that then there may be duplicates in the network, but it's so unlikely that it's even from a safety point of view, it can be neglected. Okay, I'm running out of time a little bit, so I will make progress here quicker a little bit and come to the last topic here about data integrity. And this is protection against random bit flips. And the classic way to detect communication errors, it's very old, it's cyclic redundancy codes. And the challenge here is to use the cyclic redundancy code and to also determine the residual error probability. That is the probability that you have an error in the telegram, but your redundancy code will not be able to detect this. And for example, in 6.17.8.4-3, we have these requirements for the different SIL levels with respect to the PFH. And also in the ISO 26262, for example, there's a lot of written information about the so-called qualitative analysis, Hamming distance, and so on. So for example, I have this citation here saying, okay, if you have a message information, message ID, CSC size of 10 bits, polynomial, then you have a Hamming distance of 4 for a data length of 501 bit. But the question now is, what does that help me if I want to calculate the PMHF or the PFH? Huh? So it's the Hamming distance, it's a qualitative measure, it's not a probability. And now, what is important now? I'm running out of time a little bit, but there are two methods which can be used to calculate it. I have it here for you as a reference. And you have to use one of these two methods, because there are also simplified formulas, but none of these formulas are correct. So you be very careful if you use some kind of approximation formulas. For example, sometimes you see the misconception that 2 to the power of minus r is an upper bound for the residual error probability, so that you have some kind of upper bound. let's say if you're using a 16-bit CRC, that it's always 2 to the power of minus 16 is always this error probability. This is not true. It's not even a rough upper bound, as we will see. Next misconception is if you have long user data, the longer the user data is, the lower the residual error probability becomes. It's also not true. And the final misconception is that there are any kind of approximation formulas, and this is not the case. So I will just give you some counter examples here. So this is a 16-bit CRC, and we have calculated using one of these two methods I mentioned, the residual error probability. So what we can see here on the x-axis is the bit error probability. And what we can see on the y-axis is the residual error probability of this polynomial. So the probability that there is an error which is not detected. And you can see here, this is the so-called upper bound, 2 to the power of minus 16. And yes, most of the time, this graph is below this line, but there are exceptions. You can see here, sometimes the residual error probability is above this threshold. So if you want to calculate conservatively, you cannot simply assume this value, but you have to calculate these curves. Moreover, these curves here are the long telegrams with many bits. And these here are the telegrams with short bits. Typically, you can assume, you can see this green line here is always below the other lines. So the shorter the telegram is, the better the residual error probability becomes. But as you can see here, again, there are exceptions. Sometimes the short telegrams have a higher residual error probability than the long diagrams. So it's not enough to only calculate the longest data you're using and then concluding it gets better if the data is shorter. That's not true. You have to calculate it for all data length in use. More examples for if you are interested. This is also, of course, valid for 32-bit polynomials. And this is a good example. So here we have calculated for one telegram all data length. And here you can see for this specific type of polynomial, you can now see that it's always below this threshold. Okay, I will skip some slides, come to the summary. So here I've put the 5 measures we are using in safe communication protocols. Cyclic communication with receiver watchdogs, sequence numbers, safety IDs, and cyclic redundancy codes. If you do that, you can also calculate the residual error probability. You can calculate these PFH values. But as always, the devil is in the details. And I've shown some examples where you have to be careful. And for that reason, in industrial communication, we rely on standardized protocols, such as ProfiSafe. So we don't do this calculation and this implementation every time again. We use the same protocol for different applications. And that helps us, of course, to make progress faster. Yeah? Okay, that was it from my side. Thank you.
Thank you. Yeah, very interesting, because this is something often neglected, and yeah, the calculations are very important as well. Questions? One here.
Yeah, Christian Nowak, TÜV Süd. Just one question. So I kind of understand the principle of the CRC calculation and how you also calculate then the residual error rate on the communication. So do you also do this for the addressing and for the timing related faults, or how is this then basically done?
Yes, so we do the quantitative evaluation for the data integrity error, but we also do it for timing errors and addressing errors. And more or less, you take into account the length of the address bits and the timing bits, and you say, okay, how many bits have to swap in error? So if you have an only addressing error, then the probability of detection is 100% because the address will not match. But if you have a combined error, let's say you have an addressing error and the addressing bits are falsified, then you can calculate in a similar way the residual error probability. But you're right, this can also become tricky.
Yes, because I've also seen some examples where you have a good calculation, let's say for the CSC and so on, but for the other failure modes, then maybe a little bit more difficult.
The new version of 6.17.8.3 requires also a quantitative evaluation for the addressing and timeliness errors.
All right, thank you.
Thanks.
So Vincenzo from Scube. So in ISO 2662, for the calculation of the PMHF, you need to assume as basis for the calculation some reliability standards like Siemens norm or ICTR 62380 or internally, let's say, generated data. So this means that the PMHF is parameterized towards those standards. So you can have different PMHF, based on the standards you have decided to adopt. Now, with your approach, you will only get basically one number, which will be a probabilistic number. So how do you harmonize that number with the, potentially three different PMHF results? And, how do you benchmark that number with the, PMHF?
Yeah, so we have this similar concept. It's called PFH, but it's, I think, very similar. And you have this safety function, which has a sensor, a controller, an actuator, and a communication in between. And we add up these values. So you have one value for the controller, one value for the sensor, one value for the actuator. And then we use this number, which we have calculated for the communication line, and we add up the 4 or 5 numbers to get the PFH value of the safety function. Was that the question, or?
Yeah, what is the basis for that calculation? Is do you use any standards as basis for the calculation or reliability standards, or not at all?
Yes, if we talk about the controller, for example, you use some kind of hardware reliability values, and then you multiply it with the safe failure fraction. And that gives you the PFH, for example. And here for the communication channel, we assume a bit error rate, and then we calculate the residual error rate. And then we end up with a contribution to the PFH value.
Yeah, I guess maybe the disconnection here is that you're maybe thinking about the permanent faults. And I think here the bit error rates are more due to noise, intercommunication. So maybe a different kind. You're not talking probably about permanent faults. You're talking more about transient and noise, EMC, and so on.
In communication, you have to consider transient faults, permanent faults, and intermittent faults.
Yes. So I think we should differentiate maybe the coverage you can get from the actual fit rate that depends on what you want to cover, yes.
But I agree, in communication, the contribution of transient faults is probably much higher than if you are talking about an integrated circuit.
Yes.
Because you have noise and interference and things like that.
Okay. Okay, quick question and quick answer. Otherwise, no lunch. Attend.
Thanks. Philipp Schleiß from Fraunhofer IKS. One more high-level question, which is maybe beyond the communication part, but I was wondering, you made the communication super safe. What prevents the application running on a just off-the-shelf server from telling the robot, hey, the door is closed, even though the door is open?
I see. I have to come back next year for the next presentation.
Good, to be continued.
It's out of scope of this presentation. Yeah.
Okay, let's close here. Many thanks. Okay, next presentation before lunch. So I would like to introduce Kevin Cavatia, Senior Functional Safety Engineers at the Borg Warner. And that is a very interesting topic about design FMEA, IAG VDA, and the connection to functional safety. Please.
Good afternoon, everyone. So today I will be presenting harmonizing AIAG VDA standard and ISO 26262. We will examine the challenges and the resolution associated with this effort. So first, let's answer like why FMEA? Why do we need FMEA? So FMEA is a inductive approach used to identify potential failure in product, process, or system. It helps us in mitigating risk. So it's a risk prioritization tool. The importance of it is that it avoids harm to people and it reduces the cost of development by detecting fault earlier on in the life cycle, and you would be able to avoid the failures in the later stages of the your life cycle, like production. So here is the agenda for today. First, we will talk about both the standards, so AIG VDA, the first edition, and ISO 26262. Then we will talk about the gaps and the resolution between these two standards. Then we'll talk about, we'll walk through how do we resolve these gaps and the misconceptions. And then at the end, we'll talk about the value proposition that FMEA MSR brings to the table. So first, AIG VDA FMEA handbook. So it provides a single standardized and systematic approach for developing system and hardware design FMEAs. And on this edition, we have an additional FMEA, which is called FMEA MSR. It's a supplemental MSR, supplemental FMEA, which is not necessary, but it's recommended. So the benefit here is that it ensures technical risk management, improves quality, and fosters better supplier-customer communication. It follows a 7-step approach as shown in the figure. Then the next one is ISO 26262. No one needs introduction to this, so we'll just quickly go through it. So it provides a comprehensive standard for safe development of electrical system throughout the entire vehicle or product life cycle. The benefit it mandates a structured development process to ensure that safety requirements are correctly defined, implemented, and verified at every stage. And the ISO is divided into 12 parts, but I'll be mainly focusing on part 5 for our discussion today, which is hardware. So let's go through the key gaps and the misconceptions. So the first gap is that there is a missing clarity in ISO, or I'm sorry, in AIAG VDA standard, that what should be the severity rating for any failure of safety mechanism or basically any diagnostic function. The second one is that how do we deal with the analysis of mechanical parts over the product life cycle. So common misconception includes firstly that AIAG VDA standard focuses on functions while ISO 26262 focuses on requirements. The second one is the use of safety analysis as a preventive measure. Thirdly, the difference between fit rate and occurrence number. The fourth one is use of safety mechanism as detection measure. And lastly, the difference between safety relevant items and special characteristics. First, let's talk about the key challenge in FMEDA, or basically the DFMEA today. How do we assign a severity rating to a failure in a safety mechanism or basically any diagnostic function? So a failure in safety mechanism have two main modes. Of false positive, it's the case when the safety mechanism incorrectly identifies a failure of a primary function and it forces the system into a safe state or a limp home mode or a lamp on. The second mode is a false negative. Here, the safety mechanism fails to identify a failure in a primary function. And here we would basically, it would be a failure of a secondary functionality. So in a false positive, we would have a severity rating of 8 because it's a loss of primary function. In a false negative, we would have a severity rating of 6 because it's Okay, so yeah, it would be severity rating of 6 because it's a loss of a secondary function, which is a diagnostic function. So at BorgWarner, we developed a clear adaptation of this. We ensure that to ensure that we capture the most critical impact, we default to the worst case analysis. Therefore, we assign any failure of safety mechanism with the severity rating of 8. This ensures that failure in our diagnostic function of safety diagnostic function is prioritized in our FMES. So we'll move on to the common misconceptions. We'll come back to the second gap at the end of the presentation. So the first common misconception is the difference between safety relevant items and special characteristics. The idea of special characteristics is not that it's only related to safety. The scope of special characteristics is much broader. It denotes a product attributes which incorrectly if incorrect significantly impacts fit, form, function, performance, or legal compliance, but it's not always necessarily safety. So here is the critical relation. All the safety related items or functions should be marked as safety critical, should be marked as safe special characteristics, but not all safe special characteristics are safety relevant. We often see FMEAs where only functions that are related to safety are marked as special characteristics, which are basically severity 10. And we believe that this is a wrong approach, as it misses out on critical non-safety related functions. So let's take an example of a squeaky brake pedal. It's not safety related. It would have a severity rating of maybe 6 or 5, but it is a customer satisfaction issue. So it would be very critical for an OEM, and it should be marked as special characteristics in the analysis, but it's definitely not safety relevant. So therefore we need to consider all the factors, just not safety, when it comes to special characteristics. Let's move on to the next one. The misconception that, or the confusion that everyone would have, that AIAG VDA handbook focuses on function while ISO 26262 focuses on requirements. So we might feel that these two standards speak a little different language, and many would perceive that it's difficult to integrate these two analysis. So that's the core challenge, that how do we integrate this seemingly different analysis, so basically DFMEA and FMEDA, through a clearly traceable link. So at BorgWarner, we have created this through step 3 of FMEA process, which is functional analysis. Here, the team identifies the major or basically primary functions of our product. And we use this step to concurrently link the safety requirements, which could be TSRs or FSRs. By establishing this link, we ensure that every safety requirement is systematically translated into system function within the FMEA. So we'll look at an example. So here is an example that I took from a project which is basically a inverter project with transmission functionality or transmission control. So here on the left, you can see these come from the higher level FMEDA, so FMEA, so basically SFMEA. And this is the block where if you see the function here that's applied to speed monitoring function, or VREF1, that is what we have in our DFMEA, that we need to ensure that the supply is provided. And the TSR is basically linked over here through a malfunction. So the malfunction is that the speed monitoring cannot be provided within the lifespan of 5 milliseconds. And that is a malfunction which is linked to the function from DFMEA. And the analysis over here, you can see from the component level, is from FMEDA. So this way we have linked our SFMEA with DFMEA and as well as with FMEDA. Okay, in this slide, we will answer the misconception between safety analysis and preventive measure. We often see that safety analysis results like SPF matrix are used as preventive measure in FME in DFME analysis. While safety analysis is evaluation tool which identifies failure effects during vehicle life cycle. So we are talking about the active life cycle. While the preventive measure is a design or process action which intends to eliminate or reduce the occurrence of a systematic fault in the design or development phase. So here the clarification is that the analysis itself cannot constitute a preventive measure. We can take insight from the previous project or like lesson learned from the previous project to define a preventive measure in current project, but we cannot use this analysis of the current project or like the analysis of FMEDA from current project to implement it as a safety or as a preventive measure. This slide talks about it shows the clarification between fit rate and occurrence rating. So fit rate is a quantitative measure of a hardware component's failure rate attributed to random hardware failures. It is generally provided by the supplier. Occurrence rating is it's a relative and qualitative rating that measures the effectiveness of the prevention control determined by applying the current like the methodology that a company has. This could be from a table that is predefined by the company, or it could be from a standard like a industrial standard. So the occurrence rating represents the likelihood of a failure cause occurring, while the fit rate is for a failure rate of a random hardware failure during the vehicle operation. So these two are covering different life cycle, a different part of the life cycle of a product. So we cannot use interchangeably a fit rate to occurrence rating. Next one is safety mechanism and detection measure. The key point here is that safety mechanism is electrical element or feature to detect, mitigate or tolerate fault or failure to maintain intended function or achieve a safe state. Our detection measure is used to detect existence of a failure cause or a mode before the item is released to production. So over here, the difference is again that we are applying at different stages of a vehicle life cycle. Safety mechanism is active during the vehicle active life cycle, while the detection measure is applied during the production or design phase. Now that we have clarified that safety mechanism is not a detection measure, we can move on to what is FMEA MSR. So MSR basically means monitoring and system response, and safety mechanism is basically the monitoring system response that is shown in FMEA MSR. So we use FMEA MSR for vehicle life cycle. So this is the supplement that I was talking about initially. It's not used during the vehicle production or vehicle development or development phase. It is used during the vehicle active life cycle. So we have come to our final key point. Here we address a subtle but important gap in ISO 26262. That ISO 26262 only talks about electrical component failure mode. It does not talk about purely mechanical components failure mode during the vehicle life cycle. So how do we bridge this gap which we have? What would be the analysis that would cover that? What would happen if a vehicle life cycle, if a component fails during vehicle life cycle? This could be stemming from wear and tear or operational stress or degradation. So this is where FME MSR comes in handy. We use this to analyze all these non-electrical components over vehicle life cycle. And this way we integrate that all our components are analyzed over the active life cycle of the product. And this way we achieve a true end-to-end safety analysis, which covers the entire life cycle. Thank you for your attention.
Okay, I already see questions here. Great.
Thank you for this very insightful talk. It was great to see. I have one question regarding slide 11. I think you mentioned something like you cannot use the analysis result for your current project, but only like the analysis results from previous projects. Why is that?
So what I have seen is that people use SPF matrix, like let's say you have a CLD system, so you are above 99%. So you say, okay, I have 99.1%, and they use that as a preventive measure. This cannot be a preventive measure because what you are proving from SPF matrix is that your vehicle is safe when it is on the road. While a preventive measure is a proof that you have a detection measure, prevention measure, so that the occurrence of a particular cause is lower. You cannot use that, oh, I have done my analysis that my product is safe on the road as a measure to show that, okay, this is the way I will detect my fault. You could use a old project. So let's say you have a project which is done and dusted, and now you can use that result and have a new implementation on your maybe production line or your design, where you say, okay, I have this, what I have found on the road, I can use this as my occurrence, I can use this as a preventive measure, so my occurrence number is lower.
More questions? Okay, one here.
Two questions. First is regarding the occurrence ratings for the system. Occurrence rating. So if you are building a first time product, let's say even if there are non-electrical components, how do you get the occurrence rating like 1 in 1,000 lag when you don't have the previous data?
So in this case, I'm assuming you're talking about a new technology or a new IC. The rating would be like 9 or 10. You have to give it high rating because it's not proven on the road. And for you to have a lower risk priority on your FMEA, you have to work with better detection. You cannot do anything about it unless it's proven on road.
Okay. And second is about the MSR, FMEA MSR. So is it done only at one level or like DFMEA where you do DFMEA at system level as well as sometimes at the component level as well?
Yeah, so this is
at one level.
Yeah, so that's a good question. That's a multi-layer FMEA. You could do it at system level, so this would incorporate into a part 4 of ISO 26262, or you could do it at hardware level. But in BorgWarner right now, we have started with the system level, and now we are trying to incorporate in our hardware level as well to answer basically this question that how do we make sure that mechanical failures will not cause us a critical failure on road.
Thank you.
Yeah, actually, I like this concept, new concept of the MSR, because usually the understanding is random or the false needs to be protected in the field with safety mechanism. Systematic false, you only do during production by prevention measures and so on. But actually, are we sure that all systematic faults can be eliminated with prevention? And I guess no. And MSR is also something that is telling you, hey, here you have a risk, then you also need to plan something in the field. And of course, at the system level software, I think this is already done. Even the ISO 26262, we are talking about range checks, consistency checks, like in the part 6. But many are still feeling, yeah, for the hardware, part 5, everything is done by process. And yeah, what is your view on this? Any comments about it?
I could not get the whole line.
What is your view on this point? Can we really address all systematic faults by prevention, or we also need to plan some measures for systematic faults in the field?
So for systematic fault, I think you have to have a prevention or a detection measure based on like what exactly works for you. Because on the field, once you are on the field, a systematic fault, I think, can cause a big loss. That's why I think that's why you have all the recalls, right? Because you found a systematic fault. It's not a random hardware failure that we're talking about. And so the best way is that you evaluate this and get it done during your production pre-production phase. And answering like how would you basically rectify a systematic fault on field is a very difficult task, I think, and very.
Yeah, the question is, can we eliminate all systematic faults during production through prevention measures, or there are still risks that we need to consider in the field?
Oh, we have to consider some risk for sure. Like there would be some risk. We probably might miss out on some things, and even I don't have a proper answer to this, I guess.
Yeah, it's something that usually is neglected because it's difficult to quantify, as we mentioned at the very beginning of the conference. If you have SPFM, LFM, easy, and yeah, that's my value. Systematic faults, have you done enough? And have you proved that you are okay? One question here.
Sorry, to just talk about another point. So I think this action priority concept over RPN is doing a better job, I feel. Before, I felt that there were times when the RPN said that, okay, this is a higher RPN, but I would think that it's not that critical item. But I think action priority does a better job at like quantifying that, okay, this is your higher risk item than the other one, and you need to take care of it.
Yeah, for sure. Yeah, I agree. Action priority is much better.
Okay, well, Siavash from AVL. Regarding the question if we can eliminate all the mitigate all the systematic failures before production, well, the risk would not be zero ever. But what is the acceptable risk? If we consider only occurrence and severity and multiple these two, not the whole RPN, but occurrence.
Action priority.
Yeah. Then we have a risk factor. The severity is 10 for the safety requirements. So we have one factor and it is only the occurrence. I do not remember in the catalog exactly what does occurrence 3 mean, but I remember something like it, that the occurrence 3 used to be mapped to a probability that that if we consider that probability as a failure probability multiplied by 10, then we can compare it with the SPFM. It is not regarding the life cycle, but if we consider that for a certain failure, we should have a probability less than 100 feet, then that occurrence value can help to correlate it and say, okay, perhaps beyond that 3, it is not acceptable because we violate every metrics, or perhaps 2 or 3 could be accepted depending on the ASIL. But regarding MSR, I am going to add one other comment that what it helps. In the FMEA, VDA FMEA, let's say, around 6 years ago, before having the IAG VDA jointly, there was the problem that when we have a safety mechanism, in FMEA, we consider single point of failures. But if we have a safety mechanism, and it is activated, we will not have the violation of the safety goal because the safety mechanism is working. If the safety mechanism is working, then it is not the risk of the safety, so it should not be classified as 10. If it not be classified as 10, then we put in FMEA a rank that is not standing for the safety. Then we don't know how to evaluate it. The MSR helps and improves this part, that we could have the violation of the safety goal in absence of the safety mechanism. But with the MSR, we can manipulate the severity later during the development. It is the very good advantage that has been added.
Yeah, that's correct. I did not add that here, but here you have to have the monitoring as 1 though. Only if your monitoring is 1, so basically very, very robust, you can reduce your severity. Otherwise, you cannot use your, that is the way it has been defined. Which I did not add this because I didn't think the discussion would go there, but yeah.
Yeah.
But the table that you talked about, like the 100 feet, and then it could be this. I have seen usage of that kind of table, but I don't agree with that because a fit rate is talking about random failures. While like if you are like, let's say, developing a new technology like a new microprocessor, obviously you are going to have higher systematic failures because it's not proven. It's not as tested as, let's say, a older micro which is run like millions or billions of hours on road, and then your fit rate could be similar, but your occurrence rate would be very different in these two cases.
Yep. Okay, the last question.
Yeah, maybe a comment on the previous topic. Sorry, Rogier Nap from Sesata Technologies. For systemic design, it's really about how you can estimate your reliability, right, with your occurrence. So it's affected also by your detection measure. So this is more the classical design of, okay, how well is good do I do my design? It's monitored by your quality performance. So you will see very early the early failures, right? You will see later the longer taking failures. It should be taken into account from a safety perspective because it can influence your architectural choices, right? A classical fuse is maybe a very robust fit value and a very reliable, could be a very good fit value. Making a more complex system with a lot of electronics behind is a whole different ball game, right? Now you need to build monitors and softwares and more complex maybe component. But a fuse, we all know, fails a lot, right? So is that the best approach, right? That's where maybe safety and system, how should I say it? Systematic failures need to be considered, right? Like what is the best system in the field? If it's very safe, but it detects all the failures all the time, it's also a quality nightmare, right? So you need to build enough redundancy in, or you need to build a good enough architecture so that you have a good systematic.
Especially going to something like now brake-by-wire, steer-by-wire. You do want to move to safe state. I mean, what is a safe state? Yeah, okay, but I think this is very interesting again topic. In many cases, when we ask about the safety analysis, everyone, yes, that's my safety analysis, but that is random failures. What about systematic failures? Yeah, that's a quality topic. But instead, is really part also of the functional safety. So.
Yeah, that's why I think we had this thing that we have to integrate FMEDA with DFMEA. Because if that traceability is it's maintained, you know that why severity 10 was given, and no one could say that, oh, my analysis is complete without doing either random failure analysis or systematic failure analysis.
The question maybe is how to combine the two, because there are a lot of commonalities as well. Of course, the root cause is different, but maybe the mitigations could be same. But yeah. Anyway, thank you.
Thank you.
Okay, the moment you were waiting for, lunch and network. Let's be back 2:20 or potentially even a bit before. But let's try to enjoy lunch with the network and let's talk. See you soon.
jedna. Ho, 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 ho. Ho, 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 ho.
Okay. Sorry to bring you back to reality. I know the lunch was good. The discussions are very interesting. Okay, are we ready to start? So, you coming in? Or... Yeah, sorry to put pressure, but I also have to leave on time. Maybe the flight will be late, but you never know. So let me close the door. Okay, let's start with the last afternoon of the session. And can we get the presentation here as well? Yeah, perfect. Okay, thanks again to be on time. Now we have a new presenter, so he was not part of the conference up to now. So welcome, Hassan Igazi, functional safety expert at Cariad. And also has been kind of proven user, been on functional safety area since 15 years. So please, the floor is yours.
Okay, thank you so much. Hello, everyone. I hope the lunch was tasty and good. I'm very happy to be with you today to talk about zonal architecture in SDV. So today I just represent myself, not my employer. So does anyone know how many line of code in the jet fighter F-35 contain? How many million line of code, roughly? 35, because F-35, yeah? Yeah. 10 million. Ricardo? Okay. So yeah, so it is roughly from 8 to 30 million. So if we are comparing how many line of codes to the L4 or L3, L5 autonomous vehicle, we'll see a massive difference here because we see in the car itself, it could reach to 500 million line of code. So this big difference is a trigger for us that it is more complex in software. So it opened lots of problems about how to manage the update and scalability of this software. So it could be kind of semi-data center on the wheel, not a data center because it's still limited resources. So this is the flat architecture, and this well-known picture everywhere from Clemson. So we see a lot of ECUs, a lot of wiring. So here we see from level 2, level 3, 4, 5. So we transfer the liability from the user to the car system itself. So we need more sense vectors, for example, more sensors, more actuators. So it means more software as well. And we see here the current paradigm, which is gateway. We have one gateway that connect the car or the vehicle domains here. And currently we are to a transition to zonal architecture. So zonal architecture is a paradigm shift for the architecture to support and realize what SDV means. So we need something easy to manage, easy to update, and instead of just updating 100 ECU, we need not just to cluster them, but to have a streamline update for each zone. So we have key advantage of the zonal architecture. So the first one, which is really obvious, it is not the motivator to have reducing wire, but it's a byproduct key advantage we could get out of this zonal architecture. For sure, scalability. We need 100 feature, but we need to make the hardware as a commodity for this software subscription model. So we need to add software as we go without the need for new hardware. So software, hardware decoupling. So many new companies, new players can join this competition by adding new features for just one ECU. So new software companies, which has no history in the automotive could also play in this field. And also, yeah, if for sure for this decoupling, we achieve how the OEM can save a lot of money for this. And also, most importantly, maintainability and upgradability. It is easy to maintain for ECUs instead of just 100 ECU. Maybe it is a catastrophe for tier 1 suppliers because, yeah, we will just focus in 2 or 3 or 4, but it is not a religion. It can be 5, 6, it's okay. And yeah, cost efficiency and the self-enhancement. Yeah, I cannot say safety enhancement is like something you get it because you have zone architecture, but you have to have a deliberate process and strategy to have this while you are reducing the cost to make just 4 or 5 ECUs to control your whole vehicle. So to tackle the issue and the functional safety challenge for the zonal architecture, we have to think in a different way. We have to redefine. Yeah. So what? Yeah, okay. Take photo, 3 photos, one for me and also for my wife. Okay. A redefinition of the principles. So the best one for my wife. So we have to redefine the principles. Now we have to think it is not ECU centric, but it is function centric. And virtual boundaries. So we are talking about millions of code. So boundaries now a lot of software. So we have one big ECU as a hypervisor and virtual machines inside virtual machines containers, and also another partitioning. So you have to think that boundaries now are software, and the software has lots of problems. Dynamic interfaces, like in adaptive AutoSAR, the binding of the software could happen, could occur in the real time, for example, in the runtime. And contextual deployment from different car lines. You have to understand the same function would be different from commercial to premium cars. And also for the zone architecture evolution, as we have said at the beginning, it is not a religion. You can have like 4, 5, 6, whatever, what you can able to manage. So we can say for this model, yeah, this zone architecture, not just aggregating IOs, it could be pre-processing and execution for the functioning in this localized area, for instance, or yeah, just forward IO, or it can be just pre-processing for the data. And also you might still have the legacy network for powertrain because you already have this in millions of cars and already reliable. So you can partially update your architecture. It's really impossible to have one zonal architecture or pure zonal architecture in just one release. So it is a separated or consolidated SU. So we see is a difference. Here, if we see criterion for fault containment, here we'll see that if it is separate, so strong physical isolation. However, in consolidated, it depends on robust partitioning and enforcement. Lots of software problems. You have to take off your configuration and with your stakeholders as well, third parties. Complexity is lower system interaction in the ECU. However, in this consolidated, we'll see it is higher due to partitions, scheduling, and the resource policing. Latency jitter, it's predictable. Per ECU, you have just a few functions, not hell of functions. We see here in the consolidated risk of interference a lot, requires time-space partitioning, and also scalability upgrades, modular changes per ECU. So it is not easy, and to update all of this, you have to have a good process campaign for the campaign, etc. But however, if it is just 1 or 2 or 3, so centralize the updates with careful regression for FFI. Yeah, so this is the conditional, the traditional ISO 26262 handling of the normal issue, whatever from powertrain, body domain, whatever domain. So we have this process strategy from safety goals until validation from the left to the right side of the V-cycle. But for the distributed ECU, it has a static set of functions, is assigned a fixed ASIL level and validated independently. Sorry, this is for the distributed. Okay, so we have static set of functions and the fixed ASIL. However, it is changed now. Yeah, so this still the normal safety concept. We have one ECU, specific functionalities, and well-defined boundaries. However, we see here, whatever your current setup here, we have central ECU, powerful one with a fallback. We have 1, 2, 3, 4 or more for the zone architecture. We can have here n number of functions, but also we have a lot of interference vectors with also another functions. So this should be handled. It is not easy like before. We have Excel sheet, we fill it, but we have to think something like, yeah, triggering this and handling this in good structured tools like SBOM, for example, to have this as like a triggering. Whenever we have functions, it triggers our FFI analysis, for instance. So as we see, one ECU could have mixed ASIL criticality. So we have ASIL X, A, B, C, D, whatever, and the QM, and we have to have here the right partitioning and isolation of the interference after our analysis. So this is just with one function and another function. So you have to think if there is lots of functionalities here, or it is just IO aggregator, or the functionalities in your central compute or in its fallback one. Okay. Quickly, we see also there is a lot of work in the TSN, how to enable the deterministic communication. So we have still powertrain and something working with real-time constraints, something 1 milliseconds or less than 1 milliseconds. So the Ethernet technology cannot provide this unless we also have another software, not native like FlexRay, for example, but we should have another layer of software, which is time-sensitive networking, TSN, to enable us our QS parameters like latency, jitter, time assurance, and traffic isolation. So it is like IEEE standards, for example, to improve the latency. So this time taken for a message to reach its destination. So with configuring this standard in the data link layer, we make sure that this is critical for control loops. For example, 1 millisecond control loops. We still have this in microcontroller, not processor, because microcontroller is still to live because it has a deterministic in mind, the deterministic approach, not like a processor just for performance. So I have a case study to show how our Zona architecture, for example, good for scalability and also will support us for fail operational or degraded mode. We, all of us know the front turn assist. It is like level 2. So when you go in your way and would like to go to turn right, so you as a root user have the controllability on the brake. So this is level 2. But once we think about level 4, for example, so liability would be on the system. So it is not just the ASIL B, it should be ASIL D. So think like we are driving to the right, and there is a road user. It can be cyclist, whatever. So let us think about this example. So the safety goal could be prevent unintended collisions with VRU or vulnerable road users during mid-speed turning maneuver. With ASIL-B, this is just if you have the controllability as a road user, so it is improved to ASIL-B. However, if it is, yeah, good, first time to use it. So if we assume it is level 4, for example, so this is ASIL-D. It would be ASIL-D. So we check here. For example, from the left, we drive the FCRs, TSRs, even here, because we have a service-oriented architecture. So we drive the service. We drive the service requirement out of this software component. So object detection service, vehicle dynamic service, turn prediction, collision risk. So this is like a traceability from safety goal to services. So this is the setup. The ego vehicle with 25 kilometers per hour. This is the speed. And pedestrian standing on the right curb. Road width 7 meters. So three different pedestrian speeds. We have distance to crossing the point. So this is like 5 meters. This is like this arc from the vehicle, 5 meters, and the pedestrian also has like 2 meters perpendicular to this arc, and the pedestrian path is literally. So we'll see here 3 different speeds, and this band, this red band is the path for the vehicle, and this dashed and this dashed one is the vehicle arrival. So we calculate the speed, the time to enter the path for each speed, okay, and calculate the FTTI. So basically we'll see the user or the pedestrian with the low speed is likely to have a collision with the vehicle if there is no brake or deceleration. So it is at the end, it is like optimization problem to get the FTTI for our system. So we put our functions in the zonal architecture ECU here in the front as this setup. So we have radar, right camera, also left camera with the radar to check the right pedestrians or the VRUs here. Okay, so what happens here is that we have a failure in the left, in the right ECU here, and would like the zonal ECU in the left to take over this. So they are talking to each other with heartbeat. They are talking to each other alive. But once the signal from the zonal ECU right here is not missing or delayed or corrupted, so the left one will take over. And we're sure we have to warn the driver for this or our system on the Ethernet vehicle bus. Yeah. So here, this is failed, and we still have in our strategy the capability to have a fallback on the level of the zonal architecture itself. Even if you can see here, the split field of view, part of it could be pre-processed from the front one and the other for the left one. And the left ECU still could do its part, so it could be degraded, or according to its processing performance, could process both the scenes from the cameras. So we have failover strategy, functional redundancy here with safety measures, for example, and the recovery could be in the next cycle of the vehicle. So conclusion, the transition to zonal architecture is redefining the vehicle as a dynamic software-driven platform. So we have scalability with this. We can add multiple functions, the runtime, and we develop this without many issues. Also updatability. We can update this easily, streamline hardware architecture, subscription software model, enhance fault containment, but still we have the challenges in determinism, mixed easel criticality. Okay, thank you.
Okay, one question here. So we're a bit out of time, but 1 or 2 questions should be okay.
So thank you, Alexander Matros from Electrobit. So first of all, at the ZVI, the German Electronics Industry Association, we have recently done a similar exercise, really decomposing functions onto different ECUs in its own architecture, and have seen that functions that have previously been similar ECU, that have one ECU, are now distributed.
Sorry, again, one function, what?
At the ZVI, we have done a similar exercise, composing functions in a zonal architecture, and have also found SU that it gets distributed among various ECUs. And yeah, this basically leads to the question, as it's not just the only function that is then on this ECU, it shares it with many others. How are you dealing with item definition and things like that?
So if I got your question right, how we handle item definition if one function is handled in different ECUs? Is it already allocated in different ECUs?
Exactly. And not only the single function, but probably also other functions that are then on the same ECU.
So in item definition, you have to define your boundaries. And here, what is the normal definition of your boundaries in the classic ECU distribution? You have just ECU boundary for your functions, and you define the interfaces with other ECUs, yeah?
And some sensors and actors, and you're done.
The interface with other ECUs is that triggers any kind of action that affects your item. So you'd like to study this as well, right?
Yes.
So now it is extended to another ECU. So you have also to extend the effect of this into your boundaries as well. So in terms of software or also ECU. So it could be in another ECU, okay, and affects your own ECU.
Yes.
You have to add this in your document or your item, okay, to be analyzed in your HARA, for instance.
So think this to the end. This means in the worst case, the car becomes your item.
The car?
The complete car becomes your item.
How
what it means?
How can yeah, you mean you have four ECUs and this is your
I have four ECUs plus sensors and actuators attached to these ECUs. The various functions that we have are distributed among all ECUs. So when I want to do an item definition, well, I can't do it anymore actually, because my item will become the complete car.
So in this way, you have to abstract your item from the realization in the hardware. So you have to think about the abstraction, and your function. Your item is just the function itself, and you have to handle the entire amount of ECU as like system element out of context in this way.
Yes, can understand, but this also means that all the other functions can interfere with my item.
So what is the problem?
That gets difficult.
Yeah, what is the problem if other function interfere with you? You have to analyze this. Everything you have to describe this in your item and to make it abstracted from the realization layer from the hardware.
Last comment, my problem with this is that typically the effort for these analysis rises exponentially with the.
Yeah, it is. Yeah, it is. This is like the trade-off that it is exponential analysis, and you have to abstract a lot. And even if you abstracted something, you have to have it in your analysis as already done, and try to build on that, maybe from third parties or other departments. But you cannot analyze everything.
Thank you.
Okay, we are a bit late. If you want to, but try to be quick, please.
Quick question. Like when the ECU grows, then two things happen. The probability that something breaks inside the ECU is higher, and the cost for repair is also higher because it's a bigger ECU. Have there been any commercial considerations as sort of a sweet spot of how few big ECUs and how big they can be are reasonable Because like if the whole car is just a single ECU, right, then as soon as something breaks, you have to replace everything.
Yeah, thank you for this question. It is really good. As I said at the beginning, the hotspot could be depend on the vendor itself, because it is not a religion to just have one ECU, because as you said, it would be really complex to identify the fault or the source of the failure, for example. So yeah, we think that instead of just have 100 ECU, so we have one, but we have thousands or hundreds of functions, for example. So it is difficult also to figure out this. So it is, the sweet spot is not just to have one or two or three. It is something you can manage. You can manage to maintain. So if you can maintain 10 issues, it's okay. But if one, it will be, yeah, in the long term, okay for the ECU cost, but for the maintainability, it would cost you higher. So you have to check, the cost from this and analyze the cost if we just have software and would like to maintain this. So it's a trade-off. You have to do your check.
Okay, thank you. Unfortunately, we need to move forward. Well, many thanks. Okay, do we have the next speaker? Yes. So next speaker is Senthilvel Prabhakaran, Functional Safety Manager at Sensata Technologies from the Netherlands, and also many years experience on the area and 10 years into functional safety. Please.
Good afternoon, all. I know this is a tough session after lunch, so I will try my best to make it as simple as possible so that it will be easy to digest. Okay. In multiple presentations, you might have seen the box as sensor. So this particular session will give you an idea about how we deal with sensor, especially in functional safety perspective. So there are so many sensors. So we have picked the design approach, a FUSA design approach for the braking application. So we develop braking sensors. So we see how we design the braking sensors, which is useful in the braking applications. Yeah, AI did this job. So hope it looks like me. So I just gave my plain photo. It converted like this particular engineering photo. Yeah, about me. I'm a functional safety and cybersecurity manager in Sensata Technologies, having 21 years of experience in embedded system development and 10 years of experience in functional safety development. So I'm part of member of technical staff in Sensata Technologies. It's a group of people. It's a group of SMEs who are part of this particular technical staff group. As I'm taking part in functional safety and cybersecurity, I'm part of this group. Of course, I do have some certifications like functional safety, cybersecurity, as well as ASPICE, because ASPICE is the base for these two. So I'm certified professional on this domain. Okay, about our company. So we are in industry for more than 100+ years. We develop multiple components in mission critical systems, multiple sensors. We are into automotive, aircraft, industrial, military, heavy vehicle, off-road, marine. So we are into multiple domains. We do develop multiple components. In short, we have multiple employees, 18,000+ employees in place, and we do have 14 R&D centers across the globe. One thing which I want to specify here is we were part of Apollo mission. Even our sensors were placed in a Apollo rover. So our component not only performs good in Earth, it performed well in space, even in moon as well. Oops. Yeah, coming back to the specific presentation. It's related to the portfolio of the car. So we do have multiple sensors, as I mentioned, braking force, braking pressure, pedal force. There are so many sensors. Added to that, we are into the tire pressure monitoring as well, and we do have components for EVs like DC fast charge contactors, charge boxes, multiple switches, the power switch converters like 400 to 800 volt converters as well as we produce. Okay, coming back to the sensor specific, we do have multiple sensor technologies in place. The sensor technology is grouped into 4 in ours based on the applications. The first technology is called the MEMS, which we develop for low pressure sensing technologies. And we do have ceramic capacitive sensors, which is for medium pressure technology. And we do have MSG sensors for high pressures. So we are going to talk more about this MSG technology because we are using this particular technology for braking applications. And we do have a temperature sensor separately, which we are developing. And you can see the volumes. It's a very huge volumes we produce in all these technologies. Okay, let's discuss about the sensor design. Then we see how we apply functional safety on top of the basic sensor design. So what is sensor? So it's nothing but it has to convert one form of energy or one form into another form. So in this particular design, as we are discussing about the braking pressure sensor or braking force sensor. So this particular sensor converts your braking pressure or force into an electrical signal. So that is the goal of it. So if you see the, okay, if you see the input for this particular sensor is pressure. So this particular pressure is getting converted into a mechanical stress. So you can see the red line here, which is an input pressure, which goes to the sensing element assembly, which converts the mechanical stress into an electrical signal. Basically, it changes the electrical parameter. So the parameter here is the resistive parameter. So you can see the third box here, the silicon piezoresistive effect. So this particular sensing element assembly gets the pressure as an input and changes its resistive parameter, which changes its voltage output. So the ASIC, which is here, receives this particular, receives the particular voltage changes, and it does its own processing, and it sends as an output. So the output can be digital or analog. So here, for example, I took a sent output for this particular presentation. So the basic principle of sensor is receives a mechanical change, converts it to an electrical change, process it, and send it out based on the specification. Okay, now we have the basic sensor principle in place. Now we need to apply the functional safety design over the top of it. So consider that a customer asks for an ASIL A or an ASIL B sensor. So what we do is we take front end as a single sensing element, which converts the input signal to an electrical changes. Then we use the ASIC of ASIL A or ASIL B compliant ASIC. It's a single source of processing. So a single sensing element converts into an electrical changes, and ASIC receives it, converts into a dedicated output, and sends it out. So here is the screenshot of from ISO 26262. So this gives the simplified transfer curve. So it gives the input pressure, so it converts to voltage, and it sends it out. So so here the limitation is we can detect only the sensor valid range here. So during runtime, if the sensor drifts, we can't detect it. So that is the reason it has some limitations. So this particular logic is used only in ASIL A and ASIL B sensors. So in case if it is a critical system which is having ASIL C and ASIL D, we need to change its design. So the input is same, pressure and force. It changes it to mechanical stress, but we place two sensing element in front because we need redundancy. So here you see the same architecture, but we place two sensing elements, sensing element 1 and sensing element 2. So our input is same, but it's getting detected by two sensing element. And we upgraded our ASIC to ASIL C, ASIL D ASIC. So it has its own internal architecture. It processes its signal in a different path. So the sense element 1 signal is parsed separately, and sense element 2 signal is parsed separately, and we do have the output. So we send dual output so that the ECU which receives the sensor output can do its own processing. So the advantage is, again, we do have the two transfer curve over here as suggested by 26262. So other than you're out of range, even you can detect the drift and offsets because we are comparing two output, so that if one channel drifts, you can compare it with the other channel and you can detect that there is a drift which is going on. So once it drift goes beyond the limit, you can trigger your diagnostics. So this is the design principle we follow for different ASILs. Okay, coming back to the performance and safety limit. So we designed the sensor. Now we need to define the limits. Here you see there are zones. So here the x-axis, the y-axis is your input, and x-axis is your limit. So for example, this particular sensor is capable of detecting 0 to 100 bar pressure. So we defined the limits. This Fs is nothing but the full scale limit. So for example, this particular green zone is a functional zone. So the sensor is performing well in the green zone. If it goes to the yellow zone, it's a tolerant zone, wherein which there is some degrade in the functionality, but it is safe enough to operate on the road. But once it goes to the red zone, it's an unsafe zone. It's not safe to operate on road. Immediately it triggers the diagnostics. So let's take an example calculation here. So you consider it's a 100 bar sensor, but the current pressure is 50 bar. So the performance limit is 49 bar to 50 bar because it's plus or minus 1% full scale. So if it operates in 49 bar to 50 bar, it's perfectly fine. So it's in the operational zone. So once it goes to the yellow zone, which is nothing but 45 bar to 55 bar, it's in the tolerant zone. There's a degrade in the functionality, but it's safe to operate. So once it goes below 45 bar, or once it goes above 55 bar, it's unsafe zone. So we are comparing two channels. So the two channel comparison gives this particular change. Then immediately the ASIC triggers the diagnostics, and it indicates to the ECU saying that there is an error in the sensor, please don't use it. Then ECU need to indicate it to the driver saying that it's unsafe to operate. Okay, the next is sense element qualification. For example, as we are talking about the sensing element, which is there in the front, which helps you to convert your pressure to the electrical signal. So the ISO 26262 says that the safety related hardware part, it shall be qualified according to some well-established procedure. So we do have two procedures specified here. One is AEC or ISO 16750. But there is no direct AEC qualification defined for the piezo-resistive sensing element. So that is one check over here. Then ISO 16750 says that we have to perform some certain tests on the element. Unfortunately, we can't take out that element alone and do the testing because we can test only upon integrating into the sensor.
And the internal guideline for qualification, as I mentioned, we can't test this particular component alone. So we need to integrate that component into sensor, package it, then we use it for testing. So upon having all this interpretation, we came up with a strategy of qualifying this particular sensing element. So this qualification program is inspired by AECQ 103, which is for MEMS qualification. So we take the inspiration from this for MSG qualification. And we picked some qualification tests from 16750, as well as the use cases also we took it based on our experiences. So we used this strategy, and this is our results. So if you see the selection of tests, so each variance of sensor is tested for approximately 1000 hours at 140 degrees Celsius at high temperature, and 72 hours at minus 40 degrees Celsius, and 1000 T-shocks at minus 40 to 140 degrees Celsius. This is basically a thermal shock, wherein which there is a chamber which during the operation, immediately we change the temperature from one chamber to other chamber. So we test how our sensor performs at the temperature shock. And we do burst proof pressure cycling test to make sure that our sensor works well. So if you see the count, it's 68,793 sensors are tested. So it's a very huge number. It's not like a very like 10 or 100 or 1000 sensors we have tested. So over the past 10 years, we do have the huge statistics of data with us. So that is to past assumption. If you see, as per the reliability calculations, we are at R99.9967. So the probability of failure is very, very, very less here for our sensors. Yes. Yeah. The next logic is FMIDA. So we do have all the hardware components in place. ASIC, we do have the fit rates for that. We do have the passive elements in our board. We do have the fit rates based on the handbooks. But again, the sense element is designed by Sensata. So we don't have the direct handbook for the fit calculations. So we can't refer that particular fit from handbook. So we used the logic of field returns, because if you see the count, we have 700 millions of sensor on this particular technology on the road right now. So we use the field returns to calculate the fit value. So I just explained the logic over here. The input is field return data plus our safety analysis, what we performed before producing the sensor. So we took out the potential failure modes as well as the operating hours of the sensor, which came back to Sensata. And we have applied the correction factor, because not all the sensors will be returned back to Sensata upon failure. So our consideration is only 10% of the failed components are returned. We applied the distribution factor as well as the confidence level of 70%. Then we updated the number of failures with the distributions of the failure modes, which we have used in our safety analysis. Yes, then we calculated the overall fit, which is 2.9 fit, and we distributed to all the failure modes which we have defined during our safety analysis. So again, this particular logic is suggested in part 5. So we used this particular logic and calculated the fit rate. So yes, so the overall summary is, yeah, I presented the design principle, how we are making the MSG sensors according to the defined ASIL requirement. And yeah, we used the performance and safety limits because we need to have the clear limits, because we don't want to have any nuisance tripping during runtime, because it's a braking application. So the driver will get panic. So we have clearly defined the actual working limit, tolerance limit, and safety limit. And the other logic of qualifying as well as the fit rate calculations based on the field returns. And I just want to emphasize that we do have the huge statistical data for sensor development. Yeah, this is where my presentation ends. Thank you. Questions, please.
Okay, questions? Okay, one here, Vincenzo. Oh, okay.
Hi, this is Kepin from BorgWarner. So you showed that you're using 70% confidence limit, 70% confidence on the chi-square distribution. So is there a reason why 70%? And the other question I have is that how do you come up with the failure mode distribution? Because I'm sure that there are certain failures that are easy to detect. And you would get the returns, but there are certain failures where it's not easy to detect and you would not get the returns. So how do you come up with your failure mode distribution?
Okay, so okay, these particular failures are defined in our safety analysis. For example, as it's our design, so we consider these are all our as this is our design, we consider these are all the failure modes in our FMIDA as well as from our DFMEA. So based on the field returns, we do the failure analysis and we map the failures based on this particular failure mode. So we do have the counts, and we know that what exact failure happens on that particular sensor, and we mapped with this particular failure modes. So for example, if you say 100 failures are there in place from the field return, so we map the failure according to this particular failure mode, which is predefined. So that's why these particular numbers are there in place. Thank you.
Thank you. So Vincenzo Scube, so you talked about performance limit and safety limits.
Yes.
How do you translate then these limits to local checks? For example, voltage monitoring. How do you translate this 1%, 5% down 10 to the diagnostic limits you use, for example, to over voltage monitoring or under voltage monitoring?
Okay. This particular sensor is not capable of detecting because we can't compare the real value, the applied pressure, because it's already applied at the input level. So your ASIC processes that particular signal, and for example, consider the input is 10 bar. So that is at the very initial level. For example, say your ASIC, your sensing element has some issue, so it converts its voltage to 11 bar. So it comes to ASIC. So the ASIC says it's 11 bar. So we won't be knowing exactly it's a fault or it's the right value. So that is the reason we do have the dual sensing here in place, so that we compare sensing 1 with sensing 2. So if we find the difference is huge, then we give the flag. For example, say the first sensing says that it's 8 bar, the second sensing says that it's 12 bar. So there is some issue now. So by comparing these two signals, we can predict that there is some problem is going on in place because we don't know the real value at this particular level. And coming back to your question, so this particular definition happens based on our requirement. We clearly say to our customers saying that, okay, these are all the zones which we can define in our sensor. So usually the customer defines this particular limit. So for example, say where we need to keep this particular safety limit. So if the customer wants it to be 10% FS, then we will move the limit to the 10%. If the customer wants to close to the accuracy limit, usually we don't entertain them to keep as close as possible because it might trigger some nuisance tripping during the road. So we say them to keep some marginal zone between the safety error to the performance zone. So it's basically a customizable limit. Customer defines this. Yeah.
Okay. Yeah, I mean, the point of the fit is always a big problem because we don't really have in the community fit for safety. So I think looking at the field monitoring is probably one of the best way. The question, how long, how far are you monitoring? Because if the components will be used for 20 years and the current monitoring maybe is looking at the 5 years, we need to add potentially some margin. But if you're using handbooks like Siemens standard or IC 60380 is one of the most popular today, even if it's not valid anymore, is this really relevant or accurate for your product? But at the end, that's why in the ISO standard, we are saying those numbers are not absolute, that you should really believe on them. They are not quality, they are more relative to compare solutions. And this, I think, in the next panel, at the end of the day, we'll also discuss this because in my view, now in the ISO standard, also we go in a direction that will be difficult to compare across components. But yes, I think it is a big issue how to compute fit, how to use fit, especially if the current standards don't give you the right input. So you are out of options. The only one is the reliability test or a field monitoring.
Yeah. Added to that, we made this particular sensor as cybersecurity compliant as well. So anyway, that is a different topic. Maybe we can present that later. But this particular sensor are FOSA compliant as well as cybersecurity compliant.
Excellent.
Thank you.
Many thanks. Okay, we move to the next, and now we have Christian Novak, Senior Functional Safety Expert from TÜV Süd Rail, and also, yeah, quite a long experience in TÜV Süd since 2012, and also 10 years experience on the development before of safety products. So, please.
Okay, yeah, first of all, yeah, thank you, let's say, for having me, for giving me the opportunity. Yeah, so as Ricardo just said, so basically from our side, from TÜV Süd, so we are, let's say, dealing a lot with, yeah, assessments, certifications, let's say, of semiconductor elements. Yeah, of course, also other systems, higher level systems. In my personal case, yeah, we are doing a lot of semiconductor assessment certifications, let's say. And yeah, the idea of this presentation was a little bit, I know, of course, that most of you are, let's say, working in the automotive domain. Yeah, we have heard a lot of ISO 26262, of course, the related cybersecurity or SOTIF standards. And the idea of this presentation was now a little bit to give you some idea, let's say, how this is maybe seen in other industries. Yeah, so in this particular case, in the industrial field. So first of all, also, as you can see, I've not prepared the presentation myself only, but had support from my colleague Jaya here in this case. So thank you for that. So I'm not sure if she's online or not, but yeah, thank you for that. So yeah, I don't want to, let's say, do a lot of presentations about TÜV Süd. This is just, let's say, some key numbers. Let's say, obviously, not all 30,000 employees are working on functional safety. That's clear. Yeah, so of course, all kinds of different, let's say, yeah, safety topics. Maybe one interesting thing, of course, the TÜV organization itself was already, let's say, founded a long time ago. Yeah, roughly 160 years of experience. So that's maybe one interesting fact here. So yeah, from that point of view, so let's say, to keep this short. So what would be the idea today? Semiconductors, yeah, we have seen in previous presentations from Farzad yesterday, for example. We had previously from Cristiano as well, also some interesting semiconductor topics here. And I think what, in general, I think we can say what we have seen during the last couple of years, or yeah, maybe even decades, I don't know, that a lot of the functional safety, which has been previously been very much on an ECU level, on a board level, has more and more, let's say, yeah, walked into the semiconductor and the integrated elements. Yeah, they have become more and more complex. I think this was also what some other colleagues said here in the presentation. And the question, of course, is then how can the standards basically keep up with the pace of this development? Yeah, this was also one of the problems that was also described previously. So here I'm just, let's say, showing you a little bit. This is, of course, not the full landscape, let's say, of the full history of the standards. So the first edition of ISC 61508 was, released, let's say, around the millennium, basically. At that time, I think there was nobody really thinking about semiconductor safety. Yeah, it was really on the whole ECU. Yeah, you had your components on the board and so on. And over time, of course, this shifted, as I said before. So in 2010, we had in the second edition of the 61508 standard. So here, at least semiconductors were somewhat represented. Yeah, there were some topics like maybe soft errors were at least mentioned. Yeah, that we can have in the volatile memory of the semiconductors, but there was not really a very good guidance. Yeah, and it was, of course, also for us a big challenge at that point, really to assess, to certify such elements. I think the first microcontroller that we really certified was like, I don't know, roughly 13, 14 years ago or something like that. Yeah, so this falls, of course, in this area. And this was really, of course, not so easy, let's say, to really define, let's say, the benchmark or what's actually the requirements or objectives that we have. With ISO 26262, specifically, of course, the second edition of the standard, so released in 2018, as you know, there's the semiconductor specific part 11 that we have. Yeah, so it provides a lot of guidance, of course, that maybe many of you are aware of to interpret this better. And so far, let's say in 61508, in the industrial environment, we did not really have something like that. But now it's basically this, the work is also the third edition of the 61508 ongoing. Yeah, so, and it's, I think, still a kind of race. Don't ask me which third edition will be released first. Yeah, if it's the 26262 or the 61508, I don't know. But in the course of the 61508 development now, we have also this 61508-2-1 that has been developed. Yeah, and this is a kind of extension, as the number also says. Yeah, part 2 of 61508 is the system hardware development, basically, in this case. And the -1 is then kind of the extension specifically for semiconductors. Yeah, and this is what I wanted to show you a little bit, to say, a little bit out of the box, what do other domains say about this? Yeah, or maybe what are they also reusing from the automotive world in this case? Yeah, and I mean, in our case, it's of course also often a challenge because our customers maybe want to have a certificate to both standards, to 26262 as well as 61508. So of course, we try somehow to find their a common set of requirements to maybe also identify what are the maybe differences that you need to take care about. And this is exactly maybe where these new standards are now targeting against. Yeah, so that's generally the topic for today. So the standard itself, it's called requirements for semiconductors. So that's maybe also an interesting topic you should note. So the part 11 of 2018 is simply a guideline. It's informative, simply telling you how to apply part 5 or maybe other parts of the standard to your development. But here in this case, this is different. We have really we have informative, of course, parts. There's a lot of guidance also included, but we also have normative requirements. So there are some sections of this part which really give you requirements, with the famous shell keyword and so on. So therefore, really requirements for semiconductors in this case. And it's also previously in the standard, I think when 61508 was talking about semiconductors, they were mainly talking about ASICs always. Not really about generic, let's say, semiconductors like microcontrollers and so on. And they kind of clarified this wording. So now they just call it semiconductor in general. And this applies then both to application-specific ICs that are maybe developed in context of a certain application, as well as generic components that are safety elements out of context or compliant items, if you want. So that's basically, and the release, this is of course with a question mark. It's planned for next year, that it will be mature, but I think this is not so clear. But nevertheless, let's look a little bit into the content. So I think the most important point
at the beginning that we have basically a life cycle that is defined. So we have basically, first of all, in order to classify the semiconductor that we have, there's a kind of semiconductor classes introduced. So this sounds, of course, maybe for some of you familiar when you know part 8, clause 13 of ISO 26262. There we have also the evaluation of hardware elements, which defines classes of semiconductors. This sounds, first of all, similar, but you will see on one of the next slides that this is the definition is a little bit different, unfortunately. Then, of course, they are talking about systematic fault avoidance. We have seen, of course, in the presentations also, we need, on the one hand, to have a robust development process to avoid failures during the development, systematic failures, and as well some words about the quantification of the random hardware faults during operation. So both topics are covered here. And then we have, as I said, maybe some guidance like soft errors specifically, maybe fault injection, and that kind of topics. And then even more on top of this, we have here some information regarding IP development specifically. So what is here special? We don't have maybe always a physical semiconductor, but rather maybe some soft IP or something like that. Then we have self-test libraries. That's also a topic that we need to consider, because often the semiconductor vendors, as you know, they do not only provide you with the pure hardware, but maybe they also help you by providing already some test library that you can use in your software to basically detect random hardware faults during operation. So there are also some words regarding that, what needs to be considered. And finally, even how can I cover, you will see this then in the classifications, if we have a semiconductor that is so-called class 0, which is basically not developed according to the safety standard. Maybe we can cover this with software techniques like coded processing, maybe at least part of it, and maybe then in addition some system level safety mechanisms. So as I said, we have these definitions of the classes. As I said, a little bit different from the 26262. So class 0 is basically a semiconductor that has not been developed according to the 61508 standard. So it is what was previously referred to in the standard as so-called mass-produced device. So like device that is maybe millions of times already in market, maybe not for safety applications, but you can maybe apply some kind of increased confidence from use, let's say. So we will see how to handle this. Class 1 is then actually the 61508 developed semiconductor, that we would maybe a safety microcontroller or something like that. And the class 2 is then the specific case, which we will not find also in 26262 again. This is then again a safety ASIC or safety controller, but the speciality is here really that we have so-called redundancy on chip. So this is also a topic maybe that is not so present in 26262, that 61508 makes there a very clear distinction. If we have, let's say, so-called hardware fault tolerance, or not. And this is then also applied, this methodology here to the semiconductor. So this was already previously in the standard, but now they have defined this also here for the classes. Because here, of course, we have then specific topics to analyze, then common cause failures, of course, between the two channels. The determination of the beta factor. So how do we handle this in your quantitative analysis then accordingly? So this is the idea. For, let's say, the integrators among you, there's a kind of interesting flowchart in this part of the standard, which tells you if you're selecting your semiconductor device or your microcontroller when you're developing your system, which paths do I actually have? If the device has some safety responsibility, what can I do? Kind of step by step. And the first step is that first of all, you ask the question, of course, is this developed according to 61508? If this is the case, then we have a so-called compliant item. Not item, of course, in the sense of 26262. Here, compliant item is the same thing as this so-called SEOC, the safety element out of context. If that is not the case, yeah, what alternatives do we have? We can apply a proven in use argument to this device. This is another option. Yeah, is of course the question we had before in the presentation. We have seen this field return approach for the fit rate at least. Yeah, so maybe you can also apply this generally to say it is systematically, let's say, capable to be used in the system. This we also have. And then if this is also not the case, what is then the third option? That's maybe interesting for the automotive community. So they are saying, yeah, maybe this was developed according to 26262. Yeah, there's of course a good crossover, let's say, between the two standards. Yeah, there are many similar requirements, of course, but what 61508 then requires from you is that you do not only, let's say, just take it, maybe follow the safety manual, but you should also do a gap analysis. So you basically need to find out what are the differences between 26262 and 61508, and then, yeah, based on this gap analysis, make then a judgment, is it suitable or not, basically, for you. Yeah, and if this is even then not the case, yeah, the last resort that you have is then exactly this mass-produced device approach that was previously in there. So if you can say this is on the one hand, maybe widely, it's not a new semiconductor, but maybe one that is already has been used in the field, then maybe with a combination additionally, maybe looking at some specific development methods, some checklist, let's say, from the annex, if that is basically true, and you have maybe some mitigations on system level, on architecture level, yeah, some kind of maybe redundancy, so you can test the specific functionality of the semiconductor. Maybe that is then also you can judge to be suitable. Yeah, but this is kind of the last option. And yeah, then of course the worst case is then in the end, if none of these applies or you cannot follow it, then you should pick a new IC. Yeah, so this is really the wording from the flowchart there. Yeah, so that is kind of the flow that is suggested here. Now let's have a look. What are the general requirements for the safety life cycle? So this is, I think, this model maybe a little bit difficult to read, but this is simply, let's say, the V model. I think you have seen in several presentations already today and yesterday. So that's just, let's say, the mapped semiconductor flow, which we also had in the first edition of 61508. And then the hard requirements are basically that you have to follow for class 1 and class 2 is, of course, to follow, let's say, the process for systematic fault avoidance, do your quantitative analysis. So basically kind of the same that we know from 26262, of course. The difference is for these class 2 that there's a specific annex which then tells you how to determine the beta factor. If you have redundancy on chip, there are some specific restrictions or requirements that are placed on you if you want to exploit this features. And then I think today also good presentation from Siemens that we have seen regarding data communication. So that is of course also present, yeah, in the standard. That's exactly what we have seen before, that this needs to be considered qualitatively and quantitatively. Yeah, and then yeah, finally, diagnostic functions. That is something new actually in now the third edition that will probably come. Yeah, so that we finally have a good statement from 61508 how to handle safety mechanisms, diagnostic elements, because previously the standard really was taking more care about single point faults in that sense. Yeah, so there was not really a metric available like the latent fault metric that we have from 26262. So that is something that is really new, that we have a diagnostic safe failure fraction. Yeah, so a specific requirement here for the diagnostic elements that will come. Yeah, this is not specifically in the semiconductor part. This also applies on system level, but that of course also needs to be considered. Yeah, this is just an extract, let's say, so just to give you some idea regarding the systematic faults, maybe not so interesting, but we have basically one huge table in the standard that gives you, that maps basically a classical semiconductor development flow from design entry. We have synthesis, test, layout, manufacturing, and maps then basically the requirements from the standard here to this design flow. Yeah, then of course tells you, as you also know this from 26262, you have your recommended, your highly recommended methods that are then allocated here, or basically suggested for the different systematic capability classes. So that's the same here in this case as the ASIL, basically. And we also have then separate columns for different technologies, for different types of semiconductors. Yeah, so digital, analog, mixed signal, even FPGAs, so programmable ICs and so forth. And this basically, I mean, so far for the checklist-based approach that we have been discussing, but that is what is suggested here. Yeah, then, yeah, I see that we don't have too much time. So that is also something maybe where we can say that, yeah, this part -2-1 has taken a lot of information, in my opinion, from the part 11 of 26262. Yeah, so what was developed here maybe comes also into picture now in 61508. So we have topics like common cause analysis, dependent fault analysis, still, of course, emphasizing here if we have redundant architectures on the device, really. And maybe then, yeah, something that is, of course, very similar, first of all, to 26262. But what is different, that is the quantification of the beta factor. So basically this beta IC that you can see here, and it's kind of, let's say, climbing the ladder. If you see this is like a simplified approach, which is also new compared to the previous edition, that, it's like an incremental approach. Yeah, worst case, you have to claim 25% beta factor, which basically means if you have a redundancy, you cannot just, let's say, multiply the failure rates if you want, but you would use 25% of one of the channels, which is quite a lot. And then, of course, the better or the more mitigation measures, diagnostics, and so forth, or maybe even on the highest level, then diversity and so forth, that you maybe can implement for the redundant channels, then you can claim here better margin. Soft errors is also included. Yeah, you have the material, of course. I think here is not too much new compared to 26262. Yeah, it's just more detailed, better explained than it was previously in the standard. And yeah, for the IP, you get requirements not only for the IP vendor, but also for the integrator. Yeah, topics like safety manual and so forth. Yeah, test libraries. Main statement, of course, they have to be developed according to a systematic capability that you have to follow. And then, of course, one big question maybe is the diagnostic coverage. Yeah, maybe the vendor has to provide this to you. Yeah, what can actually be claimed for the hardware. And yeah, you also find something like this comparison table in the standard, which maps the ASIL here on the left side to the integrity level of the standard. And yeah, last but not least, maybe that's only for your reference. That's not the only, let's say, standard that is currently being developed in this area, but we also have a -6-1 here, which is basically saying maybe interesting for automotive treatment of hardware and software elements developed according to 26262. So this gives you a comparison between the 26262 standard in general and the 61508. And then basically says via this equivalence levels, is it comparable or do you need to do more? So this is then supporting this gap analysis that I was mentioning before. Yeah, so that's basically the summary. So in the end, we have several new topics like the classification of the semiconductors. We have basically the selection chart that you have seen for the integrators. Then a few specific topics that we have been discussing. And of course, also this metrics, like the say failure fraction for diagnostics. So there are a few new topics coming for sure, which are, in most sense, I would say comparable to 26262. So sorry for being a little bit over time, but you have the material. You can, of course, have a look. So thank you for your attention.
Any question? Okay, one question here.
Markus Rau from SGS TÜV. Maybe two questions, sorry. The first one, is this part 2-1 part already available?
No.
No, it's only for members of the committee.
Yes, this is still being developed. Let's say we can, of course, also not say, I need to mention that this is, of course, not yet, of course, final the content. Yeah, so we cannot say, of course, if everything will really be part of it. But yes. Mm-hmm.
Okay, and when it's expected to?
Yeah, 2026 is, I think, was called like maturity state or something. Maybe 2026, 27 latest, I would say. Yes, that is the plan. Mm-hmm.
Okay, thank you.
Yes.
Okay, just behind it.
Ricardo actually made it available to the German subcommittee of the ISO 26262 at the VDA, so you should have access to it. I think I was the only person, maybe now the two of us, who actually read it. I had a lot of comments, so if someone wants to wait for a stable version, I would give them the opportunity to fix, because after I submitted my comments, the feedback came. They didn't know if they could consider them because they have so many comments on top of what I provided. So there might still be some changes.
Yeah, we also provided, of course, some comments to it. So it's for sure maybe not the ideal solution yet. That's true. Yes.
Yeah, so I'm looking for some inside information. So if you're aware, I'm going for the class 0. Okay. Nowadays we know that the MCUs, for example, are not considered well-tried components due to their complexity. Is that going to be addressed even for the non-high level of safety MCUs, even if they are qualified in class 0, or this is not considered?
Yeah, I think so you mean basically if you can still use, let's say, a highly complex MCU, which is not in any form safety qualified, or is this the question? Or
yeah, but okay, now there's no classification at all, so we do not consider them due to their complexity. If they are qualified in class 0, that's why I'm not mentioning the class 1 and class 2. Are they going to be considered safe enough in a lower level, or they're not going to be considered at all? It's much more technical, coming from some inside information if you have and can share.
Yeah, I mean, it has, of course, been, let's say, for a long time a concern. So, I mean, previously, as I said, we had this mass-produced device approach. And this was, of course, coming from a world where you basically had systems where you could only use standard microcontrollers because there were no safety microcontrollers. And in that time, of course, what you typically did, you did not just take one, but maybe two on your board, maybe from different vendors, or maybe with different technology. And this was then kind of your way, how do you address the systematic faults in the controllers. Yeah, they of course have a huge amount of systematic faults, but hopefully not the same at the same time or something like that. And that was kind of the principle in the past. Yeah. And of course, the standard also tries to go away from this, but they do not, let's say, restrict it fully. Yeah, they try to add some additional requirements on top. But it's, I think, not yet completely removed. But it's the same in 26262, right? With for class 3, it should be developed according to.
Yeah, then it depends on what you want to claim. If you want to just use it as a functionality, maybe it's okay. But then if you want to claim a protections, you need to go inside, and then it will get difficult. And in the IEC standard industrial, we have this concept of the equipment under control and control equipment. In automotive, somehow is everything combined in a single box, and then you add much more complexity. Of course, it could also happen in industrial, so it's not a clear cut. But again, depends on the role on safety.
Yeah,
depends on your requirements, availability.
I think a big part is also if you maybe can have some external mitigations or diagnostic safety mechanisms where you maybe can kind of control the function that the device is then fulfilling. Yes. If you do not rely maybe on on-chip safety mechanisms, which you maybe do not have anyway, and you can maybe build something around then that you also can then verify and test properly. That's of course also an option. Yeah.
Okay, we are over time, so we need to move on. Okay, thank you.
Thank you.
Okay, let's change topic, and now we go to green vehicles, electrical vehicles. And we have Luz Amanda Garcia Galeano, Head of Functional Safety and Cybersecurity at Ibusco. And yeah, specialize in functional safety, sort of, but I give you the floor.
Thank you. Thank you, Ricardo. Let me try to use this. So I want to talk about, we spoke a lot this morning about functional safety and cybersecurity, but I want to give you some insights about electric vehicles. We have missed the topic today, but it's also a hot topic. Before to start, I want to introduce a little my company. My company is, we produce electric buses and battery containers. We are based in the Netherlands. We are a small company, and we have put all our effort in the sustainability. So we produce just electric buses, not diesel, not anything else. This is our mission of the company. The safety is always in mind. The story is we born in 2010, so it's young company still between established company and a startup. Our first bus was running in 2030. We have buses just in Europe. We don't export buses. And mainly we are proud for the amount of kilometers we can manage with one charge. So our best seller is the 80-meter bus because 700 kilometers can be drive with one charge. Going to the topic of today, I want to talk about the high voltage issues we have, what we mean by connection with infrastructure, and some thoughts about the legislation that we already also have spoken a lot here in the conference. For the high voltage, we need to think a lot about the battery management system, because the safety goals are mainly you need to avoid to overcharge your car or your bus, and you need to avoid the thermal runaway. Those are your main safety goals. So you need to find a solution to detect the short circuits. And the most important thing, I heard also a lot of presentation about the safe area. For the batteries, is the same story. You need to ensure that your battery is always working in that area, because otherwise your battery will not last as you expect, or will run in issues with time or on overcharging. The fail-safe strategy that you need to define with your supplier need to include also some sharing status, because you need to be sure that you know what is happening, to have the time to inform your driver to stop the vehicle in time, or you have the time to give the driver also the opportunity to stop the vehicle before you are going in a big issue. The other big point is the energy flow management, because you need to be sure that when you are driving, you can brake and use that energy to recharge your battery. But that needs to be smooth, because in the moment you have a lack of energy or too much energy, it will produce a ground reaction in your vehicle. That is what could happen. So you need to ensure that same transitions are there. And I think the main challenge we are facing with the electric vehicles is, when I started working in functional safety, my first mentor told me, your vehicle is safe when it's stopped and it's off. That is not anymore valid, because our vehicle now, when we stop it, we connected it and charge it. So we need to think also in the phase when the vehicle is charging. That is the most important message I have here. I was saying cybersecurity, functional safety and cybersecurity. What we have noticed is, coming from the TARA, we spoke this morning a lot also about it, you can have different impacts when you're doing the analysis. We noticed that the safety impacts could be real. That could happen that your battery break a safety goal that is overcharging, or also you can have a risk for the people that is inside the car. And in the worst case, you will break your main safety goal, that is avoid fire because you are in a thermal runaway and you start firing in your car. The other point that is really important is in the case of our buses is the operational impact. We don't want to have a customer unhappy because all the fleet is not possible to be driven one day because we have been hacked. Best scenario is with the driver halt the operation, but the worst scenario is if it's disconnected batteries, you don't know what is happening. Maybe if the batteries are disconnected, you don't know which is the status and could be also really risky in that case. So what we have done is we have tried to use the information coming from the TARA, add it to our HARA, and also I use this diagram also to explain how similar the work products are in. That is what I love the discussion of this morning, because when you are in a small company and you have limited resources, create all this work product is really difficult. So we are trying to reduce the effort and combine the strategies there. What we have noticed is from the management point of view is possible, but from the technical point of view, if you need experts, I was saying this morning, if you look for a person capable to perform all the analysis of functional safety and cybersecurity, you are looking for a unicorn. That is a kind of impossible. But from the management point of view and some work products, we can do it. What we have noticed from the battery management system is an evolution in the architecture. So the first vehicles was just having a single battery management system and single ECU managing all the batteries that have the complexity that you will have a single point of failure. If you have that ECU that is not working properly, you will have a lot of issues. You can, instead of have a centralized architecture, you can have a modular architecture. In that case, you can have some redundancies there. It's good news for you, but still you have the single point of failure. What is happening now, more or less, is the distributed architecture. There are different units along your vehicle, in our cases along our bus, and we collect the information. They have the big issue that you will increase the cost. And if you are the OEM, maybe you are not happy about it. So you need to start discussing with your management, what do you want? Or what the management want also. The most advanced one, I take this information from a study from the Technological University of Eindhoven, is going in the direction to have a decentralized architecture. That is some way also what we have seen today here. The big problem of have a decentralized architecture on the battery management system is difficult to synchronize the information and to be sure that it's still working properly. And the most fancy one will be have all using wireless system. The big drawback of that one is cybersecurity, because you will have the advantage of less cables, less problems with weight of your vehicle, but at that point you maybe will have challenges in your cybersecurity, because if the communication is hacked, you don't know anymore what is happening in your batteries. There are also a lot of trends regarding the artificial intelligence. We was talking also a lot in these days. The idea is to use the artificial intelligence to understand how to optimize the battery. There is also the topic of the over-the-air updates. We was also discussing this morning. One of the big challenges is how to ensure that it's safe, the patch we are releasing, but in the other side, how to ensure that you are releasing it also in time to your customer. A part of that, we have real-time optimization for autonomous vehicles. So they want to use the energy properly for your autonomous vehicle and maybe understand which is the best moment to stop the vehicle, because the idea is not anymore you are the owner of the vehicle, but you have a fleet that is running around the city, like the robot taxis yesterday we was discussing, and you want to use as much as possible the energy of your battery. So that is the optimization want to be performed. And for sure, there is also cloud connected, because if you are always connected to the cloud, you want to understand how is the battery going, and maybe you can prevent some failures, and you can recall your vehicle in time to replace the battery and perform some maintenance on it. The second challenge we have is the connection with the infrastructure. What we have seen is not anymore the vehicle as a vehicle that is taking the energy from the network, but the vehicle as a charger. So it's a different mindset here. So the trend we have seen is are already vehicles available in the market that you can connect your PC, start working in your PC, and using your vehicle as a battery charger. There are also the trend to use, for example, in a case of blackout, you can use your vehicle to use the energy in your home, or for example, to reduce the cost of your bill at the end of the month in the high peak. We'll discuss in the morning. In the morning is more expensive, so you want to use the battery you still have in your car, and start charging your car and using the energy in the afternoon where it's less expensive. The other idea is to share also the energy that you have still in the car and sharing it with the grid. That is also interesting. A big challenge is the fast charging. I summarize fast charging in a lot of points. If you ever have drive an electric vehicle more than 200 kilometers, you know the pain. You need to wait 1 hour that your car is charging, if you are lucky and find a fast charger. Now what the customers want is just in 50 minutes reach 80% of the charging. That is challenging because that will be, from the functional safety point of view, stress a lot your battery. And you need to be sure that the battery in your vehicle is still capable to maintain the same characteristics that was released a couple of years ago. And this is the megawatt charging is relevant for the buses and trucks industry. In this is China leading a lot. They are thinking to release chargers for 1 megawatt. So in that case, the buses or the trucks will be charged really faster. And but in Europe, it's still a dream. You can find those chargers only in China. In fast charging, you will have the Oh, I made something wrong here. Okay. Okay. The fast charger, the best you will find is in Netherlands. It's leading about the fast charger is 150 kilowatt hour. I know in Germany it's also increasing a lot, but it's difficult. When you're driving a car, it's difficult to find a fast charger if you go in the south of Europe in particular. So what we have seen is a trend to stop thinking just in the ISO 262 just as a vehicle. You need to include also your infrastructure. And the challenge there is you don't know in which is the supplier your final customer will use. But in general, the good news is there is an ISO standard also for that, so you can take inspiration of that, and you can take use this to consider the risk of the communication failures between your vehicle and the charger. If we think again in the cybersecurity, what we have noticed is still we have a lot of weakness in the man-of-the-middle attack. That is something that is not considered all the time in the analysis in cybersecurity. Normally, you consider inside attacks or from the cloud, but not someone that is going in between you and the infrastructure, but in this way. Unfortunately, in that case, also your vehicle can be manipulated and could catch fire, unfortunately. A lot of people think it's something that could not happen, but already in 2020, a university in USA was able to manipulate and emulate that kind of attack. And they start mimicking the overcharging, the over temperature. So it's possible. Locally, the attacks we have seen up to now just to steal the money for you. We know, for example, that if you go to charge your car, they can overcharge you a little money. So you, instead of pay 30 euros, you will pay 32 and you will notice it, you will not notice it. So it's also something that is really a trend. And what I want to talk also about is legislation. I think we already have the opportunity to talk about it a lot. But what we notice is there are now regulations for the charging infrastructure, but it's not covered at all. And if you want to develop now a vehicle following all the regulations, thinking in cybersecurity, electric vehicles, and cybersecurity, you need to have a person that is capable to understand all these standards. That is also really challenging. And it's not helping a lot to the OEM to release the vehicles. So I want to bring you to the conclusion. We come to the conclusion in my company, we need to have a combined approach between functional safety and cybersecurity. We cannot forget in one side functional safety, in other side the cybersecurity. Needs a lot of collaboration between the teams and means a lot, I will not say documentation, but at least communication, because what I already noticed is both teams were fighting in some way with different language. Someone was saying that it's more urgent one thing or other one. And it's difficult to find now a solution in the market having great cybersecurity with great functional safety, at least for the bus market. I know normal automotive have more options, but unfortunately for the bus industry, we have less issues. We have around 40 issues in our vehicles, but most of the issues are legacy products. And that means for us, be compliant with functional safety and cybersecurity sometimes is really a challenge because the suppliers are not ready for that. Thank you all.
Thank you. Very interesting. So yeah, we are nearly at the end of the conference and still we get new topics and new challenges and very interesting. Questions? We are all getting tired. No. One question here.
Questions? Was I about to say no question?
Hi, this is Kevin from Bogwaner. So you mentioned in one of the slides about trends, and there was a mention of AI. So you are saying that we can, if you could go back to the slide.
Yes, this one.
Yeah, so when you talk about AI for battery performance optimization, are you talking about on vehicle updates? Like on vehicle, are you using AI? If yes, then what about the energy usage? Is there analysis for that? That how much it would be, and is it like?
No, to be honest, not. So it's mostly thinking in the idea to improve the performance of the battery, but I understand your point. That at the end, maybe the algorithm that is running is consuming more energy than the real energy we are reducing.
Okay, thank you.
More questions? Okay, one question here, and then maybe we can stop for a short coffee break.
Marzana Khatun from Robert Bosch. I have one general question. Because of EV, we see in Chinese market, they are quite strong. For cybersecurity, they have also some standard. Are you focusing those standard as well together with ISO or IEC standard?
Yes, from the OEM perspective, you need to be compliant with the R155. And what we noticed with the supplier Chinese coming from China, they have a similar standard to the ISO 21434 or 26262. And what we are asking them is at least to share those documents, because sometimes they don't want to be compliant with European standard, but most of the standards are similar and at least are covering the most of the documentation.
Do you have some kind of assessment or analysis?
Yes, so we perform an internal an assessment with them and to analyze which are the gaps and what we need additional to the documentation they already have. Surprise, most of them already have a lot of certification in their side.
Okay, thank you.
It's not only China, also India have the particular regulation also.
Okay, many thanks.
Thank you.
Okay, we have the last coffee break, last network session, so please enjoy. But I ask you to be really on time because will be the last part, and I guess a lot of guys will need to leave on time. So please come back 4:27, something like that.
And also, I just wanted to remind, since we are getting closer and closer to the end, please fill out the evaluation forms. Your opinion is very important to us. Thank you.
Okay, 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 okay. Okay, take your seat, please. The last part of the conference, of the therapy. Come on, the therapy is nearly over. Are you feeling better? Now you're more, yeah, do you feel electrified? Yes. Yeah, it's the last portion of the conference, but still few interesting topics. Okay. So I would like to invite here on stage now Patrick Chaudhary. Good. Tech lead functional safety and cybersecurity at Munich Electrification. And yeah, more than 6 years experience on functional safety with battery management systems and so on. Please come.
So, good afternoon, everyone, and thank you, Ricardo, for the introduction. Today, I'm going to present a topic or talk about the challenge that many of us faced, that is achieving residual fit rates in distributed BMS architectures. And yeah, let's dive into it. So I'll skip my introduction here. This talk will provide you an overview of the most common BMS safety goals. And then we will also have a look at how distributed BMS systems present a unique challenge of VMHF count. And then we'll provide guidance. We'll have a look at the guidance that's provided in the Part 5 Annex G. And then I'll present you some additional approaches on HAR optimization, what can be done differently in the BMS safety goals area, and then also discuss some challenges with the norm interpretation. Before we dive in, a brief information about where I come from. So I work at a company called Munich Electrification, and this is a management-owned company which is founded in 2014 by industry experts in e-mobility and electronics design. We have a global customer base of leading automotive OEMs and also new e-mobility companies. Track record about our product portfolio is basically we have successfully industrialized 3 BMS generations, which is Monaco BMS, Bologna, and Barcelona. And we have also extended our product portfolio into current sensing devices, voltage sensing devices, thermal event detection. Also, we have some battery disconnection products, and also we are expanding into software products like battery in the cloud, and also software suites for the BMS, which more aligns with the zonal architecture concept that was discussed in the previous talks. At ME, we align our development mainly with ISO 26262, but BMS goes into different markets. And that means we also normally end up working with different functional safety norms, such as ISO 13849. But for today, ISO 26262 is our Bible. So these are the typical safety goals that we receive from our customers about the BMS. I have mentioned these here and the typical range for these safety goals. Safety goal 1, I would call it, is typically about preventing the thermal events in the battery. Safety goal 2 is about HV safety. That means providing information to the user about HV safety related information. Safety goal 3 is about disconnection in case of crash events or any emergency disconnection request. And safety goal 4 is about detecting thermal event. and inform external items about it. The typical range for these safety goals is for the first one is from B to D, and for the rest of them is A to B. Then for the third one is typically A, and for the safety goal 4, it's from QM, ASIL A, sometimes ASIL B. So I will briefly dive into how these safety goals are implemented into BMS functions. We don't have to dive deep into it, so I'll keep it brief. That means basically for the first safety goal, we want to ensure that the battery is operated into the safe operating region. I think the talk before that, they touched a little bit about on this topic. So basically the BMS is evaluating these parameters of the battery, which is cell voltages, module temperature, pack current, and then proceeding to a safe state, which is disconnect the battery from the HVNet. Then we have the second safety goal, which is about the shock. And then in case someone is operating on the battery or the high voltage side, and then for this, you monitor different criteria, different parameters of the battery, like high voltage interlock status, isolation status, or contact to close request, and so on. And the reaction is mainly to notify the users and also to contact the control if that is the situation demand. Third one is about crash behavior. So in case of crash, it's important to disconnect the battery so that the occupants of the car or the people who are coming to rescue, then they don't get electrocuted. So as from BMS side, we try to disconnect the battery from the net. And that's here, it's self-explanatory. The safe state here is contactor control. So last one is the interesting one, which is about detection of TR events. That means thermal runaway events. And here, as you can see, that even if you do your first safety goal right, which is operating the battery into the safe operating region, it could be that because of cell manufacturing defects or cell internal short circuits, you still run into a situation where one of the battery cells catches fire and then that is propagated inside the battery pack. For this, you evaluate with pressure or a gas sensor, whatever you have based on your concept. And then that is then the BMS then notifies the users in the car and also does contactor control. So these are the two safe states here. Right. So here's the ground reality. This is the typical BMS architecture that we see across the industry. You see if the pointer works. So yeah. So here is the typical your BMS master board. Here it's called SPS High, which is the product name in the company. And then you have here your disconnection devices, which is your contactors and fuses. And then here, as you can see, there are many cell measurement boards, which are spread across the whole battery. And here's the challenge. The challenge is that normally it's possible to achieve the single point and latent point fault metrics for ASIL D. If you of course select the right components, have the right good diagnostic coverages and so on. However, achieving probabilistic metrics here is a challenge because as you can see, there are so many components. It's a distributed architecture. The residual fit goes easily over 10 fits, and you blow past your budget. Fortunately, the ISO provides some guidance on it. That means the example in Annex Part 5, Annex G, they have an example distributed architecture. And there you can see that you can draw some parallels between the system, which is here in the lower side, versus the typical BMS architecture. And you can see here that for example, here, the ECU A plus the sensor A1 can be mapped to this SPSI plus the integrated current sensor in this example. Then you have your actuators here. And then the ECU B plus basically the system B can be mapped to the system of these cell measurement boards. With this, your metrics for individual components are much relaxed. You don't have to fulfill for the metrics for the whole BMS system as a black box, but then you distribute that fit and relax it for the individual components. Apart from this, there are some other ideas as well. Apart from the math, what you can do is that here you can see that I have done an example of an acyl decomposition. Here you can see the safety goal 1 that we discussed about prevention, and then the safety goal 4, which was about detection of thermal events. These are basically can be seen as 2 decomposed safety goals of a battery pack level safety goal, which is about prevent harm to people due to vehicle fire or smoke. And then these 2 safety goals become just 2 branches of achieving that. With this, for example, if it's an ACLD safety goal, then it's decomposed into 2 safety goals here. And then you can also then approach this metrics targets much more in a relaxed manner. Apart from this, the other idea is normally also that a good battery pack mechanical design that ensures that fire and smoke are directed away from the passenger cabin. If you, I mean, that doesn't have to be at the beginning of your project. You can assume the worst possible scenario and then validate your pack design during the course of the project and use that argument once you have the sufficient confidence in your design to lower the acyl in the Hara stage itself. Then there are some cell chemistries like LFP, which are more resistant to overcharge. That means first of all, it's hard for them to enter thermodynamic conditions, and even if they enter, it does not cause any severe battery fire. So you can use that argument to reduce the controllability during Hara of this event and lower the acyl again on this. Lastly, I will conclude with some challenges with norm interpretation that we face, that I see, or confusion I see in my day-to-day life, which is about that some sections of the norm can get too literal. That means sometimes there is a simple example given, and without understanding what's the motivation behind the numbers and so on, people tend to get too fanatic or too literal about what is written in the example without understanding the idea behind it. And of course, that needs to change and that needs to be improved in the community. At the same time, if there's a way for the norm contributors to provide some more context or with some white papers about the most talked about or most controversial topic like this one, it will help the community as well. On the other side, some sections of the norm can get too vague. For example, the requirements for ASIL A compliance can be unclear. That means since there are no hardware metric targets, is just the process compliance enough? That is to develop its safety processes. For example, can you have an FMEA for ASIL A function that has no safety measures for a single point fault? That is 0% diagnostic coverage enough? I mean, sure, there are no metric targets, but is 0% enough? Or is it okay to pass the assessment or to be accepted? I don't know. I'm glad that I think Shaktivel, you presented about the pressure sensor and how ASIL A, B, C, D can be achieved with those sensors. Maybe let's take an example of a simple analog pressure sensor. Here you can see that the short to ground and short to supply are straightforward failure modes that to diagnose. But like Shaktivel, you mentioned the in-range drift failure mode is not possible to diagnose with lower ASIL sensors. And then if it is a single point fault with good enough failure mode distribution, is it okay to leave that as it is? The norm does not provide any strict considerations on that, and this can potentially cause an abuse of the ASIL A requirements and can be an excuse for a bad design. So that's how I would deal with it, is to be careful with ASIL A concepts, because it's easy to prove the compliance to them, But you could also, I mean, we have to differentiate between simple process compliance versus a good safety engineering. So we have to look beyond that and look at good safety engineering and good concepts. Yeah, so that concludes, that brings to the end of the presentation. I think in my presentation, we covered that, about the common BMS safety goals. We saw how distributed BMS presents the challenge due to component count. And we can use some guidance in the norm for relaxing the budgets. We looked at some HARA approaches and also some challenges with the norm interpretation. And I thank you for your attention. And with that, I'm ready to take your questions.
Okay, went faster. So we got a few minutes for Q&A, please.
Thanks. It's a nice presentation. This is Senthil Bell from Sensata Technologies. I have a question about the relaxing the PMHF. In one of the slides where you have drawn the fault tree analysis. Yeah.
This one?
Yes. So in this case, I have a it's a OR gate. So in this case, this PMHF will get added to the safety goal, isn't it? It's a question. I have a doubt over here. That's why I just asked.
Yes, this is directly taken from the norm.
Mhm.
They didn't have the OR gate in there, but the tool that I used, they in the last moment put an OR in it. But the gates style is the same. The idea is that yes, you're right. The PMHF of the individual blue blocks gets added to the higher level target, which is the gray one.
So it still put the stress on the overall safety goal, isn't it? So
Yes, but the new metrics that you see, they are much more relaxed. They are if you initially had 10 feet of the target, if you have two systems, that becomes 20 fits.
Okay.
Yeah.
Can you please go to the next slide, please? I have a question over there as well. Yeah.
Yeah.
So in this case, I have acyl X, which is decomposed into Y and Z.
Yeah.
So for this particular box, prevent thermal event in the battery, do I need to achieve the metrics of acyl X or do I need to meet the metrics of acyl Y in this particular?
So on the BMS level, you achieve the metrics of acyl Y
Mhm.
and acyl Z. And for the common parts between acyl Y and acyl Z, you check and those common parts need to fulfill the metrics of acyl X. And on the pack level safety goal, you achieve the metrics for acyl X.
Okay, so if I decompose acyl D into acyl C and acyl A,
yeah.
So in that case, I need to meet acyl C matrix in this first box, which is there in the down.
Yeah.
Is that right?
Yeah.
Okay.
Okay, but actually, I mean, if this is decomposition, the rules to apply decomposition means that there are basically independency between two elements, and then by definition, your single point fault matrix should be 100%, because basically they are all redundant. But the metrics are still at the overall item, these are not changing. Just now is easier to meet. Now each element is contributing to latent faults, not anymore to single point faults. That is the concept of the decomposition. So, yeah. One question at the end.
Thank you.
Hi, I'm Garrett Tietz from Harbinger Motors. Regarding this decomposition, the decompose requirement on the right, where you're warning the driver, you're relying on the driver to take action to satisfy your safety goal?
No, on the BMS level, what it can do is detect and send the message.
Right, but that alone doesn't prevent harm. You're sending the message and then you're depending on the user to do something. How do you manage that?
Of course, on the vehicle level, if I'm working on the vehicle level, I would have to make sure that the whole chain, right from the point where a cell is burning versus this message is communicated with the brightest red and alarms to the vehicle, to the driver that, hey, I think your battery might catch fire in the next 5 minutes, is presented. And that's where you are. That's the whole chain that somebody has to make sure that this whole chain is safe.
Yes, but then if the user ignores those warnings, are we then telling them that it's their fault that they were harmed?
No, I don't think so. I mean, if the user ignores the warning, I mean, that's out of functional safety scope, right? It's the safe of functional safety is to prevent the failures due to malfunction of electrical systems.
Yeah, I think this question is, what is the part of the fault reaction? Is something automatically or is depending on the user? I think you had a comment?
Yes, I have a comment, Luz Garcia from Ebusco. So in general, that was also in my presentation, you need to have a fail-safe strategy at vehicle level. And at that point, you use the information from the battery management system, and another system need to take an action, a part of informing the driver. For example, you can start a cooling system to ensure that the battery is reducing the temperature. Start informing the driver, please stop within time. Worst case, disconnect the energy fully from the system.
Or drive away from the center.
Yes, and plus run away.
So this is Kevin from Bogona. So I have another comment, like if you see NXD, I think of part 5, it allows you to use that you can tell user that there is a problem with lamp on, but you cannot ask for, like, let's say 99% coverage. Your coverage has to be lower, but you can say that, oh, I have informed the driver. That is a valid safety mechanism, but the diagnostic coverage would be much lower.
Yeah, I mean, in general, we should not really rely so much on the driver intervention, because then you are depending also on the driver ability, and then it's becoming really, for me, critical.
So I have a question on this decomposition. Like, how do you prove the independency? Because to me personally, it looks like very dependent.
Yeah,
safety
depends on your architecture, depends what's being used. Of course, you have to prove the independence. And in case if you have any common cause faults, then you have to make sure that they are handled with the highest possible ASIL.
Thank you.
Okay, and I think it was also one interesting topic was touched here, not about electrical vehicles, but more about the ISO standard. What does it mean, ASIL A? That's, yes, I agree, is a big question. And to be honest, I never work on ASIL A projects. We always started from ASIL B. But even ASIL B, there is an issue because the metrics are recommended, not highly recommended. And yeah, we can see in some regions, in some companies, they don't do metrics. They don't even do assessment because it's recommended. Then I see that even with the same ISO standard, we have a 2 level of safety. And there was a discussion actually now in the 3rd edition to change the recommended to highly recommended for the ASIL B. But unfortunately, yeah, many companies rejected this because, hey, what's happening with the existing system? Then we need to change them. So, yeah, that is also a very interesting topic.
Yeah, but at least with ASIL B, you can still ask if you have fulfilled the 60% diagnostic for single point faults. But for ASIL A, there is no way, even if you keep 0% diagnostic faults, or your FME line item says that I don't have any safety measure for this, you can get away with it.
I mean, the point that with the ASIL A, the risk for hazard is so low that you accept maybe some process only. Okay, the last point, and then we move to the next question. Sorry, next topic.
For me, what you showed is kind of a classical dilemma. You can either look at your problem through the standard, or you can look at the standard through your problem. So I prefer to look at the standard through my problem, because then I look at the standard providing guidance rather than providing truth. Because as you rightly showed, it can't, it's impossible. I mean, if you actually witness a committee meeting, it is so far away from truth.
Yeah, I mean, that's my approach as well. I mean, I would look at first, if I want to do any safety goal fulfillment, I would first look at the standard, check what I need to do and so on. But you have to look beyond that and check if it makes sense. You don't have to put your logic and common sense behind just to fulfill the check boxes that we...
The issue is we go back to safety culture, yes. And some guys like to use the standard as a reference to what is my starting point. Others like to use this as that's what I have to do. Anyway, we have no problems. We only have challenges. Okay, thank you.
Thank you.
Okay, we have the last presentation of today, but not the last topic. So we have Helen Bushomeskin, or Buchomeskin? Yeah? Oh, Bushomeskin, good. Director of Global Functional Safety and Compliance at the ARM. And yeah, floor is yours.
Okay.
I think everyone knows you already.
I need to stand here, right? But I don't
Can
know.
use the mic or you, yeah, whatever.
Are you still capable to sit, guys? I'm just checking. It was difficult for me. So if it's difficult for you to sit, you're welcome to stand as well. It was interesting for me because, you know, I discovered that I'm in the end and no one would be here. So thank you so much for staying so long. And I'll try to make it as interactive and fun for you as well. And I thought, do I have oh, this is a clicker. Let's see how it works. But let me also ask you something. How many, and actually it was interesting that this conference started with some questions about culture. So how many of you think culture is important for functional safety? Oh, nice. And how many of you think that your companies invest enough in culture? Okay. Well, good. Oh, thanks, Chris. Okay. Yeah, you're here. What I'm doing? Oh, this goes back. Okay, I'll skip this slide. The reason actually I put some slide about myself is just to say I don't think I have all answers and definitely don't try to share all answers. I'm coming with my experience and my knowledge and everything I did so far, but you did much more. And I really want to keep in touch and continue this discussion, right? So I just want to share with you what we do and what we think on this topic. But please, I put my LinkedIn here. Let's continue. This is my main purpose of this presentation. I want to be in touch and see what you do in those domains which I'm going to talk with you about. So this is me. What I'm going to share with you today is our journey in ARM. And I'll talk with you about what we think or how we establish and what we think in general about safety culture, why at all we started to deal with safety culture. I'll also introduce to you our safety quality security governance framework and what we also do with AI and how all of this actually connected and related and why it's so connected and related. And actually it was fun, right? Because I think all of those three topics were covered today a bit. So I was thinking, okay, it's really interesting. I did some changes to this presentation also based on some discussions we had here at breaks. So let's see how it goes. So I started this role of global functional safety, head of functional safety in ARM 3 years ago. And I felt a huge responsibility. And I decided to ask people what they really want me to do. And in ARM, we have this very nice tradition of Functional Safety Summit every year. And I decided to go to everyone in the summit and ask them where you want me to invest. I thought they would say you need to work on tailoring of safety standard to ARM processes and products. I thought they would talk with me about complexity of reviews and decomposition and lots of aspects. But I was quite surprised to discover that 35% of people actually said foster safety culture are the highest priority. And I was, me and my boss back then, we were like, okay, interesting, safety culture, what we should do about this. And why people want to really look into culture. I started to ask engineers, what you guys want me to do about culture? Funny enough, they said, we really want to measure it. And I'm an industrial engineer, right? So I was very happy to hear people say we need to measure this. By the way, Edward Deming, one of the founders of industrial engineering here in the picture, talking about his statistical process control to Japan, a Japanese audience. Many people said that he's the one who invented this sentence, if you cannot measure, you cannot manage it. This is not really true. I think Edward Deming knew exactly that most important things is very difficult to measure, right? How you really measure love, for example, or trust or culture. But as industrial engineer, I thought this is pretty cool. Let's talk about this. Let's see how we can measure safety culture. And why is because my engineers, safety engineers, really wanted to find a way to communicate issues related to safety culture to everyone else, right? So we started to think and look in safety culture. Now, culture is tricky, right? Culture is pretty difficult. It's pretty difficult to be measured, developed. I think the biggest challenge is also it's very pretty difficult. I don't know what you think about this. Sometimes it's very difficult to admit that culture does not exist, right? So the issues with culture, we are sometimes feel a bit bad to say they are not there, like, Naked King or all of those phenomena. Two pictures I put here, Challenger disaster, and I'm sure you're all familiar with Dieselgate. If you read the root causes of those disasters and actually many hours, of course, technology would be there, right? There would be some issue with technology. But at the end, disaster or scandal happened because of people. So in some situations, people didn't want to talk about problems or they were afraid to raise issues. In some situations, like Challenger, for example, there was a smart, by the way, all of those bad decisions made by very smart people in the room. So in Challenger disaster, I don't know how many of you are familiar, there was a person in the room sitting saying, it will fail, it won't work. But we already ordered, all this marketing team said, but we already had, many people are coming, journalists are invited. We also have press, we have lots of, nice party and refreshments. We need to do it. And smart people sometimes doesn't make those decisions, right decisions. And one of the reasons related to this is when you guys and we all study engineering, we don't really talk about soft skills. We talk about how to calculate very complex formulations. We talk a lot here about lots of very complex things, but how we establish trust and how we establish a proper relationship and how we really make people to really speak up in meetings, right? What we should do around this, those are soft skills. There are many cases underestimated. But different direction. Our beloved standards 26262 and 21434 actually did a pretty good job in this domain. And by the way, the resolution is terrible. Sorry for that, but I hope you would get proper PDF with all of this. Yeah. But this is the appendix from 262. Groupthink is here, it's mentioned. And when you read those appendixes, pretty good examples here describing poor safety culture and good safety culture. But again, we cannot really share it with ARM engineers. It's not really something you can digest. So we were looking for some less overwhelming way to talk about culture. And this is how, this is how we invented what we call safety meter. So this safety meter was accepted and used even more than I ever thought it would. We use it in multiple conferences. We share it with, I think, more than 2K here, people in ARM feel this safety meter. I also made Chris Boss to do it and many our leaders in ARM. Richard, by the way, Chris, I don't know, we have him as well. So what we did, we gave to people stickers, a blue sticker for where we are and red stickers for where do we need to be. And we just asked them to rate it. And it was very visible, no judgment, no fully open discussion here. Following this safety meter, we really managed to increase awareness to safety culture. We could compare different results in different regions. For example, in some our ARM offices, people were rating people don't feel comfortable to raise risks. So some of them rated higher, some of them lower. It was very interesting to understand differences between culture, but also it really helped us to think about follow-ups. We did lots of workshops. We really started to invest in this domain. We quite, it was very significant. So I know that many spin-offs and many initiatives happened post-safety meter. And my colleagues in product security department created also security meter. And since then, they pay me royalty for every sticker security guys use. I always check it. Guys, anyway, we use it across ARM and it's pretty popular. But also what it helps us to discover, it helps us to find measurable gaps, right? So it helps us to identify issues. And one of the biggest issues, as you can see here, was related to reviews. Now, I did this survey not only in ARM, I check it across industry. If I would ask you here as well, you probably would select reviews, fast tracking as key pain point in your, do you agree? What do you think? Is reviews, does it an issue in your organizations? How many people like to do reviews, don't like to do? In many, I ask it. No, I'm asking this not only in ARM. I'm asking in many conferences, and I always get reviews as a big problem. We could not start working on reviews quite back then, 3 years ago. But once AI became a thing, last year we actually realized that safety reviews are amazing use case for AI. The reason they're pretty repetitive. Time is a king. There is general frustration and fatigue by people who are participating in the review life cycle. Also very interesting when there are many researchers today which shows that we feel much better to get feedback from AI on simple issues. We still want to get human judgment on more complex situations. And based on analysis which we done, we actually managed to calculate that around 80% of issues reviewers find we can resolve using our model, which I'll show you in a few slides. We were also debating, do we want AI assistant or we want qualified software tool? We compared those few options. At the moment, we decided we will keep with AI assistants. We don't want to go through certification and qualification, especially because AI is still very early in its development lifecycle. Now, where we started as for every safety project, we start with requirements and we ask ourselves this question: what does it really mean? Safe for safety AI assistant, right? What would be those characteristics? And those are key principles which I wanted to share with you, like those Asimov laws for robots. So first of all, we want our AI assistants to be tied to specific goal. Now, I know we spoke a lot about models. We spoke a lot about how difficult it's to control them. However, we try to define very specific boundaries. And when we run our AI assistants, we want to use this concept of rules. And similar a bit to MISRA rules, for those who are familiar, very, very specific criteria on what AI needs to check. AI acts as independent reviewer. Now, this is really, we spend lots of time on that because we don't want AI to provide suggestions. Sometimes you ask a question and it would say, oh, maybe this formulation would work better. No, AI assistants for safety must be independent in same way as my team provides feedback or identified gaps to people who are not part of the solution. Accountability, human judgment is a key thing here. We don't want to get rid of it. So the way we build our AI is not to get rid, it's by design, encourage people to think. It's not providing again solutions. So this is all by design. This item, by the way, it's interesting, right? Because it's not necessary, but we thought one of the principles would be that it not only will replace human, but let's see what humans can do today, and AI can. And this is, of course, one of the key principles here: reliable as much as possible and transparent, right? So the rules we are using, we are applying, are visible to everyone. And I will also talk a little bit about how we do this crowdsourcing, but we invite everyone to participate and contribute. So people who would use AI would be part of those people who are creating those rules, right? Defining how it would act. So I know there are some questions about what's happening there in the back. I'll just few for those of you who are a bit more there. First of all, we had this huge treasure proprietary legacy review database. Many of you have it as well. Some consultancy companies who are trying to develop those tools don't have it, right? So there is a huge benefit of doing those things internally as well. We started with RAG. Our first MVP was using the RAG pipeline. Today we moved to KAG. I won't get into much details around it, but we can talk about this later. We found it today based on the hackathon we did last week as more efficient. Yes, so we are using AI to deal with language and context in safety, life, FMEDA, DFMA, all of those. There are lots of numbers, and for numbers, we don't use AI. It's not so good with this. We don't using large learning models. We are using static analysis. And it also helps us to increase predictability and make it much more controlled. We close loop with human experts, and it's all developed. Now, one of the issues which we have today, we don't really have those resources, right, at the moment to invest into this. So we started with interns and graduates in our teams, and we moved to a model of hackathons and crowdsourcing. So last week we had one, and those are very fresh photos of us working on next generation of USAI last week. So I don't have lots of time to demo, so this is more like I'll show you a little bit. Oh, you won't be able to read nothing, right? But there are rules here which are very obvious. There is a feedback here. Oh my God, this is, you would get it all in PDF, so it would be much better later, but just to show you some examples. So this is an example of tailoring table. So for example, here you may see, maybe not, I don't know if you see applicability is no, but justification is all applicable in this example. So we will, so the feedback which AI provides, this is inconsistent, and it explains why it's not inconsistent. It's not telling you how to fix it, right? And it also doesn't tell you it's wrong, it gives you alert sign. So the author can take a look and make a decision, is it a valid comment or not, right? So this is just one of the examples of how AI can provide independent feedback. And we also checked, this method also was pretty robust in terms of, or robust, right word would be probably repeatable. In some cases, what we got that some rows were in wrong directions, in different directions, in different places, right? So sometimes it changed the position of answer, but the response was the same response. And I think the way we managed to control the boundaries really worked for this case. Okay, so so we played with this. This is something. This is part of the MVP we did last year by our two very talented interns. Something they told us, you know, this is very nice, but it's not enough, right? It's not enough. AI by itself cannot solve the problem. And that's why we came with this FUSA efficiency V model for ARM. While our AI assistant is here, FUSA AI, right? Now, what we realized that if we will put data which is not really machine readable or not really understandable by AI, it won't really be useful, or the value won't be so big. As well as if we don't really know what to ask, we won't get the right answer, right? So we need to really work, and to make AI be very effective and very efficient, we really need to create this data model. So, and this, by the way, this is what we were doing last week in the hackathon. So what we are working on now. So first of all, our templates must be machine readable, and there are many nuances how you can make your template much more easy or clearly understandable by machine, by AI, right? So if I want my review be better, and my input should be in better format, so AI would be able to read it. And also we are working now to create ARM safety data format. Actually, this is something we already have, but we want to create a data model which would feed information into this those templates, right? And also we are working on governance framework, which would define exactly what needs to be checked, right? So we want to get compliant, correct, and valuable prompts and review questions, and everything would be playing, dancing together and fully aligned. And now, so just briefly how it was looking before. So before, we believed that we spent 80% of our time on correctness. Our author got input, created a safety document, and it went through multiple reviewers and assessors. What happened? Yeah. No, I'm not good in this, sorry. Now, the result after we have this process, we have all this backend happening with FUSA AI, smart templates, SQS framework, and ASDF, resulting in spending 10% of time on correctness and improving of the model, and 90% of our time on really safety activities, right? So we are not saying that we are replacing people with AI, we are improving and making their value-added work to be much more meaningful using AI, if AI can sort out those a bit of more simple tasks for us. Now, a few words here also about process, right? So something which we developed to really make it all work. I really liked all today's morning discussions about holistic approach to quality, safety, security. Absolutely, this is the only way. And we also created our framework, which we call it SQS framework, which has together all processes from functional safety. It's also created this plug and play mode, so we can always easily add new standards into our framework. And it also defines those work product requirements, which goes as input to FUSA AI. So one of the tricks here was to make sure that our process, our templates, all our reviews in our system, and FUSA AI asking and requiring the same questions, which make it very clear to users what to expect and what to do. I can talk about, by the way, about this topic also a lot, but just because it's so late and you're so tired, I'll just move to talk a bit about insights here, and maybe we can open it for questions. So what happened here, right? So this is just a brief at glance what we did in the last 3 years in ARM. Safety meter. Safety meter, maybe it sometimes feels a bit funny why we should do all of the things, but it really helps us to boost engagement and shared ownership. More than that, this model of crowdsourcing, which we used to develop those tools, would not be possible without creating this strong culture in ARM safety community. So it really helps us to make it all work. We created one holistic process, right, which allow us now to align better, understand better what everything means, and basically have this clarity of how to create prompts for AI, which is also complicated. Result, we are accelerating and we are basically adding 10x mindset here, and people would be able to focus and provide much more added value. Now, really interesting, right? I'm sure you're all familiar, but with this model, people process technology, it was invented in 60s, quite old model, but I think today is even become more relevant moving into AI. You must have process, you must have people and culture to be able to leverage this amazing technology which we have. This model also talks a lot about balanced investment in all of those 3 domains. So I think this is why I asked you in the beginning, do you think your companies invest enough in culture? It should invest enough in culture, process, technology, not one of them independently based on this model and based on our experience. Otherwise, it won't really work. And how I see the future, we spoke about this actually yesterday also in the panel. I do believe AI would be even more meaningful every day, and we should get ready to this. I think that we should, of course, prioritize safety, quality, security, right? We need to invest in efficiency using AI, but this is really what we need to do, and we need to always remember that this is our highest priority as per the standards. And culture would be the thing. Culture is the key to make it all work. And I think that's it. This is all I wanted to share with you today. I got I got you also as takeaways. Okay, I have small postcards in the form of our safety meters. So if you want to check, and I also have some safety bookmarks here, which you're more than welcome to collect. Yeah.
Excellent.
Yeah.
So I guess next year I won't be here as a chairman. We're gonna have AI helping out. Okay, 1 or 2 questions. One question over here, yes.
Thank you for this great presentation. My name is Melih from Robert Bosch. And I want to ask you regarding the, you have said that we have created smart templates. And from these smart templates, AI has read. So what did you actually additionally add your existing template? Because normally the corporate templates are very in very similar format. So what did you do to read by AI?
Yes. By the way, I'm more than happy to follow up and share much more detail on this, right? It's a huge topic. We use today Excels and Microsoft Words as templates for some work products. Some funny things, like for example, table can have different structure. In one way, table can be organized. It would be clear for AI. In another way, not. Sometimes people leave blank fields or merged fields. AI, very difficult for AI to deal with this. So we try to organize things. We try to identify also what would be the inputs and repeating values in those templates. And we created one place to put all of them, saving lots of time also to people who are generating them. At the end, where you want to go that it would be very easy to, I don't know what you're using, maybe you're using much more advanced formats, but you should be able to extract your template to something like XML or Markdown or some form which is much more structured. So if it's structured, I can feed it to AI. AI can, of course, read any template, but what we want to do here, we want to reduce the risk of errors, right? And if I want to reduce the risk of errors, I should be able to explain to AI exactly where information is. And that's why I need to mandate a structure. Excel is even more complicated because Excel is like all over the place. So you need to also define the boundaries.
Thank you.
Yeah.
Okay, quickly on to next.
Okay, thank you, Luz Garcia Busco. My question is, you talk about a lot of employees engagement, but if I go at the beginning of the presentation, was people afraid to share those risks. I think is the work is not the people, the technicians. I think it's more the management and the leads of the company. How do you involve them to convince them that the safety is important? And
Yeah, great question. So this safety meter, there is no one person. So in ARM, we have our CEO, Rene, and there is his leadership team, our highest, every one of them filled in the safety meter. Right, so we really took it there, and I think also something very interesting with senior leadership, they care about those things. We don't talk enough with them about those things. And if you come to those leaders with this cool thing like safety meter and ask them, what do you think where we are? They've all were very engaged, and many of them stay for quite long time to talk with us, right? So this really help us and open this opportunity to start talking with them. In addition, we do, and by the way, I'm more than happy to share those materials. ARM is not selling safety culture, we are selling our IPs. So more than happy to share all we did in this. We have workshops with some situations, which we started to involve also with leaders. But I can also tell you that it goes from top down and bottom up, right? Every person needs to understand the value of me talking about risks, me highlighting that there is a change which should happen, me highlighting that there is the FMA item which was forgotten, right? We need to understand the importance of this. And when we hear it from all of those directions, it really helps. Okay, thank you.
Okay, let's move very quickly on the last one, and then we need to move to the final topic.
Yeah, so very short comment on what you mentioned before about the data format. Actually, this shows how important it is to have reusable formats, and this is what we learned is text-based.
Yes.
We have everything by now in previous already in DocBook. Now we're migrating to ASCII doc, or Markdown is something similar, and I can only recommend going this way. Then you can also feed it directly into your AI systems.
I agree 100% with you. And I also want to say that one of the powerful things here is that by showing the value of AI, we also can make people to really adopt those templates and align much better to our holistic processes, right? Because they can, if you show them this would save you so much money, so much time, you would be able to invest in much more interesting tasks. They would go and collaborate. Yeah.
Okay, I mean, we could stay here still a few hours, but unfortunately, we have to move on.
Thank you very much.
Okay, we have now the last panel and the last topic of the conference. I know you're so disappointed, but every good thing come to an end. So, can I invite here the panelists? So, Dr. Christopher Temple, Dr. Gordon Elger, and Dr. Max Walter. So, great. It's okay. Yeah. I'm doing multi jobs. Okay. I mean, I'm very sorry that this topic is really at the end of today with a few people now in the room, but thanks again for staying this long. And I think that is, again, a very interesting panel discussion. And it's really how we are evolving. I mean, we are talking about AI, we're talking about failure modes, next generation, so on. But let's start with the first topic. Basically, kind of fault models or failure modes as what we have. So we discussed before kind of checklist approach. So are the failure modes a checklist approach that we have basically all the failure modes defined? You can look at the part 11 or part 5 before and all is done. Or because we are moving to new application, new technology, process nodes and so on, we have to reconsider our view. And maybe what we have is not fully up to date anymore. Who want to start?
Yeah, maybe I start. So the question here is about complex and intermittent fault models in modern SoCs and ECUs. And yeah, so first of all, I have to say I'm more on the software side in safety, not on the hardware side. But I think if I would answer the question with no, we don't have to evolve with the technology, that, I mean, it would be obviously wrong. Yeah? So if this technology evolves and we have new failure modes which weren't present before, we would make a mistake. So definitely we have to consider failure modes if new failure modes arise, if it is important to also take into account intermittent fault. So there can only be one answer. Yes, we have to then integrate them in our observations, have to think about it, and have to, if we come to the conclusion that it may become dangerous, also include measures against these or detection measures against these kind of errors. From the point of view of the systems we are using, I can just comment there are also measures which also work well together with intermittent faults. For example, the presentation I've shown earlier, if you have this communication, if you check every telegram, it doesn't matter at all whether it's a transient fault, an intermittent fault, or a permanent fault. So in this case, we are lucky that we don't have to care about it because it's already covered. But there may be, of course, other measures where it is a difference between intermittent fault and transient fault.
Right.
When I came here, I was a little skeptical. I heard great presentations the last 2 days. And I think my concerns, and I do have concerns regarding these complex fault models, might not, or I think they're being addressed, right? I think there is more awareness than there could have been. There are in complex devices, in ultra complex devices, I would call them, right? When we're looking at 32 cores running in parallel, out of order with weak memory ordering, highly optimized software compilers on top, there are very strange cases where, as I said yesterday, it's hard to say that there is a single culprit in the system, but when all the participants collaborate with one another, and I would call it strange effects occur, that at the end shouldn't be there, and the ISO would consider to be a fault. And I think what, ideas we saw today, for example, to say go from sort of more like a structural block diagram fault model to a functional fault model, look at high-level functions and how can they fail without spending too much time obsessing about what was the root cause for the failure, because in some cases you just can't find it. But if at a high functional level we achieve a sound safety concept and we carry that down into lower levels of the architecture, then I think we have a good fortification against these strange problems that can occur at lower levels, including communication when I think of Byzantine faults, right? So that's a special class of problems, and in your safety measures, you didn't have any mitigation against Byzantine faults. So I think we need to evolve and we need to capture experience, but the understanding here in the room today and yesterday gives me the confidence that we're on the right trajectory.
Yeah, regarding problematic intermittent failures. I mean, they occur due to what you said, many different situations, and within a complex system. And then they have a certain probability, and then they, then I can estimate, okay, with a probability they occur, they are not a problem. So, but when during a lifetime, then aging processes occur, they might get up, or certain parameters like the temperatures go up, then they get maybe more probable. They occur more often. And even if it's difficult to find the root cause, in the end, there is some physics behind it. So therefore, as a reliability engineer, I would always say, in the end, I need to try, or I need at least people who are trying to dig deeper and find really the root cause, why then the probability gets higher. Even if there is a complex combination of states and situation, at the end, there is some physics behind. And therefore, I should try to understand what makes them occur more often, and then I can monitor those magnitudes, and then I can understand under certain condition those intermittent failures were more often, and I might then and those increase of currents, increase of risk, I would try to include in my evaluation.
Yeah, thanks. I mean, do you want to comment?
It triggered a thought, and I think it will take us to the second bullet, right? What the car industry has been very good with for liability and warranty reasons is to understand the beginning of the bathtub curve. And the end of the bathtub curve is kind of, the car is in ownership and a lot of cars get scrapped and damaged before they reach the physical end of the bathtub curve. What I think we can say for sure is that if we put more semiconductor content and more electronics into the car, presumably the bathtub is getting a little smaller. So the question is, how do we deal with the end of the bathtub? And I think that is kind of the aging effect. We were discussing yesterday at the bar, there are ideas to have, the analogy of canaries. And in the coal mine, when there is a danger, the canary stops singing. And the question is, you can put similar constructions onto semiconductor devices and get indication for early fatigue. It works very well in data centers because number one, you have good operating conditions, very solid. And number two, you have a service technician who, when the canary stops singing, will go off and fix, right? In the car, it's not that easy because if in 10 years, the canary stops singing, who's the person who's going to hear and listen, and then what, right? Then the customer has to go to the workshop and say, I have a problem, which hasn't become evident, but is most likely. And then the garage says, okay, you have to pay for it and invest a lot of money in a 10-year-old car. That probably isn't that attractive. So it's a huge challenge, and I'm curious what my fellow panelists have to say about the aging.
Yeah, I'm not a car expert, but as far as I know, there are also many mechanical components in cars, and there you have the problem with aging too. So, and there are tests during the lifetime of a car to check whether, for example, the brakes are still working and so on. And cannot these kind of techniques also be applied to semiconductors, so that you say, let's say in the biannual check you do with your car, you also check the canaries, and if you have driven your car in an environment which leads to a early fatigue of your electronics, okay, then it's a problem, and you have to change it. Like you have to also change maybe your brakes.
But the question is also why this point about the degradation faults, intermittent, is getting now a bit more hot topic. So was not this an issue also 20 years ago? Why? What is changing?
Not sure. I think there was a time when there were problems with semiconductors, and then the semiconductor industry and the car industry together sat down and developed AEC-Q100 and burn-in tests and put a lot of effort into making semiconductors more robust and adequate for the car industry. I think what's happening now potentially is that there is an interest in the car industry to adopt technology that is very advanced, and it doesn't want to sort of wait, right? So there's a cost pressure, there's an innovation pressure, and there is this attractive technology out there, and it will make its way into the car. And the question is, we will all learn collectively how it will develop from there.
Yeah, right. Yeah, I think before we used to be a bit more conservative, automotive world. Now, yes, we are trying to kind of push the envelope, and then we see issues. But I mean, of course, the degrading faults is something now getting more critical with especially the new technology that maybe we don't have enough confidence. Intermittent faults was already part of the first edition. But I think the meaning of intermittent fault, I see, somehow is changing now, because intermittent before was more a kind of maybe a loose connection that can be kind of transient fault. Now is more maybe also a temperature dependent fault that, yeah, some test that will detect a transient fault will not detect this kind of faults. So it will become a kind of common cause failure as well.
Electronics are expensive. The life cycle is very short-lived. And more, I was part of a presentation at the VDA, when it used to be VDA Baden-Baden conference in 2012. And we predicted at the time that the car industry won't be able to load a single fab with its semiconductor content by 2015. And then in 2020, when the semiconductor crunch appeared and everyone was screaming for semiconductors, I looked back because in 2012, when we made the prediction that the time will come when the car industry will not be that dominant and will be replaced, we didn't foresee that it would be handies and cell phones and everything, but it was foreseeable that the relative dominance of the car industry and value in the semiconductor market will diminish in comparison to others, right? So yeah, at the end, there's going to be an interesting learning curve between the car manufacturers, the consumers, and the value of the car as a value proposition that we still today expect to be of value for 15 or 20 years. At least we silently say we don't buy a Mercedes because we like it. We say we buy it because it's a long-term solid investment for 20 years. And then we sell it after 5 and get the next one, right? In future, maybe after it will be harder to justify that it's such a long investment because the semiconductor content will ultimately decide how long the car represents value in the market rather than the sheet metal that represents the value today.
Yep.
So when a system function, there is no failure. So, and then at the end of the life, there is the failure. And in between, in a state where the system is not fully intact or not fully operational, there is this intermittent failure. In many cases, let's take really an easy example everybody can understand, that are our solder contacts of our components. In the beginning, they conduct. At the end, when we have a huge amount of thermal cycles, there is a crack, they are open. And in between, there is an intermittent state where they open and close due to temperature, for example, due to thermal stress. And then failure occurs sometimes. Then I try to test, my system is cold again, everything is fine. So, and this simple example, I can't really transfer that to any electronic problem, but in many problems, in many intermittent failures, that is the case, that the system has already some defects which take place when complex conditions or when certain conditions take place and then suddenly they fail. And when the system degrades further, then at a certain state, I have a permanent failure. It does not apply for everything, for every failure, but many of those failures I can describe with this approach.
Yeah, no, I agree, and maybe I would like to add an extra question. Sorry, I'm deviating a bit from the points there, but today we know somehow how to quantify, at least in semiconductor, random are the faults. We are using Siemens or 6230. If now we go to degrading faults or intermittent faults, do we know how to quantify, or are we using the same handbooks? I mean, extra question, but do you want to answer this, or?
Maybe the next bullet has the answer, right? We need more AI in the car to diagnose the faults that AI has produced. Then those faults get reported to even more AI. It sounds like a good business model for anyone in the semiconductor industry here.
Before that, I'm going to bring for the second bullet one vision. And the vision is when I test for product development, my products, I have standard accelerated condition. In the field, I have a huge amount of different conditions, and my system, yeah, it might be even that I don't see any failures because I just got the failures due to my extreme acceleration. So my vision is really that I monitor critical components over their life. So it means I have a clear path or a digital life path, which tells me how much load the system has seen in automotive temperature cycles or current, and I I write that down. I might really communicate over the air those state of aging of components in my car. And then when a certain, residual, or when a certain age is reached, or when my remaining useful time of life gets at the end, I need to exchange the component, or I close down my car. So a digital life path for my components, because nowadays it's so simple to really observe what is the situation of my car, which temperature, where is my car, how salty is my atmosphere. I can record everything. And when okay, some privacy is maybe here in the way, but I can anonymize my data that I get for my system, a digital life path, which allows me better to address how much of the life is over and how critical gets that component.
Yeah, that is a key challenge. We discussed, I think, today or yesterday about it is end of life. How do we control it? And especially moving to more electrical cars, electrification. I think the lifetime of the car will reduce somehow. And then we spend a bill to say, okay, you reach the end, you need to change your ECU. Will be the OEM, will be the component supplier, will be the customer. I mean, are we going to buy a car that we say this after 20 years you need to last, you need to change? I mean, maybe it's okay, but somehow it's different. Yeah. Okay, before any comments or questions from the audience here? Yeah, one here. Do we have
Rogier Knapp, Sensata Technologies. I think the discussion is partly already solved in automotive. I mean, being involved in brake pressure sensors, very high volume market, our sensors would not be acceptable if they have more than 0.1 per million failing in the field, because, well, we produce 40 million of them in a year, right? So if it's 1 per million failing, it's 40 coming back. So these challenges described on intermittent faults or solder faults, they're already in industry being solved, right? You can argue about, okay, how much of that needs to also be implemented as part of FUSA, because FUSA is maybe a bit too relaxed about it, right? As well, we have 99% detection is enough, right? But in our practical implementation of a sensor, for instance, we have a PCB, an ASIC that's mounted, or monitored between the pins. Those ASICs are very advanced in monitoring open, closed, what's happening on the PCBs. We have known failures of PCB contamination, where the parts grow together. We have known parts of package delamination, which again is diagnosed by the ASIC. So a lot of this can be done, but it's a question about how much effort do you want to put in and how much in detail do you want to go in the component, right?
I agree, and I think sensors are very advanced. What we see kind of more on the semiconductor side is we're really moving towards the bounds of physics. And as well as the charges in DRAM are concerned, there are just very few electrons that distinguish between 0 and 1, and ECC codes and things are added to compensate that. We're driving towards the limit of yield of dies. So the next big thing in automotive is going to be chiplets. So designing kind of smaller chips and then combining them in a package in a three-dimensional way to chiplets, which creates a further physical challenges to get the heat dissipation out of the package. And the simple question is, how much margin is there still between the system we have built and the system that doesn't work quite right anymore? It still works right most of the time, but not quite right anymore. And that margin, I think, is shrinking, right? How much and whether we will have new ideas to push it further out, I don't know. But from today's perspective, it's getting smaller, and I think that's creating sort of this specific challenge for semiconductor processing chips.
Yeah, we're really pushing the boundary. Okay, one question here.
Now that you mentioned chiplets, that's actually an interesting point, because to me, it's not fully clear why Automotive is actually interested in chiplets, because the space limitation is not as strict as in mobile devices, for example, where I do understand why we push the boundaries and get smaller, 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 because you don't want to see the earpiece anymore, for example. So there, the space limitation is real. Maybe in aircraft, small drones, you have weight and space limitations as well. But for cars, actually, I still don't see why it's actually necessary and why we would buy all the additional complexity and problems that we then need to address.
There are two drivers. The one is yield. As a monolithic chip gets bigger and bigger, the probability of a defect somewhere on the chip during the manufacturing process just increases. And at the end, the yield goes down. So if you have smaller chiplets, then rather than sort of having one the size of a postcard, you have it the size of a stamp. And if one is impacted by a manufacturing defect, you throw it away, but all the others are still good to use. And the second challenge is variation. It gets very expensive to produce these high performance chips, and it's even more expensive to produce variations. And the idea with chiplets is to say you sort of have a set of, let's take 5, and now you can just combinatorically modify and say, for a vision camera system, I need a chiplet that has a graphics processor on it. But for example, for an autonomous driving system, I want one with high performance compute and a neural processing engine, and you can create those variations. The cost that we're looking at for masks for just kind of a first set of 2 or 3 reasonable chiplets, it's 3-digit. You're looking at 200 to 500 million euros for the mask set to get started. And there is nobody in the car industry that has those budgets to do it, right? So there's a lot of activities you will see of car OEMs and tier ones getting together and discussing chiplets and creating consortia and everything else. One hope is always that someone will appear who has the money in his purse. That so far has not quite materialized yet, but there is this big question: how can the car industry manage this gigantic investment that is needed to get these sustainable high-performance platforms?
Yeah, also there is maybe a third dimension about the scaling. So if you're changing, okay, there is one question here. If you're changing the logic, moving between process nodes, you can get benefits. But if you have something analog or power, it doesn't scale in the same way. And then there is a tendency now to split and have different technologies as well.
Maybe I didn't get the first question, maybe the direct answer for this, because my understanding SoCs are different, and also we need I guess there is no common driver that could be applicable for all SoCs. Otherwise, we will miss the performance of the SoC, for example. So if we are thinking high level to have a fault model, can we get this generic fault model that's applicable for all of SoCs?
I don't think that being generic is why does it have to be generic? I think at the end there's going to be like 1 or 2 platforms on how these systems are being built, and it's personally, I believe, going to be more an in-context challenge of solving the problems for the 1 or 2 platforms that materialize than an out-of-context problem of solving it generically. And I think the limit is not technically, the limit is simply the money, right? There's going to be just, the car industry can't afford to have 3 or 4 completely different, for example, architectures for which support each one of these architectures with bespoke chiplets. It's going to be a investment disaster. It's just not sustainable, right? The 500 million nobody has.
Yeah, because if we are going to have these models, so it's guidelines in new norm, for example. So it would be to be applied differently from SOC to another. So we'll go to the conventional way of analyzing the models and like in FMEA and go to this hierarchy also from level 1, 2 until deeper in the details. So at the end, we do the normal way of analysis the false.
Again, what I see everywhere is this cost problem. You have the cost of the mask set. Now there has been discussions on, we heard UCIe Express. Is it worthwhile to put 2 or 3 UCIe Express interfaces onto a chiplet? That if one fails, because the physical connections between the chiplets, as we heard, is a prime area where you can expect intermittent faults to occur. So you say we have a backup. They are not for safety, but for availability reasons. And now it's simply a cost trade-off. One can say, what is the reputational damage to the OEM if after 5 years, certain number of customers have to go and get the ECU replaced? Or is it better to say, no, we carry the cost up front and we put additional UCIe Express interfaces onto the chiplet? And when you look at it, these things are expensive, and it's a non-trivial problem. And there is a lot of debate ongoing as to how to structure this.
Okay, thank you.
So perhaps also one short comment here regarding chiplets. So we're talking about this if it were a future technology. It's not. Chiplets are sold. So modern Intel CPUs are chiplets. AMD CPUs are chiplets. So the question is not if it will come to automotive. The question is when.
It's
when
coming.
is it efficient enough, cost efficient enough that it's sold? It will come.
Not will, is coming. So yeah, it's already reality. Yes. Okay, maybe you want to say something?
I would say, I mean, when the other industries, which are more in the mass market, switch to chiplets sooner or later, then also automotive will use that chiplets and build up some automotive components out of that chiplets. Would be my answer. And we just use chiplets in research projects because we wanted to mask the real function of the device. So we split it into chiplets, and then the manufacturer of that chiplet, so a factory, cannot understand the function because because the single chiplet is not having a function. It has just a function on the package level when I put the chiplets together. But that's also too costly. Then modularity was also a topic why we researched chiplets in automotive. That was just a radar sensor which we produce based on chiplets.
I bridge the gap to soft. So both in I'm in the UCIe Express working group. I'm also in the chiplet activities in the safety working group at IMEC. And one of the questions that emerged independently is how does the error reporting occur? How does the error reporting for safety occur within a chiplet? And how does it occur over UCIe Express between the chiplets? And a coincidence, I came when those discussions started, and eventually I said, let's focus on RAS. RAS is error reporting architecture that exists in servers. It's supported by Linux. It already has a fairly good infrastructure. And then a number of people said, we don't know how RAS works, right? So we first spent some time saying, okay, let's look and everyone understand what exists, and then see that we can take that into the architectures and then have software reuse the infrastructure that exists already for Linux and for the EDAC subsystem and everything else to engage in the error reporting, that we have kind of a common architecture strategy all the way from chiplets in the car to servers in the field, simply because it would make no difference to build it in a different way, but it drives everyone crazy. If you wake up in the morning and you read something in Linux here, and then you go to automotive and then something is different there, it helps if there is a common theme and a common strategy across how these systems deal with faults. But it is a complex problem technically and also human to get everyone on the same page.
Yep, I agree. Okay, we have 6 minutes left, but I would like to change slightly the topic. Let's talk about the future. And right now, the conventional approach to develop cars is to define the function, implement the components, software, system, and then we go. And the overall functionality is not changing during the lifetime of the vehicle. Now we are starting with software-defined vehicles, where we are basically preparing the infrastructure hardware for software application that may be added maybe in a few years. So still we don't know what will be the functionality that the potential will be offered. How do you feel safety should change based on this? And especially the ISO standard and the guidance. What is your view on this with this dynamic life cycle, a dynamic offering?
Maybe if I may start. So first of all, you say now the car becomes software defined, and I would like to comment that we also have this buzzword in industrial automation where we say software defined automation, and we have similar ideas, so that people want to bring software on the controllers in the factory for additional functions, like, for example, counting the number a valve opened or closed, so they can do predictive maintenance and things like that. And of course, we have the problem that these kind of software in principle can then interfere with the hard control software which is running there and which is responsible for controlling the plant processes, the real-time processes, and also the safety functions there. And this indeed is a problem. Of course, you have to think about separation of these things and making sure that there is no dangerous interference between these so-called add-on software with the actual control software. So, for example, if you are running it on the same microcontroller, of course, the microcontroller could be overloaded. There could be too much load if some bug is in this maintenance software and it's consuming too much processing power, and then there may be stops in the system because the actual control function can no longer be fulfilled. Yeah. And this is a challenge, but I don't have, of course, a easy answer to that. So I think the classical approach is of course to separate things by the operation system, but of course this is not 100% applicable also to real-time systems.
I think there is a limit how much standards can drive. What I'm curious in and what I believe in is that patterns will emerge. And I'm not just saying that because of the carpet here that I've been looking at for 2 days that has a pretty pronounced pattern. But when you look in, for example, in the car industry, e-gas is a pattern that emerged for a very specific problem in the mid-90s to control a diesel engine. And in many cases, you will find that people say, oh, we have solved the safety problem using an e-gas approach. On the other side, in cloud or in home computing, right, things like containers have emerged, not because there was a standard driving them, but because there was a problem and people got together and said, this is a nice way how to solve it. And what I think is going to be quite interesting in the next couple of years is at the moment, a lot of people are searching for what will the viable pattern be. And the interesting question will be in 2 or 3 years to get together here and say, okay, this is the pattern that has actually emerged in like a Darwin type race and has proven to be successful for everyone. And we're all part of it, right? Everyone who goes home and goes back to work is part of this search for the patterns. And I would tell you if I know how it looks like, but I know for sure that it will emerge.
Yeah. When we talk about pattern, then we can maybe bridge to artificial intelligence for monitoring functionality by recognizing patterns in the occurrence of complex fault fault situations. So as an anomaly detection for the state the system is in, and yeah, therefore getting, due to the huge amount of complicated data, really an analysis on the current state of the system.
Hey.
Sounds like an AI TÜV.
Yeah, I mean, AI we used we're using within pattern recognition when the system getting very complex to understand relationships, and that would be an analysis tool to detect based on data-driven the state of the system.
Yeah, the question: do we trust the AI for this? That will be the next step. Is it qualified to tell us? Okay, 20 seconds left. And anything you want to say to close the panel?
I mean, thank you. The discussion was good. We already had discussions yesterday, and we will continue them. So at least the panelists had a good time. I hope you enjoyed our discussion as well.
Yeah, I think it was really great. So again, thank you for joining to contribute to the panel, be on stage. And yes, so we need to close now, unfortunately. I know it was a nice ride yesterday and today. Again, I will not keep you here longer, so I just wanted to thank you for the attendance. I really hope you enjoyed it like I did. If you do not enjoy, don't say to anyone. If you enjoy, spread the voice. And please give it please give comments on whatever we can improve for the next time. So thank you again.
Okay, and the last word from me. Thank you. We also, from the organizer side, want to thank you all. And also, of course, thank our precious chairman, Ricardo. Let's have a round of applause for him.
Thank you.
So yes, thank you speakers for your presentations. Thank you participants for coming and for the discussion that we had and all the networking and for the energy. Also, I want to thank our sponsor, SGS Tuvsar, for supporting the event. Thank you very much. And yes, thank you. Thank you. And as it was already said, we look forward receiving your feedback. You can submit the evaluation form, or you can write an email or call us, any format that works better for you. And just a reminder that photos you can find either on the platform, it might be already be uploaded, or it will be sent to you in a week together with all the presentations and recording of what was happening during those days. It was a great pleasure to have you here, and I wish you a safe journey home. Have a nice evening. But that's not all, unfortunately. Can we make a group picture? Just quickly. I know that a lot of people need to run, so just quickly, one shot, and we all free.
So someone bring. I think if we have one row sitting, one row standing.